something crazy and try coding Java, like practicing Python and Java for 16 hours. My goal for today is like using Cloud Code and making it like a tutor for me. I already know like a programming. I know Java, but I need to practice. um, I want to learn some, hash map classes, some methods from string class, integer class, and even some maybe object-oriented programming principles applied in this language. And also, I'm learning Python, so um, it will be fun. All right, let's start with where we left off with Java. Where did we left off with Java? So wish me luck, guys, and check my Twitch too. Seems just fine, and open it on my phone too, just to make sure everything is right. So like I'm using a skill that I created earlier. This had like this is really good. All right. Instead of dumping the code and answer right away, instead um, it explains stuff and let me think about it. Let me check this one. Yeah, my my voice is not good at the moment because I just wake up. All right. Uh, the hour is too early, as you can see. Let me think. What was I doing actually? I think we have created some. Uh, I think for companies, no. Design patterns, no. This can be the the yes, the file that I created. So yes, so like because during some interviews I've seen that they ask like common methods from common classes of Java, like a string, integer, and yeah. So I think we should follow this. So I wanna follow this document, and also I wanna track. I wanna track the progress. So um, I think we have a skill, like where I can call checkpoint, and where am I? I think those skills are belong to uh, the adaptive project development idea. I want to have same thing here as well. So do we have that? Because in the interview topics um, folder, we're gonna take notes and we're gonna keep like we're gonna create a note for tracking our progress. All right, because it is a long run, it is a marathon, let me say. So is there a skill that we can use now, or should we create one? Let me paste it over here and press enter. And also, guys, yes, no, yeah, I can now. I see the green bar for audio. Let's wait for some time for AI find us, like bring us an answer. Good question. Yes, I know it's good question. Um, let's wait for some time too. So Let's read the file. Actually, the answer I think is ready. So read yes. So what does it say? Then a recommendation. The marathon track is well defined. Yes. Um, that's interesting. What is that? Integer wrappers auto like this topic is also asked during interviews like autobugs, alright? This is a common convention. Mm, practice. Yeah. Arrays. Yeah, 2D arrays, which collection table. Do we already have a SQL? Yes and no. They don't play yes. So I was using these skills for uh, like a creating large projects. All right, these are not designed for like a learning purposes, but instead building purposes. Zoom, checkpoint, zoom, where are scope mirrors of those skills that only ever touch. How do you want to progress track, plan file I maintain, or dedicated skill pair? I think dedicated skill pair we need to create. What should the progress ledger capture per section for an interview marathon? Status last touch date. Not started, studied, drilled, mastered, plus the date you last work. I guess like a studied, drilled. Yeah, that seems just fine. Uh, like we should keep these files like compact because as you add new features the like handling these uh, files can be cumbersome. Little code links link each section to actual Java file. No, we don't need that. Next station pointer. A single resume here. Tab so cold start is instant. So I think we can you know use that. Um, I'm checking my OBS setup and like you don't see that right top part. You choose dedicated SQL pair with minimal ledger. Status plus last touch. Yeah, we can make use of that. Like making cloud to behave like a tutor is the best idea ever because like you can ask unlimited number of questions. It doesn't get tired and it explains well. Like if you set up it correctly, it behaves very well. And the thing I like about Cloud, like AI in general, is that it can make um, online searches quite fast. So if you need to find something for any purpose, basically, it runs like search on web quite fast, like visiting let's say 300 pages at instant and bring you like let's say summary or the helpful useful part extracted from there. So it boosts you up, like it makes you quite fast or like while you are searching. But like here's what I built: a scoped tracking system that mirrors your existing. Uh, like I don't remember these skills to be honest, but that is all right. What now exists? The ledger I think. Um, Java, yes. So like we need this progress file, all right? Because it's gonna be a long session, guys. Start checkpoint. End of session save. Start where? Alright, so our skills are, I think, this one and this one. Checkpoint, like this is for project execution. Zoom checkpoint, zoom where, code walkthroughs. Alright. Start checkpoint, start where. Actually, this is, I think, this is the certification name. I guess this is the certification name, right? But actually, like, our goal is even broader, like practicing Java. Like, I'm gonna use this skill for like a practicing Java and for learning Python and maybe like practicing JavaScript, C Sharp, and also I started learning Rust, so I can use it, like use this skill for that too. So this skill should cover all of the cases, all right? So maybe instead of using CERT, like a CERT, maybe we should use another name for that. Like I want to see the checkpoint and verify like a where keywords in the name of the skill, but can you update the skill so that it is not only about Java? Like I want to use this skill. The goal, the goal of this skill will be like studying different languages, and like we should, like the user should show the the folder that we're gonna like save our progress markdown document, like a file, and then mm, I will be like you know asking questions and practicing basically. So can you update our skill? Because we're not gonna only study Java today, we're gonna study Python too. And also we have a tutor skill, so let me add this too. We have like a tutor mode 1 and tutor mode 2 and even tutor mode 3. So can you get the core idea from tutor mode 2 and insert here as well? Because I need this skill to teach me like tutor mode 2 while keeping track of the progress like checkpoint skill. Um, study is just fine. I guess we have, like we could paste the dictation and let me copy and paste it over here. So when you paste like a while the cloud is already running, when you paste another message, basically it changed the course of how the cloud works basically. So instead of like waiting until the cloud completes and brings you the full message, you can send another one and you basically direct it to the point where like you want actually. That's, I thought this it wasn't helpful at all because like making changes on the go, like it is error prone based on my experience like in programming languages. All right, you should go you should go with clear steps, but for AI, it can understand and it can direct itself. The study skill should teach a style, graduated hints, senior question here, and track progress. Let me read Thermal's core so I extract its actual protocol rather than approximating it. Thank you for that. I guess the stream is just fine too. and let's wait until it completes, until it creates our new skill. Like, of course, I could use tutor mode skill, like a tutor mode 2 skill, but it doesn't create the progress file. Or maybe I could make that tutor mode, like a that skill, to create those files for me. The teaching style and saving checkpoint style are genuinely different actions, so naming a single skill checkpoint but having it teach would make the same lie. So I'm building a trio that keeps and adds teaching entry point, it says. So the session teaches the next unit, tutor mode 2, style graded yes. Standalone save writes progress to that folder's progress. Yes, we need them. We need it too. Alright, let us wait for some time until Cloud completes. And I think while it is doing its job, I think. Oh my god, why it opens like that? New terminal. Alright, I think we can make use of it too. And Cloud here. And find. Can I copy the relative path? Yeah, so paste it over here. Now I want to practice this, so give me a topic from this file and let us start. And also activate tutor mode 2, alright? Tutor mode 2 skill. Oh my god, tutor tutor mode 2 skill. This is what I meant. Alright. So that we don't lose any time. I haven't tried this one yet, but I really want to try that command, like a goal. Like you give a goal to AI and drive everything until the requirements satisfied. So like that seems quite interesting. I've got your learning trigger loaded. I think this skill also has like a tracker, but I don't remember. Comparator custom sorting, it is the highest leverage interview topic you haven't drilled yet. Like these are the big companies in Turkey, and it connects to something you already know. Comparator is reverse order you use for the max heap in heap sort. What we are building? Of intervals by start ascending, then tie break by end descending. Concept you practice comparator chaining. I think I can start this timer too. Alright. Let me check the new skill we are creating. What you now have, tutor session bound to track. Wonderful. So I think we have this, but what happened? Oh my gosh, why this opens terminal like this? New terminal. Again same. And when I do new, like what happens when I click on split terminal? Why? Alright. We can create new terminal window again. And then run this. Alright. I don't know why this happens, but let's not lose any time. Copy that, and maybe I can move this to another window. We don't need that. Open this, paste it. I'm gonna study like Java, all right? And like there is another file called Java core method reference. So while following that document, I need to practice Java. Activate study skill so that we can track the progress. Like the name of the skill is study, but what was the checkpoint progress? This seems very nice, but I wonder like which skills should I use for this new skill? Like we have study, and then like what is our checkpoint and where am I skill? Like the UI is messed up again, so I think here it explains. Start of session, study where, like study and study checkpoint. All right, so and at the end of the session, we're gonna run this command, and when cold start, we can run this one, and during the actual teaching. All right, so let's give it a try. I'll start by resolving the track folder and reading its progress ledger, resuming. What we are building, the try it drill. Like what is that? I don't know yet. Reverse the words the quick brown fox so it becomes fox brown queen D. The concept will practice. String is immutable, yes. In Java, string is immutable. And you have split indexing and string building to recombine. Picking the right tool is the whole exercise. First, the question for any code. When I say reverse the words, not the characters, yes. What's the very first operation you'd run on that string to get something you can work with? I think what we should do is like getting each word, right? We should split basically. So you asked a very nice question. The first move, like a first step that I would take would be like a splitting this oh my gosh, why it's splitting the string, all right? But I don't remember the split method exactly. So how should we do that? Like let's say this is string s1, all right? And what would happen if we do like a split? I mean, yeah, maybe like this, or like there are two like there are different ways of calling this split method, all right? Let's say let's say if the split method is inside string class, and if it is static, like, and maybe like this can return an array basically. I cannot see this part. So like maybe this can return an array of words. Maybe then we can we can use something like a string array, and let's call it array. So like this is the first way of doing this, and this is the second way of doing that, all right? So now we should check which one is correct basically. Like in this one, we act as if the string is object here, and in its class, like in string class, we have this like a reference type. But here we are using it again string class, but assume that split is static method. Right, split is the move. Now the second half of my question, because it decides everything downstream. When you call, I forgot, like I forgot the split operator. So imagine you have a string, all right? Let's say A, B, C, all right? And then let's say X, all right? And then D, E, F, all right? And then another X and G, H, or M, all right? So let's assume this is our string. So if you want to have something like A, B, C, and like in an array, all right? A, B, C, D, E, F, and G, H, M. All right, let's assume. And you would need to use like a split parentheses and X, I think. Like this is the split operator. So we need this information too. Here in this example, like we haven't explicitly indicate the operator because I forgot. So basically this makes this option invalid because here we don't indicate the operator, but we need it, right? We need it. So I guess the correct way is like a calling split method as if like a reference type. When you call the what type does it hand back to you? Not a string anymore, but what exactly? It returns an array of string, like why I cannot add these bracket. Yes, it returns an array of string. Let's add a comma after here. Let me also check the activity monitor. Seems nice. Exactly. Oh, hola. Welcome. Welcome, Americano. Welcome in. So, today we are studying Java. We are studying Java and Python today. Exactly, the string array. So now we are holding yes. Go ahead and set up the skeleton, a class with main, the split, and the store that array. Tell me your plan. Alright, so I guess I don't, but let me. Yeah, microphone. Yes. Today, we are doing we are studying really hard, okay? So we are not doing like a study with me session, but instead like a real rest lesson, alright? So they gave us a string s1, and I think it was like a real string, like this one, I think, and like a kinesin ships it. And then what we need to do now is to basically split. So after the split, we will need a string array. Let's call it output. All right, and s1 dot we need to split it, right? And now we need the operator to, like, the split operator is space. All right, because we need words, and in each word, like between each word, we have space. So this will give us each word here in output, like a maybe word, maybe we can call it. And what now we need to like reverse the words. So how do we do that? Like a basic approach that comes my mind first is like using for loop. We can create another string array, and then like by iterating like in reverse order, like an integer I starts from not 0 but at s1 dot length. All right, length and also like a minus. We can go in reverse order and add the element. But yes, this is it. I'll run for about 4 minutes to buy ingredients. Yes, for sure. Alrighty. So like this is way, but I think there is a better way. Like there should be a better way. But let's first do it, alright? Because doing the first thing that you have in mind is the way during the interviews. So yeah, we have our for loop, or maybe but if we use for each, we can't do that, right? Like using this type of for loop allows us to go like from like a left to right or right to left, but in for each we cannot do that, right? um so I should bigger than 0, right? No, actually should be greater than -1 actually. So actually, and also we shouldn't start I from this, but instead -1, like a 2. Let's say like our length is 3, we should start from 2, 1 and 0. Like I will write this one, but I think this isn't correct. Interesting, quite interesting. Like we should have numbers 2, 1 and 0. It starts at 2, and then one decrement 1, and then one decrement 2, and then again. Yes, I think this is correct, but like this is the first time I realized like this is -1. So let's go with it. And we need another words or reversed words. Let me call it this way. And it should be length of s1 dot length. All right, and what we're gonna do now is like a reverse words index I. Index I, but we need another parameter over here because we like because this should start from 0. So maybe create another parameter j, start from 0, right? And let's make the character like a word at index j equal to words index I. Like, of course, there is a way to use multiple uh, parameter, like a multiple variable inside the for loop. And let me try that. I haven't tried before. So like, was it comma? Or let's try this, alright? And then we can make it better. Um, so we are setting like a reverse in reverse order, and also now we should, of course, increase the our parameter I. So now we have our like our reversed array. So maybe I just can call system out print ln and initialize our for loop over here. I smaller than reverse dot length, and then increase the parameter, and what we are going to print is like its indices basically. And let's give it a try. All right, will it run? No, of course. S1, this is a string, so I should actually, what I meant to use was not S1 but the words. Sorry for that. Yes, wonderful. So we got our first error, index 15 out of 1 for length 3. So we have something wrong. Oh, like we used S1 again here, but again it is words I meant. And since it's an array, we don't need to use parentheses. Yes. Now it's compiling, but it takes too much time, guys. Is there a problem over here? Oh my gosh. What is happening, guys? What's going on? A timeout after 30 seconds. So I think in one of our loops, let's make it bigger than 0. Like we iterate through like a reverse words here. Like I should be close, like smaller than the length of this array. So like I don't see anything wrong, but we are obviously missing a point here because like it takes too much time. Like we have a string, we split it, we get its each word like a kinesin ships. It's like a three words. All right, we create another string array to hold the reverse version of it, and we are like iterating in reverse order, like the words array, and write the position in the reverse words. So this seems quite good to me. Like I don't wanna spend too much on small things. So I have tried it, but it gives me timeout after 30 seconds. Um, why it is that happening? Why is it happening? Like the code seems uh, quite good to me actually, but what is wrong with that? Let us ask this. So like our code literally seems good. I checked each line, good instinct to question, but the code isn't quite as innocent as it looks. Oh my gosh. The timeout is the giveaway. Yeah, so look at your loop and count how many times I changes in a single pass. Oh my gosh. Guys, the parameter is I. This should be J. Sorry, man. So like since it's too early, I like um I have my reasons, all right, to make these um mistake. So let me open that one. Hold on a second. Excuses, excuses. I have my excuses, right? So it ships kinesin. So yes, so it is basically correct. It is reverse order. Thank you, thank you. Like it is early in here. Here it is. It is too early here. So that's why I think I did that mistake. But I intended to use J obviously there. So there is no issue with that. So now the more important question is like this works, like this functions, but is there a better way of doing that? And also, what was our goal with this example, basically? Like maybe usage of split method, right? Because I forgot its use, like its operator, basically. Because in the morning, what I was thinking was like should I use like should I call this split method using the reference of an object, like a string object, or if is the split method is a static method of a string class, all right? And we like I give the string as a parameter, like a like a string class dot split, and in parentheses I give the string that I wanna split. But I forgot we needed an operator, all right? So so the static option is now eliminated, but uh, again, this method could be written as static still. In that case, it would need another variable, variable two, all right? Like we could write it in this way too. So what holds us doing that? Like I'm asking this from like a object-oriented principles because Java and object-oriented programming like go hand in hand. So can you clarify these, please? So I strongly believe that adding please at the end of the like our message, we fill cloud with positive insights, positive feelings. So it answers better. Like it is not of course real, but this is what how I give commands to cloud. All right. So like the question I ask is though quite important because like you can design your language, all right, like using this approach or this approach. Back, by the way, what challenge is this? The challenge um, is this actually like we have a string, and the question is like creating its reverse version, reverse, reverse. The challenge is this. I use basic for loops and split method actually. So in Java we have split method, and today I review like we studied again that split method takes an operator as a parameter. Like this operator dictates us like how to split our string. So it is quite important. in the beginning of our session, I didn't know that, like I didn't remember that part, uh, and now I just reverse word order or character, word by word, word by word, not fully character, because otherwise, like you wouldn't need to use split method. Like our string is like a Kinesin ships it, and the reversed version is like a it ships Kinesin. All right. This is the reverse order by word by word. Now the question I ask is um, like you can call this split method, like imagine you have a string variable, all right, and like you could call this split method like this, all right, or like split method could be a static method, like a static method of string class, okay, string class. So in that case we would use like a string dot split, and we would give the our string and then the operator. Like this is one way of doing that, all right, this is one way, and this is another way. So now I ask that, like what is the design reasoning or design decision behind designing this method, uh, like this one. Let's see. Great question, thank you. You nailed the diagnosis yourself. Let me clarify the object-oriented part since you asked directly, then nudge the better way. Why split is an instance method, not static. Yes, so like we are discussing this. Why split is an instance method, not static. Like, do you have any idea, Americano? Like, what would be the reason behind that? Do you have any idea? Empty here. Um, like imagine like a. Do you know the static here? I mean, first, hmm. You know the static keyword, right? You know the static keyword and how it behaves. Do you know it? Like, what is static mean? What does static mean? Like, we have our methods. Yes, sir. About it. So, can you tell me in like in a few words, in your words? Like, we have our methods. While we are typing that, I'm explaining another thing. So, we have lots of methods everywhere. All right. Like, let's say we create an animal class, like public. So I guess this one, right? So we class, like we create animal class, and in it we have, inside it we have methods. Static immutable? No, no, no. Immutable is final keyword. After you assign a value to a variable final, it cannot be changed. You cannot change it. It is final. Final keyword. Static. All right. So imagine you have like I written down here. Like imagine you have method over here. All right. So let's say you have a method here, public. Um, let's make it return, or even make void. All right. Public void method one. and you define its inside. So how do we call this method outside the class animal? How do we call it? So let's say we are in main public class main, all right, another class, and we need to call this method one. How do we call it? How do we reach its definition? I want to call this method. How do we do that? Americano. How do we call method one? How do we call method one? Create a constructor. Sorry. No need to be sorry. So constructors are for classes itself. Actually, we're gonna use that constructor, but we're gonna use it for creating an instance from this class, all right? We need an instance from this class to reach this method, all right? And since it's public, we can reach it. So the way to call this method is, you are correct actually, by calling its constructor. So animal, let's say bird, all right, new animal. So like this is the constructor actually, but like we are initializing an animal object. Like this is object, this is in our heap, this is the object we instantiated. Now we can reach the method one via using the reference, like the object reference, all right? So bird dot method one, like, is the way for calling, all right, Americano? You could use this method only if you have a reference that you created from this class. Like this is bird object, like any animal basically. You need to initialize this object in your heap. So this is one way for reaching this method. So another way is a static. So you could create another method, all right? But this time we're gonna use static keyword, and let's see how, like, what would happen. Like a public, this time static, and again void, and now let's call it method 2, all right? This is the static method. Like as you can see, we have static keyword here. So how about this one? How do we call this one, Americano? How do we call this static method in another class? Okay, we are in main, we have our animal class, and we wanna call this static method. How do we call it? How do we call method 2? How do we call method 2? So since method 2 is static, we don't need to initialize an object of animal class, but instead we can directly call that method using the class name itself. So here, like in the first approach, and this is the second approach. In the first approach, we instantiated, I think. I don't know how to write. Instantiated an animal, like an animal object. And in the second one, we don't have object reference, but use class name instead. This is about static. Oh, so adding static tells anyone trying to find method 2 that's an animal, so you don't need to instantiate animal since it does automatic. Yes, exactly. This is what static keywords does. All right. So now the first thing that should come to your mind is, then why not we make all the methods static so that we don't need to initialize at all? But of course there are some reasons. All right. So this is the question that I ask to AI as actually. The like we have a split method. All right. Our professor never explained this and just told us we will understand later. All right. Yeah. So I don't like the way they teach, but I understand because there are tons of topics. All right. If they try to explain everything, like there is no time for that. So the students should search for them in their free time. I mean, in their study times after the college. So we have Americano, public, class, string. All right, this is string class. So in Java, this is default. All right, in I think jar, the string class. So in string class, we have a method called split. All right, but is it like should it be a static, or should we create an instance of string class and then use this method? Like is it like a public static and what it returns? I think array, but I think string array. All right, public static string array. So like should it be this way, or instead of static, public, again it returns string array, like this one? Like should we use basically static keyword or not to reach this method outside of string class? But what is the reasoning behind whichever option? Like the option, like the usage, the real usage, like in real string class, we have this. It is written in this way, like it doesn't use static. And but why? We could use static keyword. So this is what I asked. The principle is encapsulation. Behavior lives with the data it acts on. Like this is something we should save. So let me maybe open. I guess we had like I have some Java learning. Let's pick this one. All right, let's create. Which should we? What should we create? Let's call it general. I don't know, or this. Add a mark. That's a string. And here I just want to save this line. Like, this is quite crucial. Like, this explains a lot. The principle is encapsulation. Behavior lives with the data it acts on. So using the data, it says, like, we're gonna understand it, all right, guys? So let me take a screenshot of this part 2 and paste it. Let's see. String object owns its characters internally a byte. So yeah, when you write like using the object reference, it says like this is a string object. You are saying this string split yourself by comma. Split yourself. So like split yourself. The method already has the data it needs. Yes, like it is this, like this keyword. All right. There is a receiver, so the data and the operation are bundled together. Yes. So like another word is like this is the reason actually. Like we could design the split method other way around, like using static keyword. But the reason why we use like a reference, like a string reference, is like string holds the data, like the object reference, like object itself holds the data itself. All right, this is why we designed this in this way. All right, save it. So I get it now. I get it now. Your static alternative, like this is the static alternative. So static is what decides if the data is carried over or not. Actually, yes. So if the object like has the data itself, you can call it like a creating by object. But if it doesn't have the data, then you can like you can create that method as a static. Like I'm gonna show you example like a static methods, and you're gonna see like you're gonna understand. Let me show you now. Like there is method in Java. Oh, I think I partially get it now. Like there is class called math in Java, all right? And um, like I'm asking you, Americano. There is a class called math, and inside it there is a method for min, all right? And this min method is like takes x and y and return the minimum of these two, right? Like this is what it does. So my question is, should we design this method as static or using instance? What would you do? How would you design this method if you are the author of Java? All right, design it as static. Yes, yes, because like you don't need to hold any data. Like all function. Congrats, by the way. All function, like all job it does is like comparing these values. Like you already give these values as parameters, right? Like these are parameters, all right? You already give them. So the function of this function, I mean the operation, is like a comparing and doing that job. So you don't need to instantiate. So this is how we call this method, all right? This is how we call. And even better, let me I think, can I open? Oh yes. So show me math min func in Java. As you can see, like this is how we call it. Like the class name, and it is static, so that you can reach that method right away, and it returns the minimum of them. So well done, Americano. Uh, so your static alternative string splits is the procedural C style. Data and function kept separate. You pass data in as an argument, so it works, but it throws away the whole reason objects exist. The data wouldn't belong to anything. Intelligence plus one. Wonderful, man. Like Americano. The reason why I'm studying this like a string class and integer class, because in one of my interviews I've seen these questions. All right, they asked a certain method. They asked which method belongs to integer class, or like it was like which method doesn't belong to string class or integer class. So I thought, how on earth am I supposed to know which method those classes have or like doesn't have? Like you may say the same, but these classes are quite essential. All right, like a string and integer, the same, like a simplest thing. All right, and if you wanna be a Java developer, at least you should know like which methods they have. And fun fact, actually, let me. I think I cannot do this right now, but I can ask AI. Like there is a what's security? No, 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 no. You don't need to secure you don't need to be secure at all. Uh, for example, look at them. Like we have length method, split method, and to uppercase. So let's take to uppercase as an example. Like we have a method of what was it again? Uppercase to uppercase. So this is a method, and what it does is like return like a if we have like a kinesin as a string. So if we call it with this method uppercase, all right, what it returns is this version. So like since the data that this function uses is the object itself, all right, we use like a we like a, this is a we don't design this as static, because if we do that, like if we design this method as a static, then we would need to like a string dot to uppercase, all right, we would need to pass the name like a kinesin as a parameter. So since Java is object-oriented programming language, we make use of it, all right. So the cases where we use static keyword is like a small number of like a small areas, all right. For most of the time, we make our method like a reference type, like an instantiate. So for example, we have to uppercase method, split method, and length method. Like these are instances, all right. Like these methods are called using instance. And we have some static method, like a static method too. For example, integer parse int. All right, so like you're gonna use this method a lot, like a to parse int. So there is a method parse int, and what it does is, I think it takes a string, like a string, but it is kind of number, like this is string. It takes a string and returns its number version, like its integer version. So for this method, it is not static, it is instance. So I mean, it is static, sorry, it is static. Why? Like, do we write integer like this, right? Yes, integer. So this method is static because like the data, like a 42 is string basically. So like you cannot do this. Like for example, if this method wasn't static, but instead like a instance type, how would we write it? Like we would need to create an integer object. Like a, let's create it like an integer I, like, or let's say object. All right, new integer. All right, we created it. So and then using its reference object, uh, parse int yes, and then we would need to like give the 42 yes, and it should return um, the real number, like a real integer answer. um, so we created an object. Like I'm thinking what would happen if we design this method as an instance type, not a static. We would need to create an object from integer class and then use this method using the object reference. So this would be the way. So like we can do this basically, but why shouldn't we use it? Why shouldn't we design in this way? Why is this a bad practice? I guess like Americano, wonderful question, all right. Why don't we use like why don't we design the parse int method like this way? Can you explain why don't we design parse int method like this way, not static way? Yes, think. And also I will ask, what is the concept called? I mean, static versus instance. Imagine like there are two methods. One is static, one is instance type or reference type. So how should I call them? What is the convention? Think, Americano, think. Terminology, yes. Instance method, static method, instance method. Wonderful. Instance method, static method. So our question is, why shouldn't we design parse int method like an instance? Yes, instance method. Why should we use should we design it as a static method? I have one idea, so that's why I asked. So 10, 9, 8, 7, 6, 5, 4, 3. You give up? 2, 1, 1.5, 1.4, 1.3, 1.2, 1.1. So you type it. I maybe I can read the answer while you are typing. Why split is an instant method, not static? The principle is encapsulation. Behavior lives with the data it acts on. A string object owns its characters, like it owns its characters. Yes. When you write, you are saying this string, focus on this keyword, all right? Because this is the object itself. Split yourself by comma. The method already has the data it needs. It's this. There is so like now I see the meaning of this keyword better actually. Your static alternative, like we said that why not design split as a static method? Actually, it is written in C style, but in Java, since we are in object-oriented world, we take advantage of using this principle. Data and function kept separate. Like in C, data and function kept separate. You pass the data in as an argument. All right, here's my answer. So basically, it is because it's simpler. Actually, kinda, but the answer, like the idea I have is like in integer class, like most probably you haven't seen an integer class, like, but I have look into it. All right, like the integer class, like a public integer class, all right, has tons of methods, all right, like tons of, I don't remember them all, tons of methods. Let's call method 1, method 2, method 3, method 5, all right, and it has also some fields, all right, field 1, field 2, etc. all right, tons of fields and tons of methods. So if we designed this method, what are fields? Fields are like variables, basically variables for the class itself, all right. So when you create an object from this class, you can use these fields. Let's say you instantiate an integer a, and if there is a field, let's say called field 1, or we can call it variable 2, like a variable 1, like we can assign it to 2, you know. So when you instantiate a class, like when you instantiate a class, you create everything, like fields, methods, all right. So it consumes some space on heap. So for this type of operations, where the only thing you do is like you don't need the data but the function itself, instead of instantiating, like using a static method is a better option, so that you don't create another object on your heap, so that your memory doesn't get crowded, let me say. So but for some objects, for some methods, you need object reference, because the data, like the object holds the data so that you can use it. All right. So, like for example, split method is an instance method because what we are splitting is the object itself, like a string object itself. Oh, so instantiating costs memory since it copies everything, yes. Whereas using static makes you just exactly, 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 bro. Exactly. So, like you may say, then use everything static. Why care about making methods instance type? Because like there's a logic behind it. All right. If, for example, yeah, you're gonna calculate length. Length of what? The string itself. So this method is instance type. Because the data, like it holds its data, and same for split. So same for uppercase. So let's say we have a string, and to make its letters like a to uppercase, which data we are working on, like that's a trig object itself. So, but whereas in, let's say, calculating absolute value, or turning like a string into parse, like a turn integer, we don't need an instance of integer class. Like this is core function. All right, let's continue. Rule of thumb: instance, when the method works on an object on state like this, like, all right. Instance, when the method works on an object's own state. Static, when there is no meaningful instance yet. Factory methods, it means parsing value of pure utilities, like this is utility, or things that produce a new object from inputs. All right, all right. This is a good rule of thumb. Let me take a screenshot of it and paste it over here. C contrast. Since you look like the cross-language anchor, yes, in C there are no methods on data, so you'd call a free function exactly your static version. Java could do that, but those choose encapsulation. So the method we are using is also called encapsulation. So we encapsulate the data. Actually, this term is used in different ways and in different cases. So I didn't internalize this concept fully yet, but it is good to see it now. Is there a better way? First, what was the goal? Producing the single string. Like our goal was like in the beginning of our question, our goal was like this is our string, and our goal is reversing like a in word wise. But look at your output. All right, so like I asked, like this is my answer. Like we split our string into words and looping, in reverse order, and saving in another parameter like a variable is the first thing that comes to my mind. I ask, is there a better way? What was the goal? Produce single string, yes, but look at your output. Finish each word on its own line. All right. So like this is not important. All right. I think it is important because like the question was asking to create. Like I choose this option to see if it is working or not. So our goal, actually I am doing this, so I need to guide the AI correctly. Two things to try. Don't write the manual J. Which static method from the reference glues a string array back together with a separator? You literally just mentioned it above. Bonus. There is a way to reverse the word order without allocating a second array. Yes, like this is what I meant actually. Without allocating a second array, because there must be a better way for sure. Without allocating a second array at all. Using plus one collections. Call. What do you think that call is named? Which static method from reference? From the reference. Take a crack at rewriting the bottom half using number 1. Let me copy the code again and paste it again. Actually, AI gives the answer here, but like this is my new version, but I didn't understand what you mean. Like, of course, there must be a way where like we don't allocate another array. All right. I think I need to find this, but I don't know it. I don't know it because I don't know the methods of string class fully. So it is a good practice to know the methods of this class basically. One thing at a time. Let's nail the recombine first. Then I'll show you the non-array trick. You got reverse words fit correctly now, yes. You need to turn that array into single string. The question asks us to return a string, not a string array base, because we have the array, so we need to create a string using that. How do we do that? Like, all right, so it is time for converting string array to string. Like, these conversions are quite popular. Like, we do this all the time. Oh my god, I didn't start the anyway, so maybe I just skip this one and the break. Yes, so like we do these conversions all the time, like string to integer, integer to string, integer to integer array. So like we do this all the time, but I don't have any idea how to convert string array to string, like, because strings are immutable. So let's say if we like instantiate a string object and then add the cars coming from this string array, but this wouldn't be a correct way. Like, Java should solve this issue. All right, look at this line from reference. All right, how can I position? All right, I think this is better now. Look at this line. Like, you got reverse words filled correctly now. Yes, like I have this array. You need to turn that array into single string. Yes, like this is our goal. Look at this line from reference, the split join block. So there's obviously a method in string class which is a static. It uses an operator, I don't know why, and parts, and it connects. But what is parts here exactly? String join takes an operator. I think we can go like after completing this, we can go in and check how the Java implemented this method, because we know the string object is immutable. Like actually, but string object or string primitive, which one is immutable? Let's see. Like let's first ask me this. So I know that string primitive is immutable, right? But is the string object is immutable too? Let me ask this first. String join takes a separator, an array. It takes an array and welds the pieces together with the separator. What separator do you want between words? I want a space basically. What array are you joining? String result we have what array? So like the array we have, like our array is reverse word, so we need to, you know, turn this into a string. So this is our array. So it says that we can like use a method like a join or something, right? And our operator is like a space, and then the array we're gonna like a turn into is this one, and this is gonna return an array like a string. All right, let's call it string 2. Isn't string and string object the same thing? Wonderful question you ask. Like there is primitive version of it. I mean, actually that's a good question. Like integer is primitive, boolean is primitive. What else? I think string is not primitive, right? Car is primitive. You're right. Like you asked wonderful question. String is reference. Yeah. I think yes. So string is, but I remember something about string that they are immutable. So, but if it's an object, so we can change it. Like we can change its values, its fields. So quick correction on the framing because it matters. There is no such thing as a string primitive in Java. Sorry, is always an object. You're right, Americano. String is always an object. Java has exactly 8 primitives. Wow. Byte, short, like int, char, and boolean are the ones that I remembered. 8 primitives. Intelligence, alright. Wonderful. Like string is not primitive. String is complex. Like from the perspective of like a language, like a Java language, or from a computer. Like these are simple things, all right. But the string, like for us people, string is like for me at least. Like if someone would tell me string is a primitive, I say okay, but actually it is not. Why? Because like let's say kinesin, all right, and let's say it is a string. What is it consist of? It consists of characters. So we should first design what character is, all right? Like this is primitive, but this is not. Because you can divide this into characters. What if string is just an object that combines an array of characters, then it just uses final to make it. Like, bro, are you professor or something? Are you like a genius or something, bro? Huh? Yes. Like it is this way. So let me make a search. What is string class in Java? Or string class in Java. I mean, how can we, like, this is not what I'm looking for. Like, I want to see the literal string class. How can we do that, man? Like I want to show you. Maybe I should turn the server on, right? And maybe let me, I don't know, how can I open string class? Like, we need to see it by our own eyes, all right? Like, diving into, yes, because I've seen, like, once I opened that string class and saw something like what you just said exactly. Just an like combine an array, like combines an array of characters, all right? uh, all right. mm, can you create a documentation of string class, like a string.java, but in markdown document, so that I can open it right away next time? So look at it, bro. Like, wait, like, I'm gonna show you. I'll base it on a real string Java source, so signature artifacts are accurate. Real GDK, not made up proof. Yes. So I'm making AI to extract this string class, like a public final class. Yes. And is it that voice to text a built-in feature? No. Is it a, is it is a search software? Um, it is voice ink. It is open source. It has its own paid version too, but it is open source. You can download it from GitHub. It uses 500 megabytes model, and it works quite well actually. It is open source and you can use it too. I think it works on Windows too. Like, I'm not sure, but it can be maybe for Mac. I'm not sure, but this is the program I'm using. Uh, let's yes, it's megabyte. The future is like a small like small language models, bro. Come on. All right, I guess we have it. Are you ready, Americano? So this is our string class, public final class. Like, it implements some uh, interfaces. These are not important for now, bro. Are you do you see, like, do you see this? Private final byte. So basic, it is characters. Yes, line 16, the value. So, like, this is it, bro. This is it. This is what you just described, all right? But see, recognize that it is not static, all right? It is private, so I mean, we don't use static keyword here, so we need its reference. So we need to instantiate this class to reach this field, basically. And see, it is final. So since it is final, it is immutable. So you never use static on private? No, you can use it. So, like, that's why I changed my saying. You can use it. There is no problem with that. if you use static, then you won't need to instantiate that class. Yeah, yeah. I changed just after I said, yeah. So like private and static is not like a non is not mutually exclusive. So this is the string class. uh, but for the maybe next stream, I will handle how we can open the real string class. All right, currently I cannot do that, but that is enough for today's purposes. Let me turn that off. All right, now where were we? We have our string. What was the question again? So when you write, yes, Kinesin is a string object. It lives in the string pool. So in Java we have this, all right, string pool. This is important too. And S is a reference pointing to it. Like this is basically a pointer, all right, points to this label, like this pool thing, the thing that is in the pool. There is only one thing here. It is an object. So that string object is immutable. Its internal byte is private final, and every modifying method, like to uppercase, replace, substring, string, returns a brand new string that leaves the original untouched. Wonderful. So string. So when we use this method that makes each character uppercase, this returns a new hello. It returns welcome. It just works okay. Welcome in. So today we are studying Java. So that's how it does it. It doesn't change anything. It just clones it a new thing. Yes, yes, yes. So this stays in our memory, I think. Returns hello, but S is still hello. Yes, hello unchanged. So to keep it, you must reassign the reference. All right. So alright, so I guess that's why we are creating, okay, this one. So we have an array of string and we need to join them. So this method returns a string. All right. All right. So if we print it, then we're gonna see the reverse version of it. That's nice. A cheap Kinesin. So let's continue, man. This is exactly why split, join, substring, etc. all hand you back a new value instead of mutating in place, and why string builder exists for when you genuinely need to mutate, built in a loop. All right. So like now, the next question. What was it? Yeah, it were no array trick. So the no array trick is using this join method. I think we can create some sort of cheat sheet or something to memorize them actually. But now we know the core logic behind it. Strings are immutable because it has a private final byte array, and when you want to change it, you basically create another string, and this join method returns it. And you can ask why this method is static. It is because like it only operates, like it does what it does is just a function. It doesn't really need the data of the string object itself. And For the ones that we pick the instantiate version, there we need the data, like an objects data, all right, which, for example, split method. We splitting this string, you as we see like a space, all right, but the data is itself like a, this is the string, all right. So we use, like, we applied reference instance type approach. Here it is static, here is instance. Hi once more, hello, hello, welcome in, welcome in. So now the next question is, guys, how would you design like a, like, imagine you have a for loop, all right, imagine you have a for loop and you have a string, all right, let's say it's s2, all right, but what you need to do is like updating this s2 frequently, all right. And what would you do? Because in each update you would need to create another string. So hello, hello TV Josh, welcome in, welcome in, we are studying Java, welcome in. So Americano, you got this part very correct. So like, imagine we need to update that string like in for loop, all right. Let's say this runs 1,000 times, all right, let's say 1,000 times. So if it runs 1,000 times, so we would end up with like creating like 1,000 new strings, right, 1,000 new strings. So this doesn't look right. Like, imagine you are building a string. Let's say you take an input from user and you are like just creating, or like by adding each character or something. So like, since the string is immutable, you would end up with creating 1,000 string things in your string pool. So this doesn't look good. So but my question is now, imagine like I need to, like, we need to create a string or something inside a for loop, all right. And since string is immutable, what we would end up with is like creating 1,000 new string in string pool, right? Let's say that for loop runs 1,000 times and we update, somehow we update our string. So what I wonder, like what we wonder is like, how does the string builder class solves this issue? We really wonder it. Can you explain? If you want to mutate a list of characters, you could use a character. Yes, but um, we are using string object for it. So we don't have a list of cars, but instead a string, and we are updating a string. This update operation costs a lot because we create a new string object, like a Java creates new string object. Is there a way to append strings without making it a character array? So actually, this is what I'm asking, like a similar thing, because string builder class handles this, but how? Yes, this is exactly trap reference flags, concatenating with plus in a loop and square time complexity. Let me show you why it's bad and how string builder fixes. Yes, like this is what we are looking for. First, a small correction. Runtime plus concatenations do not go in the string pool. The pool only holds compile time. Wow, literals. And explicitly intern strings. Wow. Strings built at runtime land on normal heap as garbage. But your so alright, so they are in heap. Why plus in a loop is unsecure? let's assume we have a string, all right, string object, and 1,000 times we are appending it. The, each of these operations a whole new string by copying all existing characters. Yes, because string is immutable, s plus I cannot append in place. Like it cannot append in place. It must allocate a new character array of characters big enough for old plus new. Yes. Copy every character of the old string into it. Yes. Copy the new characters, wrap it in a new string. The old one becomes garbage. Yes. Iteration 1 copies one character. Iteration 2 copies two characters. Iteration 1,000 copies 1,000. So, oh, wow. All right. So, and square. So plus 1,000 throwaway objects. Wow. Like this shouldn't be this hard. I'm gonna read in just a minute. How string builder fixes it. How string builder fixes it? String builder is mutable. Internally, it holds a single resizable. It holds single resizable character buffer. Same idea as ArrayList. Maybe string builder is just that, a method that does automatic. Yes, it is, and we're gonna see how it does. Love me a good string builder, though I don't know if Java has some reference or mallocation. Potentially, you might just want to allocate a new array of characters, the size of some buffers. Yes, so this is like without the string builder, this is what happens when you try to append a string. This is very costly, and it is on NSQL. Yes, that's how string builder works. It was an array list. Actually, it seems, of course it is. I mean, I would heavily die if it wasn't a vector. Let's see. A string builder is mutable. Internally, it holds a single resizable character buffer. Same idea as array list. Array list. So we instantiate a string builder over here, and again we have a loop 1,000 times that runs 1,000 times, and we append writes into the existing buffer. No new object. No new object. So, we basically after we append all of them, we convert string builder into string using this method. Materialize one string at the very end. Append writes the new characters into the existing buffer. No copying of what is already there. No new object per step. Alright, but how? When the buffer fills up, it grows. Oh my gosh. Roughly doubles its capacity. But what is the initial capacity then, guys? What is the initial capacity of string builder? Let's say 5,000. What is the initial capacity? And copies once, because it doubles. Those growth copies are rare, amortized, or one per append, or n total. You pay for one final string allocation adds to string. Yes, the whole loops goes from n squared time plus n garbage object to on time plus one result object, from n squared to n. The Mendel model, like a string append, rebuild the entire wall every time you add a brick. So this is what it does. But string builder solves this by keeping laying bricks on the same wall. Only take a photo. But this doesn't explains very well, alright? Because I think what I need to see is implementation of string builder. Let's ask this. Can you show us the implementation of string builder because you are saying that same idea as array list, but um, and also you said that it holds a single resizable array of characters, so buffer. So what is the initial size of it? And also, um, like if like there can be sometimes like there can be times that, let's say, we append only one or like a once or twice, all right? So what I mean is that this buffer, like we may not need this buffer. Like I guess it is kind of big, all right, not small. Like the example we used is like 1,000 times. Let's say like a 2 times or 3 times, all right. In that case, using the string builder, um, like maybe expensive, like more expensive than using like a normal string, right? But I guess in real world, like in big systems, like there are like tons of read and write operations, like a million or billion times. So in that case, string builder is obviously the better option. But what I need to see is how string builder, like how is it designed, and what is buffer over here, and how it works as like a array list. Like I need to see it. And also, can you please mention about array list a little bit? Um, as I suspected, it is indeed a character array. Mm-hmm. Array of characters. Ah, nice. It's just growable. Yes, growable string, but like how it does, like how does it do that? So a lot of ergonomics for the starting bridge and only CKs in higher. The initial high capacity just ensures even small allocations are not dumped. Like initial high capacity. Let's see. So let me show you the actual GDK source. Yes, so this is what we care. And maybe even we can copy this into our nodes. Like this is the real code. Uh, like abstract string build. So, oh guys. So like it implements appendable and car sequence. So there are some methods that we made sure that this class has. This is what it means to have like a to implement an interface. So we have still like a array of bytes. So like we have in string, all right. In string class we have bytes of arrays too. The buffer, the backing array of bytes, all right. Integer count, how many slots are actually used, not the array length, all right. Like that's the whole secret. Value is the resizable array. It was a array before, since complex yes, it's a byte. So count tracks how much of it's filled. So the array can be length 16 while count is still like only 3. There are spare slots waiting. The distinction, the distinction value length, like this is capacity versus count, is the same distinction as array list element data length and size. Capacity, how many it can hold before growing, yes. Size, how many it does hold, yes. So we know this, but like like this is same as string class. Only difference is like this count variable. Like so initial size, yes, 16. Default buffer capacity is 16 characters, guys. So like 16 characters, like that's interesting. So you can precise it yourself. Big enough for the seat. All right. All right. Like 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 is the only difference is like that count variable? Who said we were allocating 4 megabyte and such? It is literally just space of 128 characters. We're not gonna crash a program or kill an operating system via optimizing space due to amortization beans. It is 16, but that's still right reason. Maybe it's just because I know C that I get and understand why it's done. Just the more reasons to learn. Like I'm trying to understand object-oriented programming and the string class and the problems with the string class and how they are solved with other classes like a string builder. How appends work, right in place, grow only when full. Like, all right, so like this is the key, I think. Like grow only when full. Like I see, like this is something, but string length, ensure capacity, and increase the count, and the grow rule, new capacity. So old capacity, yes, we double it, like we double it like this, yes. Like this is handling capacity. Your sharp observation. Is it wasteful for 2, 3 append? You are thinking like an engineer. Yes. The answer has twists that will please you. For a small fixed number of concatenations in a single expression, you write that 16 bytes, like 16 bytes buffer is overhead, but you never pay it manually because the compiler already uses string builder for you. You wrote this, for example. The Java compiler does not create three strings. Java 9, it compiles this into single optimized concat. Oh my gosh, guys. Like, like I love details, but not that this much detail. So, like string builder append and append and append and then string. Wow. One buffer, one result. One buffer, one result. So the rule sharpens. The rule sharpens. One expression, fixed PCs. Like, all right. Just use plus. The compiler handles it. 16 bytes is nothing. Yeah. So array list, the same design, two differences. Uh, it has size, the capacity, and the buffer, the objects, not bytes. Well, wonderful. I was like, all right, because we can use array lists for um, like storing any type of object we like. Like we can store string, we can use store even our objects. So that's why the type is object, so that we can use anything because every class extends object class. So we basically store everything in array list. So we have a add method, all right. We override this method elements data. So we basically add this element into this list. This is right. So a new capacity. So I really like the way array list is designed. Let's paste it. So but the maybe we should create like a comparison between string class and the string builder class. So like all right, so like all right, like let's look at like growth factor is 1.5. So like this is interesting. This is quite interesting. not 2x. That is quite interesting. How it is one and a half? Like a old capacity plus half of it. That seems like an optimization, guys. Do you see it? So now the question is, now I like, can you please create a comparison table, I mean, can you compare the string class with the string builder? Because I thought that string builder class is like some sort of magical class that handles like a growing byte of array, like a magic, but it is not magic, like, because the string builder resembles the string class quite much. The only difference is we keep track of the size, and as the capacity reaches that size, we just create, we double our size. So basically, there is no like a radical change, radical difference between string and string builder, right? So only difference is like a one variable of that class, which is um, which is count basically, right? Um, I don't know. Like in Java, static means using a method. Yes. Basically, once you give them some area capacity for it, you cannot resize it without triggering a compiler error. Wait, hold on. What language are you talking about? All right. So, um, you basically reverse engineer it, and you are mostly right. Mostly. Wow. Let me give you the table, but then sharpen the place your sharpen the one place your mental model is slightly off. All right. String class. We have array of bytes. In string builder, we have it again. Is the array final? Yes. Never reassigned. Not final. Reassigned on grow. Wonderful. Spare capacity? No. Array length and content length. So exactly sized. Uh, yes. Value length is so I guess what I need to see is creating the double, like a creating new array with the double size. I think this is what I need to see. Um, count divided by size, mutable, no input, right in place. Yes. Modify methods, return a new string, mutate and return this. Chainable. Thread safe, inherently immutable. No, like string buffer is not thread safe. No is the same one. Hash code, cached, safe, never change. Recomputed contents change, yes. Alright, so I think I can copy here, alright, copy this one and paste it here, and then ask the part that I didn't understand. Look at the buffer, uh, where your model needs one fix. You said the only difference is count variable. The count is the visible mechanism, but the root difference is deeper, mutability, enforced by final. Look at the buffer in each. In string class, we have like a final array of bytes, and in string builder, like abstract string builder, like it is the parent. So, alright. So let me take a screenshot of it too, so I can use it for object-oriented purposes. It is, yeah. So we can assign new thing, like a new value to this, since it is not final. So this is the core difference. But where do we exactly create new array? I think I want to see. So string couldn't become string builder just by bolt operators. Alright, so I know it. Like final. Safe to share freely. String pool interning, like interning. There is a all right. Cached hash code, fast and safe as a hash map key. All right. So basically, string builder doesn't use final keyword. All right, but the string class uses final keyword on this byte array. So this is the difference. And then we have a count a variable that keeps track of the current size as we add and as we like upon we reach the size like a capacity, we just create another array byte array. So thank you for that. Now could you please show us in string builder where when the capacity is hit we create another um, byte array. Can you show us that code snippet in the real string builder? Like it showed us, but I just wanna see it again. Maybe we have it in our code, like our nodes too. This is array list. No, I think no. So I haven't taken a screenshot of it. Here's the real chain. When you append, there is and there isn't room. 3 methods fire in seconds, and the actually byte array is born on one line like this. So this is the magical method, guys. Arrays.copy of arrays.copy. So you may ask why why we use like this class, because guys, like string is basically array of character, array of bytes, array of characters, let's say. So arrays class is important. So like today my goal was like a studying integer class, all right, string class and arrays class. I think now we should also look into this class too, because this is, you know, essential class in Java. I think it seems that like that way. Append. So in string builder we have a append method, all right. If we have a room, we just basically add it. Um, like there's an append method, but what do we add? Like, are we adding this string? All right. Like what we are adding, like what we are appending is a string. We take these parameters length first, add it onto like a count variable we have, which is the current size of our byte of array of byte. All right. We first need to make sure that we have like enough capacity. All right. This says that if we don't have enough capacity, we basically copy the value. The value is the array here. We copy the array, and I don't know what we do here. New capacity, minimum capacity, coder. Anyway, like we don't need to understand it. It seems a little odd to go this in depth on a string builder. So actually, the reason why we go deep is understanding how the essential parts work, TV Josh. And also, in an interview that I had, there they asked string classes methods and integer classes methods. So, like the reason why we do that, understanding how Java works, and we basically practice Java. So there is no bad side with it, all right? Uh, like it is like a solving lead code problem, like algorithm problem, all right? Because like previously, like string builder class, like was something like a magical class, all right? Magical, like a magical class for me, because like it gives me append method and maybe add method. I don't know. You know, append method. So but I didn't know the like internal parts of it. All right, I didn't know what problem it solves, and also what is the problem. We should define, like we should know this. Like the problem is, the problem starts with string class itself. In string class we have a byte array which is final, all right, which is not editable after instantiation. And then what happens if you like what will happen if you want to add something like a update this? So you cannot do that. Why would you? Like why would I append a string? Like this is a basic operation. So if you, let's say, you created a string called kinesin, and after like let's say 1 month, you just need to update this. Go in this, like this is not depth. This is what I mean. Like we are, like imagine ourselves as a solving LeetCode problem. Do you have any problem with that, like a studying LeetCode? If you have, I cannot explain, but we are basically practicing Java. Practicing Java. I like LeetCode. So this is like just like I see this like a LeetCode problem. I like LeetCode too. But you're not coding. Um, like this is coding. This is definitely coding, bro. Actually, we have coded it too. Like in the beginning of our stream, we coded like um, reverse the string. We have coded it with the approach that came to my mind first, and then we thought that there must be a better way. So we learned about join method, and then I wonder like why join method is defined like this, like why it is static, and why this split method is instance type. The reason why this split method is instance type is that because of encapsulation, all right, and we have the data, like the object holds the data itself. So the function, like the operation we're going to do, requires the data, and that data is the object, like the object itself. So that's why we made this method instance type. But whereas in join, like this is like a core function. What it does basically, based on this splinter, I think, separator, you create another string. So you don't need to like mm, you don't need to hold the data in the object. um, Actually, now I think that like maybe we could design this as an instance type too. Maybe we could type like reverse words, like this is the array that we're gonna reverse, and then maybe we could use join, all right, and we could use a separator here, and then this could return, like, because like this method, like this array is what we are operating on. Like we could design this too. Like I don't see the encapsulation logic here. uh Thank you, thank you. No worries, no worries. So maybe we can ask this, like how, like why don't we like design this like this way, all right? So this is another question. Maybe it is because String Joins was added a lot later. Yes, that can be, but I don't think so, because the author of Java like applied object-oriented programming principles deeply, all right? And like there is one example with that actually. There was a, I think, linked list. So there was a method that caused real problem based on the object-oriented programming because in early phase of Java, uh, I guess it was in HashMap or something. We can look it up. Like I will ask this right after this question. Thank you. Now I understood the encapsulation part where like why we use like we pick the instantiate type over static type, all right? But couldn't we like a design our join method like a instance method instead of static method like this? Like both seems correct to me. And also, can you also remind me the object-oriented principle mistake that Java authors made during the early phase of Java? Like I guess it was hash in HashMap or something. Because when I was studying um, extend keyword like inheritance, I learned that there is a method that is in that class, and actually it is wrong. What was that? Like TV Josh, you mentioned about a good thing, and now the AI will tell us. Because in early phase of Java, like they made a mistake, like a design mistake. So we're gonna see it. Python string join is not static like in Java. Wonderful. So in Python, like then it means like in Python you can use it like this way, right? The array itself and then the join method. Wonderful. I didn't know that. So like it seems it's like a design decision. Like hmm, join reverse. So you are giving it as a parameter. Actually, it seems same to me. We can ask this too. Like is you are saying that it is not static, but the double quote that you used in the before the join makes me suspicious. Three things here. Let me take the code back first. Because you just learned the exact rule, it breaks. Your line has a bug. Support it. What you just learned. Like, which bug? So, like, what I thought was like, we have the array. We are we are gonna create the string from it by joining by this. I mean, separator. I don't see a bug right here. I know the original join is a static. Like I think the problem with that is like reverse words is string array, all right? Like array of string. So when we do that like this, what is the class? Join means it can be static, can't be. The double quote string is the object. All right, all right. Here, like before the dot, this is the class name, so we can understand that this join is static. Uh, so the empty thing is like a string object. I see. I see. So here, like we use like a join method here, but the type of this variable is string array. So there must be a class like this one, right? So what is the class of this? So I think we cannot use it like this way. So that's nice. Let me take a. I think this is the answer for it, and this is the bug that the AI mentioned. So we tried to make join method as an instance method, like in Python. We tried it, but we failed. So join is a static method on string class. So by the convention we just covered, what do you call it on class name or a reference? And separately, this variable is a string, an array. So does an array even have methods you can call with that with a dot? Remember, like array.name. So no parents. Arrays expose no method. So guys, so the problem is this. So this is like the type of this is array. All right. It is string array, but the real type is array. It says, wonderful. It is array. Like the type is array. Maybe because arrays are end classes. I didn't get that part, but we see that the type of this string array is array. But why do not other way around? Why the string array is like let's call it string, but the but we do is like a string array is array. Like type of string array is array. That's interesting. That is interesting. So all right. So rewrite it. The shape is all right. Could join be instance method? Great design question. It could. It could. And as TV just says, it is like that in Python. And he also showed the example. Thank you. It could. And one famous language did exactly that. Which language is that? Python. Yeah. So it gives the example. Yes, Python. So we could design this method as static or instance type. Basically, we can do this. But if we try to do that in Java, what we end up with is an error, basically. Why? Because the type of this variable is array. So does array class has this join method? I guess no. The string is more generic too. It works on iterables. Yes, I think. Maybe, yes. Iterable. So I guess the string class implements iterable, right? But how is it related to join method itself? I think because of the parameter type that it gets, it can work on iterable too. So maybe we should. Can you give me the definition, like a method definition of join method inside the Java JDK string class? Because my friend says it works on iterables too, and I wonder how it does it. I guess it can do it by using the like a correct parameter types, right? And as far as I remember, string class implements iterable. Like what other classes does the string class implements? If join is a string method, then it is less generic. Oh, yes, it is string method, like a string class method, because it is static. So the definition of join method is inside the string class, and it is static. So it doesn't need a object instance to work. Your friend is right. TV Josh, you are right. Um, you have half guessed the mechanism correctly. It's parameter types overloading, but there is one misconception to fix about string implements. What string implements? Here are the two real overloads from overload, overriding and overloading. Um, like this is a static method, and it takes character sequence like a delimiter, yes, and character sequence. Like this is interesting. This is the one. This is the one your array hits. Our array like in our code, which is array of string, hits this method. I think there are multiple type of join in string class with thanks to overloading, and this is the method that our uh, example hits. And what we need to see is like a character sequence. All right, elements. So we basically take, like, we using for each loop, we iterate every element that we got from our parameter, and we add it. I don't know this one, but we basically add it. So, and then we like a using to string method, but we return is a string itself, like a string type. And when it comes to iterable, as TV just said, this is the one your friend means, like a list, set, etc. So again, we have delimiter. Yes, like yes, like look at the parameter type, man. The type of parameter is this. Wonderful, wonderful. Um, Again, we iterate through each of the elements and add it, and then return the string. But in our code, our parameter is array of string, and this is what we hit. Can we see an example of, yes, so string join here takes list, so it takes a parameter which is a type of iterable, like a list, and that means string, like array of string, is not iterable. All right, so this is great. So thank you, TV Josh, thank you for saying that the join method works on iterables as well. That made me think that string class, like an array of string, is not iterable, and also that made me think that what is iterable. And as we see here, list and list is iterable basically, like a list, set, etc. So let me take a screenshot of that and paste it over here. Like this is amazing, guys. Thank you. And this is the example, like a we overload, like a same method name with different type of parameters, so that we don't have to write like a different method each time we need to do something slightly different, like a same function but slightly different. So we overload the method. Overload. Both bodies are identical. They just funnel into a string joiner and loop. The only difference is the parameter type of the second argument. So like this is what I just said, the parameter type. The misconception: string does not implement iterable. Oh, all right. So string has a join method, and that join method takes different like a different parameter types. So we don't need to implement iterable. All right. This is the key correction, because I thought that for string class to have a join method like this, we should like it should implement iterable too, but I guess it doesn't need to do that at all. The delimiter works because its type is character sequence and string implements character sequence. Oh, nice. So what this means is, like, if you have some classes that implement some other classes, what you can imagine is like a string, like what, yeah, you can count string as car sequence and car sequence as string. All right, I mean, actually, no, not the vice versa. So you can count string as a car sequence. So imagine you have a function where it takes a car sequence, you can put a string there. All right, because there is a relationship here. Americano, are you here? Are you following, guys? Like this is object-oriented part of this. If some class like a string implements another class, you can count string class as a car sequence. So you can give like a parameter, you can give a string where the parameter type is car sequence. I'm saying that, all right. So we're gonna do object-oriented programming stream 2. This is not one of them. Today we are studying Java and Python, but this is important and this is asked during the interviews, in exams, midterms, finals. So this is important concept. So let me take a screenshot again and just paste it. So join works on iterables, as TV Josh said, because the second parameter, because of the type. And guys, like, look at it, guys, how ugly it looks. How ugly it looks, like a come on, like extends. All right, what extends car sequence? Like the question mark, like, wait, what you can do? So like, I like, this looks ugly as hell, to be honest. I don't know how to interpret it or decompose it. But we can do a to-do to study this. Like, this is important because wait, what you can do? Like, are you saying to me works okay? So car sequence in Rust, that will be iterator item. Oh, in Rust you have a similar thing. Wow. It must be something that extends car sequence like iterable string. It must be something that extends, yes, like iterable string. Iterable string. Yes, but what is up with this question mark? Like like this is generic, I think. The question mark is just generic. Is generic. So it just means something currently unknown. Unknown. Wow. Like, isn't it just amazing that we can do some stuff on unknown stuff? Like, because in coding everything should be known, you know? Like, I know what my string is. I know the definition of this method. Like, it takes a parameter and we give it. So everything is almost known. But now you are saying me that there is something unknown that extends car sequence. In Rust, iterator, arrow, and item equals, yes, like this is quite resembles to that. Like, but for me it looks hell, like it looks ugly as hell. I need to. The library author doesn't know the class. Oh, wow, yes, like, this makes a lot of sense. The library author doesn't know the class you wanna use, but you, like, that means the question mark is for us. It's possibly because the user could define new classes inheriting. Oh my gosh, thank you guys, thank you both, TV Josh and Boris. Okay, yes, it's possibly because the user could define new classes that extends this, like I am the user, like I am a coder, like we are coders, and we create a class that extends this character sequence for some reason. Maybe we have our own method, like we have our own definition for certain methods that should behave differently than the main class character sequence. So we have a class that extends this, and um, if we are gonna iterate that, or maybe you want to use it with two different, no worries, maybe something like a token stream, this could inherit character sequence. So like, like you are right, guys. Like I can understand this. So like this is for us, for coders, and we extend this class basically. Like we have a class, another class that extends this class, uh, and this is for it basically. Like this makes some sense. This makes some sense. Thank you. What string actually implements? Hmm. Serializable, comparable. So as TV just said before, like an iterable string, he gave an example, like iterative string. All right. Like I think I'm not quite familiar with the generic, so that's why I struggle. Implements car sequence and constable and constant. All right. So our beautiful string class is implementing lots of classes, lots of interfaces. Um, all right. Character sequence interface. I am a sequence of characters. So implementing this lets string builder and string buffer all be passed to the same APIs like a like joins parameters. So when we implement this class, we can put ourselves like a put that instance, like instance of that class, and use it in joins parameters. So like this is the first time I see the real world example of the implementation. Like upon you implement an interface, like what we are doing here basically, there is a method, all right, in string class, and when we implement like this interface, we make our class usable for this method, like inside, like I mean, for this method's parameters. Like this is what we are doing. Wonderful, wonderful. Uh, yes, yes, yes. So so when we look at the join methods implementation, we saw character sequence, like it takes character sequence, but we are string, we are string, but this method takes its car sequence, so we should implement this. So yes, and string class implements this. Wonderful, guys. Let me take a screenshot of it and save it, and also gave some colors because like amazing. And also guys, you had like a like I wanna copy the text you just gave, because like this is when I understood. All right, thank you. uh all right, yeah, good job on yeah, yeah. Thank you, man. Thank you. So, like reading these topics from book does not help at all. All right. I need, at least I need to see how it is used. All right. Because otherwise you would end up like a memorizing everything. Like this is real. All right. You genuinely covered in real depth now. Pool, immutability, final, string builder internals, yes, join overloads, what string implements. Give me the two sentence famous on string builder versus string in a string plus in a loop, and I'll mark one with alright. Well, yeah, you learn by asking suitable questions. Yes, as such, it's how I learned some of the yes, yes. You should like you shouldn't be afraid of asking stupid questions, alright? Because this is how you learn basically, by making mistakes, by making wrong assumptions and fixing them. Alright? We covered lots of things today. We studied a string class. First of all, we uh, like a we thought about why the split method is an instant type and why join method is a static type. All right, and we learned about how string class is built on top of immutability using byte array, which is final, and also as a solution for because here what we have here is creating another string array, all right? So it is not optimal way of doing that. And we ask that, is there a better option? Is there a better option? Is there a better option? A better option. And there is, which is string builder. And we ask that, how is it better than using using this approach, like creating a new string array? It is better because it has like a string builder, like string builder resembles string class very much. What it has different is having that byte array as not final, and also it has a count variable. It keeps track of the kernel size, and as it hits the boundary, like a capacity, it just basically creates like a using erased copy, guys. Like we're gonna also study this today, erase class. It use like a erase dot copy of, all right, and create the copy of that array, so that uh, like we don't create the string array by ourselves, but let the string builder class handles it, all right? What it does under the hood is like creating new byte arrays, like a copy of that byte array, yes, byte array. uh, but when it needs, but like another question I have, like string builder creates copy of byte array, but what we do here, creating, let's say, a string array. So what is the difference exactly? So because what string builder does under the hood is like creating a byte array, like a copying. So we are doing it too. Like the difference, there is the difference, like like about sizes. Let me ask you this one to AI. So as we learned today, string builder has like a byte array as a immutable, like a is not immutable, all right? It has byte array of bytes, and whereas in string class it is immutable, but here in string builder it is mutable. And also what it does under the hood is like a creating like a copy of byte array, like that array, when the capacity is hit. But I wonder, like, uh, does this approach have a better time complexity or space complexity compared to our approach, where we just create a new string array with the size of the words array we have in the code? Like, I want to compare the space. Well, like I want to compare these two approaches, space, like space complexity wise and time complexity wise, because what it seems is that string builder does the same as we do, like a, so I don't see any difference. The only difference is like we creating a string array, and string builder creating like a copying when it hits the capacity, like, and it creates a byte array. So string array versus byte array. Let's see, guys. And after it, answers these, we can take a quick break or something. It's been 2.5 hours. Maybe 30 minutes break would help us, guys. Help me at least, because I haven't had my breakfast yet. Let me write breakfast break in 5. Quick wording fixed. You said immutable twice, but meant yes. String builder's byte array is mutable. Yes, that's the whole point. String is immutable. Yes, sorry. Now your real question. Two approaches aren't doing the same work. Here's the subtly you are missing. Um, yeah, all right. String array of references. Array of references. What do you mean by that? Uh, a string array. So what it holds is reference of those strings. Yes, it is a string array. Your reverse word holds reference to the existing word. Existing word string objects. Yes. Yes, uh, because we split it and we should have we had to store all of the words in somewhere. So the correct data structure is like a string array. Your hold references to the existing word. Yes. When you do, you copy a pointer 8 bytes, not the characters. Not the characters. Yes. You never touch the actual text, so words length equals v total characters across them. Your reversal loop cheap, independent, how long the words are. So this is, I think, the good side of this approach. We store the pointers basically, not the characters itself. All right. So this distinction is good as well. Like we are storing the pointers, not the actual characters. All right. You copy a pointer. Yes. So we copy pointer, and pointer is 8 bytes, guys. So we need to remember that. And a string builder appends the characters themselves into its byte buffer. All right. So this is something important, guys. All right. So I'm happy that we make this distinction, guys. In our approach, what we do is the copy the references of those words. All right. Whereas in string builder, it copies the characters. There's a lot of screenshotting for one particular. Yeah, no worry. Like it's okay. Like it is like this is not a single problem, problem, not a particle problem. Like what we do here, like there are tons of things. String class, in interfaces, object-oriented programming, join method, and then the split method, static keyword, like tons of things. So like what we do here is not like only one question. What we have done is tons of stuff. Even recognizing that we store the references is important, quite important. So we studied a lot, to be honest. Not one problem. Let's say 5 or 6 problems. In string builder, we append this copies all C characters. So they are not comparable head to head. Your array step is yes, the string builder is C, but your approach isn't done yet. To get the final string, you still call string join, and that pays yes to copy every character internally. Internally, it uses string joiner, which is a string builder. So, end to end, both approaches are OC time and OC space, not asymptotic difference. Your instinct I don't see any difference is correct at big O level. Where the real reference lives, the constant factor, and you nail it. So allocations, extra calculus, grow and copy. You allocate once at the exact size because you know verse length upfront. Yes, string builder default doesn't know the final size, so it gambles with a small buffer and pays. So that growth. Yes, yes, yes. The punchline. You can give string builder the same advantage. It's the lesson worth keeping. Alright, alright. So, uh, what stores references? What stores references? This like a reverse verse string array. Here we like a here we have a string array, all right, and each element of it is a string. Here we don't recreate these words like a kinesin ships and it, all right. What we do instead is copying the reference of them and putting them here. At least this is what AI says. So what stores references? So this is stores references. Actually, words stores the references too, I think. It is not crystal clear for me too, so maybe we can ask it. Maybe we can ask it. So let me write what stores the references in my approach. All right, guys, I need to take a break now. Like we can start with the when I come back, we can start with this part. Actually, it's been 3 hours. Oh, like my eyes get tired. Maybe we can make a 40 minutes break, guys. My eyes get started hurting, so today is a long day. So all right, go get your breakfast. So yes, thank you. All right, see you for 40 minutes. Yes, thank you, man. So thank you. And also I should charge my microphone too. um, Thank you for the follow, guys. um, like we should look at this, all right, how we what we store here basically. So take care now. 40 minutes break. See ya in a minute. All right, we pause and then the set the break for 40 minutes and bye bye. So, hello, I we are back, guys. How are you doing? How was that 45, like 40 minutes for you? Now I just need to send a quick message, like a cold message. If you guys have like a two, like a 2 or 3 minutes. Breakfast was amazing. I had my cup, like a tea, black tea. I had my eggs and yogurt. Everything was amazing. I just need to send a cold message. Just give me 2 more minutes. Uh, because this man gotta earn some money. Nice to hear. Sounds like a pretty good. Yeah, yeah. It was it was good. Give me this same but well formatted. Like after I send this cold message to HR, I think we can save this and continue with the next topic that the AI says. So we were using like study skill. So I guess the to end the session, we should run like a study checkpoint. What does that skill? Could you remind us? Because we studied, it is good, and now we just like I just wanna stop working on this topic and go continue to the next one. Now I'm just sending a connect request on LinkedIn. we can make a like a be right back, right? Like, let me change the scene for a second. Hello guys. Hello again. Now, which other programming language do you know? Like I code JavaScript, C Sharp, uh, and yes, that's it. Like I have projects written on those languages, and also like I created another project using TypeScript, like using, but I used AI heavily. So, sorry, what was that? Like JavaScript, C Sharp, and Java are my main ones. Other other than those languages, I used TypeScript. And during uni, we like created some projects using C as well. And recently, I started learning Rust, thanks to Works OK. So I'm learning Rust too. So guys, uh, our skill was study checkpoint. All right. So we wrapped up the this session. I just want to continue with the next topic that our AI will, okay, AI suggest. Sorry, what? Like yesterday we started studying Rust. Uh, that was that is what I was talking about. TV Josh asked which languages do I know, so I said I'm learning Rust too. Yeah, nothing. The fact that I'm just learning it. So Java interview topics. We have we studied string class very deeply. All right, drilled and mastered. I think I don't know. Resume next. So integer. So drill the auto boxing trap. Oh, like this is one of the questions that I asked. Oh, yeah. So basically, from what I've seen, when I see my knowledge of Java stuff, suddenly increased. Hmm. Just something lower level exposure gives. Yes, definitely. Because there are lots of things happening in the low level. So, drill the auto boxing. So, like this question is asked during interview, guys. Interviews. All right. And like as far as I remember, like what is the difference between primitive int and integer, or no, like the question is something like this, all right? Let's call it a and new integer. And when you basically create an integer, like initializing integer, like a smaller than 128, let's say 120, all right? The size of this is something. And if you whereas if you uh, instantiate this integer, let's say like this one, all right? So the size of these two instances, like you expect them to be same, but they are not. It has something to do with these numbers, all right? And how Java internally handles instantiating these. Oh, is that on in I Philip Hayes learning? It's something called in. I don't know, but it might be. So like I've seen this condition asked during interviews from various sources. Um, yeah, like for Java interviews, obviously. You can look it up. It is something Java does under the hood. So actually today I've seen this like interning, and I said I will look it up. So let us check it. Java interning for integer class. Yeah. Today we also seen it. Inter. Am I writing wrongly? Concept. Interning of string. Like Yeah. So how about integer? Like points to string pool. Yeah. S2 reuses the string from the pool. It works on int classes. I think like I think too. Like but do we have interning for int class? Why aren't integers cached in Java? I think we don't have interning for integer class. Why don't primitive box objects have an intern method? That's interesting. Um, can I open Cloud here? I know we have in for strings. I think it is not in. It is not interning. I think like this concept is not interning. Let us continue while it generates its answer. Yep. It does intern. Ah, interesting. Let me read this part first and then we'll continue with that part too. It intern integer values. That's nice. Yeah, all right. Then this is it. All right. When I make a search like on like a Google, like it didn't show that, but the AI will tell us. Assigned byte. All right. This is basically I8 in Rust. Yeah, it is equivalent of that. Yeah. In Java, like these two things, like a triggers different type of thing basically. Or we basically have an if statement like a I8. So when this is above, like beyond its limits, it basically like a create real like a integer wrapper class, like an integer instance. But within the limits, it creates like it uses normal integer. So this means in Java, integer is, as you say, between this. So I think we need this information: how many bytes, a single integer, and its decimal equivalent. We need to know this to understand this concept better. Um, can you tell us the primitive integer byte value and its decimal equivalent and its limits? In Rust, we have like a I8, which is like between minus 128 and positive 127. So I guess we have same situation here when the autoboxing trap. You could check equals if they match their reference to the same heap stack value. They are in turn. Yeah, yeah. Because the equal sign operator checks the references, and we're gonna see it. So your intuition is exactly right. The cache, all right, range is the signed byte, as works okay says, signed byte range. So that's deliberate, not a coincidence. Java byte is Rust I8, so 8 bits signed. So 1 byte is 8 bit. All right, 8. 8 bit signed range, yes. Identical to Rust's I8. The asymmetry is 2's complement. 1 bit is the sign, and 0 uses up a positive slot. So the negative side reaches 1 further. Note, Java's byte is always signed. There is no U8 in Java. No unsigned types at all, except character. All Java integer primitives. Alright. So byte is, so 1 byte. It is between this range, and short is 16 bits. Okay, in this range, so 32,000. So when we are in millions, like a 2 million, it is integer. Oh, so this is what we are looking for. 32 bits, like a 4 byte. Oh, that's something new. I didn't know byte was always signed. So, like in Java, it is always signed. I didn't know that too. Byte is always signed. All right. So the long is even longer than that. And character is unsigned. So we don't have negative values basically. All right. Why the auto box in cache is exactly this? When you box with integer value of which integer x 127 goes under the hood. So when we do this, like instantiating an integer, what Java does under the hood is like a calling. This one, I think. The Java Development Kit keeps a pre-built cache of integer objects. Pre-built cache. That's something interesting. We have a cache. Yeah, low and high value. The designers picked this range because it's exactly the signed byte range, the smallest, the most common integers. Loop counters, oh, so they basically optimize it. Instead of creating a new integer objects in heap, we already have them and we use them everywhere we need them. We need those numbers. Loop counters, small flags, ASCII ASCII values. Two, caching them means, yeah. Oh, so since like, all right. So since we have cached those values, when we do like a if returns the same object, true, saving allocation. So when like, yeah, like I can get it, they are same object. Like what was the that autoboxing interview question asking? Like that has something to do with like a bigger than like this one, and we were comparing these. I guess yes, I remember now. New, like we are doing new integer 129, all right, and again like let's say x and let's say this y, and we do like we instantiate another integer with the same value, all right, and when we check this, all right, this returns, what does this return, guys? You guessed it right, guys. What does this return? I mean, this condition, is it true or false? It is, of course, guys. Yeah, false, guys. Why? Because this number is beyond our cache, like a Java cache. So so it creates new instances. So new instances meaning new, like different references. When they have different references, this operator returns false. And as VerseOK said, if you want to really check if the values are same or not, you need to use value equals x dot equals y. Then this return true. Yes, it checks references. Yes. checks references. Yes. Since they are different objects, this returns false. It checks the references. It's why string uses equals for comparison, I believe, since it checks the value. Yeah. But we can use equals for these integers too, right? To check if they are equal. Because integer class, I think, override this method inside itself so that we can use it. Let me take a screenshot. All right, I see. Hang on a bit here. Even I'm trying to relearn Java. Yeah. So like we are combining the Rust knowledge with the Java knowledge along with assembly. I'm in the same boat as you already. So that's great. That's great. That's awesome, bro. When you box with integer value of, all right, catching them means like it returns the same object true, saving allocations for the values used most often. That is wonderful, guys. Outside that range, value of does new integer a fresh object each time. The equals, like this double equals sign, compares references. So we create an integer variable 128 and d 128, and we make this, and this return false even though they seem equal, but it is an integer object, so it creates new objects under the hood. But here it returns true because they use the same thing. This is because how authors of Java designed this, all right? For the frequent use numbers, we have a pool, like a shared pool, like cache basically. And when we do this operation, these two variables point to same place. So that's why it is true. So chosen as a default integer cache range. So like the convention, like the convention is integer caching range. All right. That's the exact boundary. All right. So one typical detail: the lower bound is fixed at this one, but you can raise the upper bound with the wow, which would make true for box integers. Don't rely on it. Code that depends on the cache is fragile by definition. So all right, I wouldn't do that. I wouldn't change the integer cache range of integer. Oh my god. You connected it correctly. So i8, same i8 binary, just reused as a caching window. So all right, so let's continue with this one, guys. All right, we are bright, everything seems fine, but we don't have our clock. Where is our clock, man? I was showing the local time. Anyway, integer wrappers. You already crashed autobox interrupt. The range, yes. So we drill the part you haven't typed yet. Parsing and radix conversion. All right, let's see. You already crashed autobox. Yes. We'll drill the part you haven't typed. Parsing and radix. What is this, man? Radix conversion. Huh. So parsing to binary string to hex string. These are methods, like I guess static methods of integer class. So maybe I can create another mark, and let's type it integer and save it. And yes, we have it. What we are building? A tiny method like a hex to binary that takes hexadecimal, and returns a string. I believe to binary and to hexadecimal returns like 010 and like A21CD, yes, and such. So yeah, they will do that, I suppose. um, Takes a hexadecimal, returns its binary representation as string, like its binary representation as a string. So you just need to parse the characters. Yes, parse the hexadecimal and then convert them into binary and then concatenate and return a string. Also, the radix is just the base, by the way. So this is how it is called, radix. All right. So to like a we use decimal, so they have 10 base, and in computers world it is 2. All right. Thank you. So all right, we're gonna build this. Yes, radix base. So radix 10 is just standard denary. Base 10, the one we use. Yes, yes. All right. Yes, radix is base. All right. The concept you'll practice: string to integer parsing. All right. So like this is quite popular with a radix. Then like from integer to string in a different base. In a different base, guys. Two static helpers on integer plus knowing what happens when the input is garbage. 3. First question, predict before coding. What's the name of the integer method that turns a string into an integer? And since 1a is hexadecimal, not a decimal, what second argument would you need to pass it? Doesn't choke on letter A. I guess the base, like a tell me the method plus the second argument, like a base. Then write the skeleton, a hex to binary. So like I guess we need to now write the code, like I mean we can remove this part. Like we need a method like this. Garbage info is like when you have invalid components. For example, invalid in base 2, since 2 is not represented with base. So when we have like a not valid input, we basically make this garbage info flag. I suppose it is a flag. We make it true or something like that, right? So we have a method over here. All right, we have a method over here. Hex to binary. So let's suppose we have like a 1a. We need to parse it like a for loop or something, like a character by character. So it is a string. So maybe I should turn into a character array or something, guys. Like a, let's call it a array and hex dot to char array, and maybe loop through it. If it's a garbage, we can't work on it at all. Yes. Wait, no, but you try to return an error or something instead. Actually, yeah. Because if it's a garbage, we cannot work on it at all. So let's create an integer value here, and then it will be smaller than the length. Length is a static length method. Is static method. What we need to do, like get the each character first. All right, like this is how we get each character, like a character at position I. This is like now we have like we have 1, and we can store it inside a string or character. character C, let's say. Now we need to like now we need to convert, like we have one, all right, at our hands. We have it. So how should we convert to what? To binary. Oh my gosh. Like maybe divide by 2, and each time we divide by 2 we add 1. Should we, I guess we are supposed to type this like a, tell me the method plus that, then write the skeleton signature, the parse line. Don't worry about the binary conversion yet. All right, one step at a time. So I guess like the parse int, tell me the method. I guess we can close this suggestion part, guys. It's like a cheat. Tell me the method. What is the name of the integer method that turns string into integer? String into integer. To convert something to integer, we need to call the methods from integer class. All right. We need like integer class has this, and what was that? Parsing. We are parsing integer basically, but we are not parsing integer here. We have car. It says parse integer, but with the parameter we put is not an integer. So all right, we put like a maybe a character or string and it returns. Like maybe we should look at the definition of this function. And which parameter it gets. This is like its constructor, but what we are looking for is like a parse int, right? So it takes string as an input. So but what we have here is not a string. So maybe instead of character I should use a string. All right, but this method returns character, so maybe I should cast it into string. Let's suppose we have 1. All right, we have like a 1, like this was string, and so we have a string value. All right, and we need to parse it to, like, is this process called parsing or converting? What we do is like a, I feel like a converting. You might need to suggest we are adjusting the function signature to tell it might throw a number exception. You might need to suggest. All right, I'm gonna be out now since the next. All right. Thank you for being here. Thank you for being here, Americano. Thank you for being here. And also good luck with your exam, mate. Right. Good luck with your exam, man. I hope you studied well. So, like, I guess I should ask this first, all right? Because like what we are doing is just converting, and instead of convert, we use parse. I think I can look at the look up the meaning of parse. What I wonder is like, what I wonder is why this method is called this like parse int, because what we do is like a converting string to an integer. But the term used here is parse. What does parse mean exactly? Is it like does it have the meaning of like a something like a converting or something? Yeah, but parsed integer is fallible if you check in more details. So you need to try and catch it. All right, I see. I see. So this operation is like a dangerous stuff. So I see. I see. But first, I need to. I wanna handle the core part, and then I will care about the edge cases. First, I should come up with a solution. Solution that works under some rules, and for some cases. Good. The word choice is precise, not arbitrary. Yes, you need to catch the number format exception. Okay, in case. Number format exception. Alright. Alright. We will look. Parse comes from Latin parse. Part. Originally to break a sentence into its grammatical parts. Parsing a sentence in school. In computing, it kept the meaning. Read the sequence of characters. Check it follows the expected rules and grammar, and extract structure meaning from it. That's exactly what parse it does. And it's more than simple convert. It is more than simple convert. So reads the text character by character, validates each character is a legal digit in the given radix. All right, handles an optional leading plus or minus, accumulates the numeric value. Oh my gosh. Throws number format exception as works okay said. Throws a number format exception if the text doesn't obey the rules. All right, for example, if the character is like a 5 in base 4, uh, like this one in base 10 is hello. In base 10. All right. So like we are writing a single method, but it handles 4 operations. So that's why we have methods. All right. So it reads character by character, validates each character in the given radix. It validates. So validating means it will throw an error if it can't validate. So this 2 and 4, like a step 2 and 4 works together. 3 is accumulates the numeric value. For example, because 4 like in base 10 like it has this thing, but 2 has 1, like 2 times 1, but for 4 we have 4 times 10 because of the digit, the numeric accumulates the numeric value. So like input might be malformed is why it's called parse, not convert. The distinction in Java: interpret text against a grammar may fail, it says. Casting reinterpret a value you already have, like we have like double, we convert. Like converting is not a single thing, it has its different styles, like a parse and casting. Value of parse or box into a wrapper object. Oh, like it returns an integer. All right, so convert is the lose everyday word. Lose everyday word. All right, this is what I'm doing. Parse is the technical one because text input is untrusted structure. Yes, yes, text is untrusted because you can type anything basically. So all right, so now I learned the meaning of parse basically. Boxing just means it attempts to enclose into an object item, an object item. Example, parse string as so parse string translates into string. Enclose attempts to enclose into object item. So we have parseInt, so we try to enclose into an integer object. All right. So it is more about what it returns than what it takes as an parameter. Yeah, that's correct. So this is about what it returns, what it tries to create, parseInt. All right. Now back to my question. You half answered. In plain decimal, would throw yes because a is not defined. Because yes, a isn't a base 10 digit. So one second. So it should take the base and base for hexa is 16, right? Because as far as I remember, we have numbers 1 to 9 and then A, B, C, D, E. Do we have F? 9, 10, 11, 12, 14, 13, 14, and 15. So yes, we have. So this is 10. All right. This is 10. This is 11. And what is the binary representation? Anyway, so we need base, and base for hexa is 16. And as a human being, we live in base 10, and computer the I don't know, the foundation part is base 2. All right. Base for hexa, it is 16, right? Wonderful. Like maybe I should take a screenshot of this part too. Like parsing has like a more meaning than just converting. Converting is just a loose definition. Parse is a more profound name for it. All right, exactly. Integer integer parsing. So to create an integer from a string, we need to indicate the base as well. The second argument is the radix base. 16 for hexa, 2 for binary, 8 for octal, and no argument version defaults to 10. So now you can parse these to this like a decimal. Yes, I can do it because now we know how to use like a integer parse like this method. And during the interviews, actually, they ask you do this by hand. But let's first complete this, and then we can try doing this operation, by ourselves. Basically, we can try writing this method by ourselves. So now you can parse this one to this one. Yes, write the method so far. Integer parse, fill the blanks. So we are going to write hex over here and 16 over here. So maybe we can hex to binary too, and copy that one over here, I think, and then basis, like hex is string, so we, yes, so all right, now turn the value into binary string. So I guess this should be again a string, right? Because what it returns, like the type of what it returns is string. So we are done. Yes. Now what? I guess it doesn't have the closing parentheses. Copy and paste it. Now the second half. One thing to catch. Look at the left and right side. Yeah. What is wrong with that? What type does string? We literally name it. Oh my gosh, what am I missing? No, it returns integer. Come on, right? We said earlier. It parses and returns integer. Yeah. All right. It parses a string into. And what type did you declare values? Actually, it was integer, but I changed. But all right. It is integer value, but correct now. Like, but the question for me is like the meaning of this, for example, as an integer is something else. And actually, we cannot have such a thing because integer only supports up until this one. So let's say the integer value is like a 101, but so all right, I see, I understand. So this is not a binary, this is already a decimal. We basically using the method of integer class, all right, parse int. We basically like a parse into decimal, correct? Yeah. If it returns integer, all right. So maybe I can use this one too, but it used primitive. Interesting. Two things left to finish. The method promises to return a citizen, so our method, but doesn't return anything yet. It won't compile. You have, yeah. So I think the 1a is 26. You need to turn into a binary text. Yes. So now first, like first thing we do is taking a hexadecimal, turning into a decimal, and take that decimal and turn into a binary. So we don't hexa to binary immediately, like in single transaction. Hexa to binary. No, we first create a decimal. I mean, all right. Let's remove that part, and let's remove this part too. All right. We should forget about this part too. All right. We have a hexadecimal, and using integer classes parse int, what we do, like parsing that string, and as works okay said, this returns an integer, but we use somehow primitive. All right, primitive integer. And now we're gonna we have 26 in decimal. Now convert this into binary. So this is, I think this is the part where we can type code our own code, because we should divide by 2, right? Something like that. Like this is this part, like a converting decimal to a binary is asked during interviews a lot. I've seen this too. So what is a static integer method that converts integer into binary? So we have, I guess we have a method for that, but during interviews they don't allow you to use methods, but instead type your own code. Same family as to hex string to string, write the return line to binary. So I suppose now we okay, this is primitive. So I guess again that method is inside the integer class, and we are gonna convert but that binary is string, so then that method should be in string class. Am I right? String to binary, because we are gonna convert into string, and the method takes a decimal, which is a in our case. Like you can use integer to binary string also, by the way. Interesting. Integer to binary string, and give an integer. Maybe I should just print them down, print ln, and see the output. Maybe I'm just making it up. Let's run it, and yes, compile time error, because there is no to binary. There is no. All right, remove it, and run it again. Actually we don't call it, so let me call it, and also like this returns string, return this one. All right. Oh my gosh. No arguments, hex to binary. No, like we didn't give a hexa value, let's say 1a, right? And make static, like make this static, because we are calling it inside a static method. We didn't give the base, I think, so it is 16 to parse integer method, right? Yes, finally we get it, guys. Like 1a, is it correct? Nice. 1a, like is 1a this? All right, this is 1 and this is 11. No, 12, right? But why is that? 1 1, like 11 0, like 11 0 1 0, like this is 12, but we gave 1a. So are we doing it correctly? Like a 1a in hexa, this is 10, but this is sorry, this is 10, of course, come on, this is 8, this is 2, so this is right basically. Our method should return a string of, first we take hexa, we turn into an integer, and we turn that integer into this one as works okay set, like a return this one. Like I didn't know this method, man, but I should know it obviously. Decimal. Yeah. Java apparently suggests leading zeros. Exactly. Yes. Yeah. And most probably there is a flag or something that shows that leading zeros too. All right. Like again in integer class, but this so like the method name has nothing to do with the return type, I think. No, yes, because to binary string. So basically, like by looking at the name of the method, you can see what it returns. Like this returns an integer, this returns a string. And the value it gets is string, and the value it gets, like this method gets, is integer. So by looking at the name of the method, you can understand what it returns, but you don't understand the type of the parameter it gets. But whereas in Python, you can see like you explicitly see the type of parameter. Like, do we have something like that in Rust too? Because here, like of course, since I know the type of hex, I understand. But in Python, there is a feature where you explicitly say or show like a type, literally type, the name of the parameter while you are calling. I guess we don't have something like that, that in Rust either. I mean, you don't type your parameters name while you are calling that functions, right? In this sense, Java and Rust similar to each other, I suppose. So today, like in this session, we learned about two methods of integer class. Two methods of integer class. And we learned, I learned that by looking at the name of the parameter, you can see what it returns, but you don't understand what it gets, all right? Because parseInt gets a string value and the radix, like a base, and to binary string gets an integer. All right. All right. And maybe we can take a screenshot of this too. So what is the question? The method promises to return a string, but doesn't return anything yet. It won't compile. You need to turn it into a binary text. So we should turn this into binary. Yes, we turn it to binary string basically. I guess we are done, but maybe in another session, but we should we should be able to do this, like what the to binary string does by ourselves. I mean, do you feel as tough? You are learning a lot, by the way. Yes, I feel a little bit tired right now, actually, to be honest. Just trying to see if my feedback also are working. I can be a bit technical. No. You are just doing great, man. You are doing just great. But I feel a little bit tired, and like what is the word for that? Um, Let me look it up. Hold on a sec. I regret. I think I I regret that I started 16 hours long stream actually, because I feel a little bit tired right now, and there are lots of hours left. Uh, Thankfully. But yeah, I'm also a bit tired. Thankfully, I got a call. All right. All right. Thankfully. Yeah. Um, let's see. Let's correct and complete. Hex to binary, hex to binary, hex to binary. We have like this is our method: parse int and to binary string. So one quick observation worth banking. Notice to binary string to and this method take an integer and give back the digits without the prefix, as you say, works okay. Just and not this one, all right. If you want to prefix, you add it yourself. That's interesting. Now the bonus, like it says that notice like to binary string and to hex string, to hex string and to yes to binary string, to hex string. We haven't used it. So basically, to binary string takes an int and give back the digits with the yes. All right. Now the bonus I promised, and it will click when your Rust background. Cloud SE Migras, like it will click given your Rust background. The math floor mode versus gotcha. So Java's operator, uh, like it gives us the reminder, right? But it is minus. Predict before I tell you. In Java, what does does this give? And why might that surprise someone who expects a clock style modulo that always lands in think about what sign Java's modular keeps. I don't know. I don't know, guys. Like um like it should like will it give -1? Let's give it a try. Like I guess it will give my like I mean -1. System out print. Oh my gosh. Let's see what it gives, guys. Yes, -1. Because guys, I have learned this where like we have a floor method, all right? And like imagine we have this, all right? Like as VR0. Welcome, Copo de Bonito. How are you? Let's say like we have these numbers, all right? And when we apply floor method to this number, I mean like not that number, but obviously like 1.5, all right, 1.5, it floors to 1, all right, or let's say 1.4, all right. It picks the closest one towards this direction, and when same thing happens in here, uh, let's say -1.4, like I thought that would it like a floor to -2 or something, because since we are in negative world. But no, of course, the rule to remember is in both cases it floors towards the 0. So this is what we should keep in mind, all right, towards the 0. So when you have a value like -1.4, it floors to -1. So like as soon as I visualize this one, it became easier. So floor mode gives 2, it says. What's up with this method? Like I know this one at least, but what's up with this one and why? Like it gives 2. Uh, why on earth? um, I understood this part as -1, but what's up with like floor mode? What is different about it? Like I don't know this method and why it gives 2. Like the function both does is the same, like a taking mode, but the output is different. Let's see. Here's the distinction, and it is the same split Rust has. Works okay. Come here. The is the remainder. Yes, like I mean remainder. It keeps the sign of left operand, the dividend. Yeah, is true modulo. It keeps the sign of the right operand, the divisor. Wow. Why is yeah. So um, sign follows -1, the dividend. Sign follows 3. So the divisor always lands. I don't get it. Why they differ? The different division rounding is defined to satisfy the, where Java's integer truncates towards 0. Yes, like this is what I just said. Yes, truncates to 0. So this is -1. All right. Uses floor division. Runs toward. All right, guys. So like this is for this is one approach. All right. I guess nothing is wrong in coding. All right, because as I said here, like one thing we can do is truncating towards 0, and another thing we can do is forget about 0, always left, I think, like a minus infinity. So I guess there is nothing wrong. Like there is nothing wrong. I mean, picking size, because as like as TV Josh said earlier, in Python we apply join method as if it's a instance method, whereas in Java, all right, the join method is static. It has something to do with the design decisions made, all right, because if you try to make join in Java as like an instance method, it will fail so badly that you'll break some stuff, all right. But this doesn't mean you can't design join method as an instance method, because in Python, as you can see, it's an instance method. So, and also here, like you can floor like a transcade, I mean, to 0, towards 0, or to the left side. So that's interesting. Floor division runs toward minus infinity. So floor mode gives the clock style answer. Clock style, all right, for a positive divisor. For a positive divisor, the result is always all right. Why you care? The wrap around back. This is the classic off by 1 circular in the off by. Oh, like I've seen this term before. Off by 1. N is 5, I is 0, and the previous. Buck tries to index -1. I guess we are trying to get the previous one by using this. So imagine you iterate, and your iteration step is 5 actually, like 0 to 4, I think. As you reach this, you're gonna start fresh. I mean, continue from 0. All right. Let me delete it. All right. Okay. You start from 0, 1, 2, 3, 4, and you start fresh. All right. And you continue counting from here again, and you hit 0 again. All right, this is what we are doing with this code. But if we use this one, we fail. We will fail. The correct method is this, I think. All right, anytime you wrap an index backward, ring buffers, circular arrays, hours and a clock, hashing into a table. So use floor mode so negative never sneaks through. All right, so that's a good thing. Let's save it for later. Rust connection works. Okay, come here. Identical situation. Rust's modular is also a remainder. Yes, and this one like a minus 1 in 32 bits, I think. Yes, 4 bytes. And we have a method that does the same job as floor mode, I think. If you do this, you get 2, I think. Is Rust equivalent of math floor, basically. Same 2 operations, different names, but they act same. So this sign is like, I mean, modular, remainder, sign of dividend, sign. All right, so we use sign of dividend. Can be negative, but floor mode cannot be negative. You now drilled core, parse and radix round trip, and the autoboxing cache trap, and this one. All right, so that's nice. So we can continue with the next topic, guys. Now just run the checkpoint skill and continue with the next one. So floor mode is like acting on a magnitude. I guess yes. It doesn't get negative values. It doesn't give you the negative values when you take modular. When you take remainder, basically. Like, this is a good question. Like, this is a good interview question. Let me check the sound level. I think yes, it plays. I think. Which skill it used? I guess it was checkpoint. Yes. All right, checkpoint. So Java util arrays. We have arrays class. What we are building? Given like an integer array, print it, sorted descending. All right. Like, I can do this in, let's say, 4 different ways. All right, using heap sort, bubble sort, quick sort. I studied selection sort, but I forgot it. Like a heap sort, heap sort, quick sort, and merge sort. There was one more thing. Yeah, sorting. I studied. All right, we can dedicate one day, like one stream for like studying sorting algorithms too. Like, I even have their animations as well. So maybe let me show you them. I think in LeetCode, in sorting, in, let's say, merge sort, in renders, we have a great animation, guys. I mean, there is others like bucket sort. Yeah. We have like there are some others, but these are the ones that you need to know their time complexity. Basically, you don't need to know the implementation of it. But I just wanted to learn the implementation too, because like you practice basically recursion, and like it is like a LeetCode problem. All right, so there is nothing bad to learn. Heap sort, and I think, yeah, so sift down methods. All right. So now we continue with arrays. So like we mentioned earlier that we're gonna study string class, which we have done today, an integer class, like a common method, and arrays. Like we need to know some common methods from these classes. What we are building, given an integer array, all right, we are like print the sort of descending, so not ascending but descending. The concept you'll practice array sort. Like I've used this method in LeetCode problems when I need to sort basically. Like there is array sort and collection sort. Like we have array sort and collections, like collection sort. So like now we're gonna study these ones. The concept you'll practice, and the trap that there is no comparator overload for integer array. So descending forces a design decision. The trap that there is no comparator overload. So guys, so comparator overload is the term we use, like something like that, like a b, and then like we were doing something like this. No, like this one and minus b0. Like this part decides the order. All right, either it is ascending or descending, I think. So this is called, like this concept is called comparator overload. So let me create another mark for arrays sort, and here let me take a screenshot of this part and paste it. And also I just want comparator overload. Like I also want to type this convention, like because I want to learn it, all right. And it also resembles like a functional programming. Like in Java we have like some functional programming features too. And also let me all right, let me open this one too. All right, I am now back. Comparator overload. Seems fine, I guess. Maybe I can turn the sound a little bit low, right? First question, predict before coding. Array sorts an integer array ascending, but the question asks descending in place. You want descending, yes. Your gut might say pass a comparator like yes. Try that mentality. Do you think array sort even compiles? If not, what are your two options to still get descending order? Tell me whether maybe we can like take a negate of it and then sort it. Like it may sound funny, but maybe we can negate of the input array and then sort it in that way and then take the negate again. So does it sound silly? Like this is the first thing comes to my mind. Um, uh, where did you see it? I think it is the code of certification, like an Oracle certification. Um, where did you see it? Like first of all, like at first I wanted to create a study note for me, preparing me for Java interviews, and this is what I just used, and the name I guess comes from there. But and then I just updated the prompt. Yeah, where did you see it, man? I guess it is like Oracle Java certification. Not silly at all. That's a genial alright, and it works. Negate every element, sort ascending, negate back. And here it is, descending order. It's a real technique. It's how you fake a max heap with a min heap tool. Ah, push minus x. Alright. We have a for loop. We negate it. Yes, we like a rewrite. Oh yes, this is also how most people work with binary heaps. All right, binary heaps. Arrays that sort. So guys, like in most of the greedy problems, the logic that we are gonna build is based on the sorting. All right. For example, if you have a sorted array, all right, you can build this logic, following logic. If you have a left pointer over here and a right pointer over there, all right, when you go invert, what would you expect these numbers to be, guys? All right, you can expect these numbers will go, I mean, left point, while upon left pointer goes invert, all right, you expect the numbers will go higher, all right, and for right pointer it is the opposite of it, the value will decrease. So meaning that, let's say you are looking for two numbers that will sum up to a certain number. Let's even call it like a pointer one, all right, yes, pointer one and pointer two, let's say, all right, these are not pointers but the values, but let's say pointers, and they sum up to k, some value k. If you have a sorted array, and if you position your pointers leftmost at the leftmost side and the rightmost side, actually don't use the pointer one, but let's call it x and y, all right, x and y. And let's say your pointer one is here and pointer two is over there. So let's say you start at these points and you like sum these values, all right, and the value you get is, let's say, bigger than the value you need to find. So what you need to do, decrease the amount of this phrase is, right? To decrease, what you can do, move the pointer to, yes, isn't this grid 2? Yes, it is. It is. The way to find like a smaller phrase, you must move the pointer 2 to the left. Yes. Yes. If you find value, the value you get from this is smaller than the value you need to find, you need to increase this. To increase this, you need to move the pointer 1 invert. All right. So why did I say this? I said that because like to build this logic, first you need to have a sorted array, all right? Without this, you cannot do anything. So, and there is a cost for that. The cost of sorting is mostly n log n. All right. And also, like for sorting, actually, the brute force approach is n square, because you need nested for loops, all right? Because you need to compare each element with each element, basically, to decide whether you position it. So, and each sorting algorithms, like a bubble sort and merge sort and heap sort and etc., and quicksort. These are the common ones. For all of them, they do they do something little to make them a little bit better, all right? Because they have like a structure like a for while, like stuff like that, right? And sometimes even nested for loops. But they handle this sorting in a like smaller, like a they do some small operation that makes it better, like a better than nsquare. So continue. One caveat to file away, you'll appreciate it after I8 range talk. Negation breaks on overflows. There is no in this one. Sorry guys. Like for integer, the maximum value we could get was 127, right? But why now integer mean value? All right. So this is integer class, not a primitive integer. So it silently stays mean value fine for normal data, lands you in the same overflow trap the reference warns about, and you all right, I said that like our question was sorting, like a sorting in descending order, but the default method of like a default version of array sorts in descending, I mean ascending order. Like it sorts in ascending order, but the question asks in descent, so we need to transform into this, all right, the descending. So my approach was negate the input array and then apply this method and then negate back again. But it says that if you like let's say you have min value and you need to like you negate that, what you'll end up with is like this one, and you cannot hold this number. So it silently stays min value. So like negating is a dangerous process, all right? And you quietly answered my compile question with your workaround, confirming the key fact. Does not compile. So I thought that maybe we have a sort method that also takes comparator, all right? But I guess there is not. There is no one. Like there is no such thing. So primitives have no comparator overload. So primitives don't have that, which is exactly why you reached for a trick. Yes. The two textbooks roots are box to integer array. Now a comparator overload exists. Our array was like an integer array, right? I mean, the question, yes. So our question was integer array. Well, yeah, 1 bit is for sign and 0 take up 1 positive slot. So you get, yeah, 2 to the n and 2 to the n minus 1, yes. Like, I understand, but I didn't see how it works because like, where is the sign bit exactly? Like, I need to see it, all right? So if we box to integer array instead of a primitive integer array, now we have comparator. Like, I didn't pay an attention the input actually, but since it's primitive type, we don't have like a comparator, like a comparator constructor overload. But if we box it to integer class, we have. Now a comparator overload exists. So if we box our input to this, now in arrays.sort, like we give our input array and then the comparator, then we can sort in descending order. The sign bit is at the, yes, at the front, by the way. Yeah. Most sign, yes. Most significant bit, yes. This is called. But the thing I wonder is like, let's say I have this number, all right? What is this? 10, right? And if we are using this as a sign, the bigger number we can get, like the biggest number we can get is 1, 2, 4, 6, 7, right? What I mean is, what is the cost of using this as a sign bit? Because you say that for negative ones, the smallest one we can get is this, and for positive ones this. So what is the binary representation of this? What is the binary representation of this? So I need to know this to understand. The rest determines the magnitude. All right. Let's say 2 to the 6, 44 less sum is 0, 1, 1, 1, 1, 1. Oh, all right. So you say that this is. How about this one? Is it just this? Or like if we add 1 to it, it becomes this one, right? And if it becomes this one, so we can make even bigger. So what is this? Is not representable. Why? Because we are using, if it is like this is minus. Oh man, how do we convert negatives to positives? I forgot, man. There is some conversion logic, right? Turning negative numbers to or only this bit. Let me take a screenshot for use tools. Yes, tools complement. I forgot how to apply tools complement. Tools complement. Like we studied at uni, but I don't remember this at all. But for the sake of time, I will check this after the stream. All right, let's continue. Let's continue with arrays method. But I should study this again. So for the sake of time, for now, like knowing you flip every bit, then add 1 to least significant bit. That's literally too soon. All right. Every flip, then add 1 to least significant. Like the least significant bit is, so like flipping is like a 0 this, and if we add 1, we get this one. I'm confused. Or we first calculate the positive, let's say like this one, all right, and then flip and then add 1, right? Oh wait. Yeah, similar to that. Like I remember, but I slightly remember. Yeah, you convert from the positive. Yes, so this is it. We flip it, all right? Yes, and then add 1. So this becomes what is this number, by the way? 1, 2, 3, 4, 6, 7, 8, and plus 1. So 2 to 6 was so 7. Oh my gosh, am I doing something wrong? 1, 2, 3, 4, 6, 7, 8. Yeah, but 8 is quite big. How do we end up with this big number? Like, which number are we gonna get after? Like, we have this number, all right? We flip each bit and then add plus 1. So what do we expect? I forgot to represent negatives. Use subtract positive values. Anyway, we can look it up later, all right? For the sake of time, let's continue with arrays class. But I should definitely check two's complement. Like, I forgot. I just remember, little. All right. Um, so we basically box to integer class, and then now suddenly we started like a being able to like a using comparator. No worries, like we can look it up later. So what I want to see is the implementation of this method, all right? Thank you for showing this sort method. What I wonder is like implementation of this method, because previously we um, we studied we studied string class, and there was a method. Yes, there was a method that takes an argument like a iteratable and then arrow and then question mark extends car sequence. And my friends in my stream said that this is the decision that the author of this library or framework or language written this so that the coders like us that will extend, let's say, car sequence class, all right, can use this method. So I think it like the join method in string class was taking the second parameter, the second parameter, and the type was this one. So my question now is that I think sort method here has something similar to that, all right? Has something similar to that. Can you show me basically? And does it have like a method overloading? Because sorting may have like overloading or something. Let's see. Because this kind of methods that I've been avoiding for a long time. Like, look at it, bro. Like, I can totally understand why I've been avoiding it. Like, look at this type, bro. That doesn't look good at all. But I eventually understood with the help of yours, guys. With the help of you. Help of yours. Alright. With the help of your help. It doesn't. Yes, like it doesn't, man. Like this is a type of parameter. Like Gosh. Let's go. You connected two things correctly, and there is beautiful symmetry here. But with a twist, the white card points to opposite direction, and there is a reason. I meant at least Rust makes it more understandable because in Rust you can actually name generics. Oh, that sounds nice. So that the generics look easy. I mean, like a normal, at least. Not this like a horrible type, like a monster or something. Wildcard points to the opposite direction, and there isn't. Let me show you the real signature. It's heavily overloaded. Yes. Oh, nice. Heavily overloaded. There are many sort overloads. Two families. Primitive families. One per type. Natural order only. No comparator. So in ascending, I guess. We can sort an integer array, we can sort a long array, we can sort a double array, we can sort an integer array with like a between range. All right, these are natural. Object family, object family. Guys, this is where things start getting interesting. All right, because if you are working with primitives, like they seem alright, they seem just fine, right? Like a normal human, like normal. But when it comes to sorting objects, you need to know based on which properties of those objects you're gonna compare them and sort them eventually. This is the comparator one you called. So, and also this is why we are able to use comparator in our functions parameter after we box into integer class. Do you get it? This is the comparator one you called. Yeah, so like we have the sort method again and we overload it basically. And now the array has items in object type. And we have something here. I don't know what it is. We can ask why do we have this over here? Yes, because a generic function is like public example type implements iterable and array vector type. So here the generic form of type is stated to represent anything that implements or is iterable. Pretty clear. So actually, this is clear too. Like this is clear too, because we are saying that type is stated to represent anything. Like anything, like anything is question mark here. That implements. Here we extend. We are not implementing, so that's a question too. Like this is not a relationship, but has a relationship. I have another question now. Implements or iterable? I need to ask this. Like, because if we used implements here, I would understand what you have written. Let's see, man. Let's see. So we're gonna ask this, all right? Remind me about why in Java it is extends. But because I feel like it should be implements, because implements is a relationship, but it extends. So basically, that class has the methods. Yeah. So we can use child class whenever the parent class called, but then why the extending, like why is the extending keyword called like a has a relationship? Because basically you can use the child class whenever you see a parent class. So it is like a is a relationship. We need to ask about this. So here we are doing some method overloading, and I understand. Extends tell you at minimum this unknown type must inherit X. Yes. Uh, yeah. Extends tells you at minimum this unknown type must inherit. Yeah. Basically, it masks it, so something like works on integer, double, and etc. Yeah, yeah, yeah. Yeah, yeah, yeah. So like I understood that part, but yeah, yeah, so like you are saying correctly. Definitely, definitely. You say like you write your methods parameter type as a parent so that you can put its children when you are calling. All right. So you define once and with a generic like a overall type, but you can call it with lots of different choices, and there obviously is child, like is children, like that number class is children. Yes, correct. Yes, and extend is more so yes, inherits. Yes, is a child exactly. Like we overload the method both parameter wise and the return type wise, but that's interesting. No, the like the return type is same, but what is it that what is this? But super ask for a parent implementation. Yes, there is a super method. So like basically like the child class. All right. So like let's say you are child. All right, child class, and we have our parent class too. So when you instantiate this child class, what you are doing is not like creating a separate class, but instead same parent class, like this is the parent class. You instantiate parent class basically with the new like a like extended part. All right, this is the child class. This is how it looks under the hood. Basically, if super integer, it works for anything that is integer or is a subset of integer, like a custom made integer. Exactly, bro. Let me take a screenshot of what you just said and put it into my notes, brother. Thank you for that, man. I can make it even like with colors, bro. It's the same parameter. Also, this t is a compile time known generic. Uh, yes, but does it something have like does it have something to do with the return type? Because the return type is void here. Like it doesn't return anything. And if it doesn't return anything, what is this? Compile time known, compile time or runtime? I think it is runtime. It's the same parameter you give to an array list. Array list number, that the number is t. So while you are writing a array list, like array list class, literally, you used it. No, it's something that marks the function call. This t must be known at compile time. For runtime known, I mean, let me ask. So these like I am struggling understanding these generics like a T, and then like while we are creating like array list class or something, I see this a lot, and also we have this in like a join method in string class where the parameter type is iteratable question mark extends car sequence. So I'm struggling understanding these generics. So could you please clarify the logic behind these generics and in which Java version uh, did it started existing? Because I think in early generation, like early phase of Java, we didn't have this basically, and we had a problem for when I guess in runtime. So the generic approach solves these runtime issues basically. But what I want, like what I want to learn this, and what I want to learn also is like this, like does this generic help us in for compile time issues or runtime issues? Explain this by giving examples. To be honest, even I am. Don't mind me. I might. No, no, no. Like, just say it, bro. Rust. This is so much more cleaner. Yeah, yeah. That can be true. Yeah. Like what I'm trying to do now is like understanding the logic behind building a language called Java, how the object-oriented principles applied in this language, what are the fields that this approach fails or some issues, and how is it solved. For example, let's say today I learned that in Python, like a join method, like I used using an instance, but in Java, it's a static class, like a static method. So like there are some different design decisions over here. So like a by cross checking, like a cross referencing, I'm trying to understand the programming idea, like a approach, as a designing approach. And also we are preparing ourselves for interviews. Sorry if I glaze Rust a lot. It's my favorite and main language. That's all right. I write a lot in. So there's that. In Python, it's also oh my god. There is a like TV Josh here earlier. He said that the join method is like a instance method, and he also gave this one, and also like it's this seems instance method is the same as str join. I see. I see. But if you use in this format, I think you oh my like is the same. Like they could be doing the same job, but I think here this is string. So this is string instance, right? And we call a method called join, which is written in the string class by using the object reference. Yeah, yeah, like it can be doing the same job, of course. Like what does like str mean, by the way? Like is it a class in Python, by the way? This is important. I assume there is a class called like str, and join method is defined in itself, is a class, all right? So you are saying that it is static, but if we can, you can call it class dispatch or object dispatch. Wow, what is that? Like I heard this dispatch thing, but I forgot it, man. Let me paste here too. Also, object dispatch is your. All right. So you are basically calling a function using an object reference. So this is object dispatch, object dispatch. So understandable. All right. This object dispatch call you directly on the object. All right. All right. All right. All right. Yeah. Yeah. So you can call this join method object, like applying object dispatch and also class dispatch. So like, are there two versions of same join method defined in the str class? Like there must be. There must be two different definitions. All right. Like you should have said this earlier. All right. Get it. All right. We have two different definitions of the same method. Like it's like a method overloading basically. I get it now. It's the same. Oh my. Like you can call this join method using object dispatch and class dispatch at the same time, and you are saying that there is only one method definition. How? Because in Java it is not possible. A method either static or you know, object reference, you know, reference type, instance type. Like no way. At least from the Java eyes, I don't see any possible way of doing that, because object dispatch just calls. Oh my gosh, object dispatch just calls class dispatch under the hood. It's literally just an abstraction. Oh my gosh. Oh my. Let me take a screenshot of what you what you have just said and color it with these colors. All right. So add me also. uh yeah, I have Python and object dispatch, and also Python, I mean that one, and then object dispatch and class dispatch. I don't even call. Yeah, yeah. So like you are quite familiar with those languages. That's quite nice, bro. I thought this was like we're gonna study Python today too, so we can start with this topic. I don't even code much in Python, so like good, bro. Like knowing this much, very nice, very nice, very nice. Even without coding. Where were we, guys? I guess we were here discussing about the method overloading and discussing about these like this generic thing. All right. I still didn't understand why, like, what is the purpose of this, but we're gonna learn. So again, we have something similar to join method. Maybe I can take a screenshot of it too, and in string class, I can paste it and add a maybe caption. Uh, it is like join method overloading. Yeah, yeah, no worries. It might just me being able to know a lot due to low levels. Oh, but don't mind me. I don't mind you to. I don't want you to understand. No, no, no. Thank you, thank you, thank you. There's no problem with that, man. Like there is no end for learning. You know, there will be always people who know more than you. So like that is just okay, bro. There are some things that I know that you don't know, and there are things you know and I don't know. So that's understandable. But I like people who knows like a deeply, all right, about languages and how they work, like how the compilers work, how the languages work. Like this is good. Yes, yes. Um, so like we have a parameter for our sort method, which looks which looks interesting. I guess T is, I don't know what T is at all. So I might be able to get some intuitive, but I might not get some. Yeah, yeah. So like that's all right. That's all right. That's why arrays that start comparator doesn't compile, because like as we like the type we put as the first parameter defines which method, like which method you are going to use. And if you use primitive type, there is no second parameter, so this is why you cannot use comparator. But if you box the integer array into integer, like a real integer class, then you start being able to use comparator. That's all. So let's implementation of your call. So there is a sort method and comparator, like a parameter that whose type is this one. All right. And if it is like, if we don't give any comparator now like information, we sort it like a natural order, like a like sorting object, like this one, I guess, like this one. Legacy merge sort. Oh, like Java does the merge sort under the hood, guys. uh if user requested, all right. If not, it uses team sort. I don't know what it is. Team sort mesh, yes, like, yeah, you said it, man. Like it was like it was the first time I seen that name, like when you mentioned. I didn't know it at all. Like, I wonder how it works, man. Like, is it complex? Java uses team sort for sorting. That's wonderful. So like, that's interesting. So under the hood, it delegates to team sort, a hybrid. Oh, merge sort and insertion sort. Stable and login, and passes your comparator down to decide every comparison. That's nice. So it's the hybrid solution for sorting. Like, maybe we can study this in our one of our stream. Look at look at the two side by side. So the join. Oh, wonderful, wonderful, wonderful. So let me take a quick screenshot and array.sort, paste it, click it, and then like we must have a screenshot of it, but I just wanna take a screenshot again, but we don't have it. All right, so that's all right. Correct though. It uses a bit of heuristic rules. All right, like we can check it. That's why yeah, we have read this part. Yes. So join method, like it takes a car sequence as the first parameter, and for the second parameter we have like a something likely here, like a extends, and here we use super. In specific, it uses pre-existing patterns in the sorting pattern to do it if no set pattern occurs. In specific, it uses pre-existing patterns in the sorting pattern to do it if no set pattern occurred. It is worst case and yeah. All right. It's not credible as quick sort. Yeah, so we should definitely do a stream for sorting. Like we have like this type, like this is a type, and this is type 2. Like we have like iteratable comparator, and then question mark, and then super. Like, your friend is right that bounded wildcard exists, so the method accepts a family of types, not just one exact type, but y extends in one and super in the other. This is the famous PEX rule. Oh, producer consumer. So Join's iterable is producer. Join reads character sequences out of it. A producer of character sequence or any character sequence or any subtype is fine. Yeah, here we say that character sequence or any subtype is okay. It's fine. All right. You can pass a list of string because string is a char sequence. Mm, all right. All right. So, all right. Now I see. All right. All right. All right. Sort's comparator is a consumer. Sort feeds T elements into see compare T1, T2. So you can use a comparator that handles T or any super type of T. Like the payoff of super in sort, a single general comparator works for many element types. I think this is one liner. Comparator object integer compare. So we can even compare the hash codes. Integer compare, like integer class has a compare method. Compare method. So I guess it calls which method under the hood. So we basically like let's say we have a string array, an integer array, and comparator object is a super string, super integer. So by hash, all right. So by hash is this type, and we basically define how we should compare these. Like this is a function. Like this seems like a function. Like we define how we are gonna do it, and we pass this how we are gonna do it to as a parameter. Comparator object is a comparator super T. I think I will understand if you and I think I will understand this a few days later. Let's paste it and like what was the no. Anyway, let me assign a color. So without this one would be rejected. It would demand exactly comparator string, and your reusable wouldn't fit it, even though it can perfectly well compare strings. So the Mendel model, you read from it, producer, give me an X or anything more specific that extends X. You write into it, consumer. So I'll hand it an X, so it must accept X or anything more general. Anything more general. I don't get it. Joey reads from I guess my brain doesn't process right now. Let me take a again quick screenshot and paste it over here, and let me type it. This sounds good. Producer and consumer. I think this is a design pattern, right? Design pattern. I didn't understand. Like I genuinely didn't understand. So let's read this part as well, and then wait. I think it is because the opposite rule. Um. All right. So yes, like kind of opposite, but I think for super, you either get a string or a parent of it. Oh, string is the minimum. You set the minimum. I think like yeah. So like in one of them, so extends is the opposite way. Yeah, yeah. So um, you get either a string or parent. So in one of them, like in one of the options, all right, producer or consumer, I don't know. In one of them, you say that this method will can accept string or parent of strings, if any. I don't know, like we don't know, like a parent of string. And the other one, like another one, let's say you like you accept either string or children, like who extends like a child, like a like child string, let me say. Like my logic did a negation on, on the logic. No, no, like I don't know the direction, but the logic, the core logic is something like you say like in one of them you create a method that um that starts from like that accepts a parameter that starts from a certain point and all its children, and in other it accepts a class and also its parents. So like I am quite familiar with this type, like with this type, all right, because I have used this type, like this type, like because this is the easiest part to understand. Uh, yeah, yeah, they are top down and bottom up. Yeah, yeah, something like yes, the notation, because like you are writing a method, basically, all right. You are writing, let's say you are writing a method. If you give the parent like a parent A, all right, like you can give lots of things to this method if you have classes that inherit this parent class, all right. You can call this method like a child A, like this, like I totally get this part, but like I get this part, but if like we are saying that like we accept the string like a class and their parents. Yes, yes, this is an extent form. Yes, this is extent form. Like yes, this is extent form, but I'm not familiar with this one. You extend from top down, and for your super ah for super bottom up. So this is super. Super goes child from parent. Yes. So this is extend and this is super. Yes. All right. Yes. I'm getting it. I'm getting it. All right. But why would I need this one? Like I totally get this one. All right. Like this is acceptable, bro. Like you just type of one method and you can call it child, like children one. Like it's understandable. It's quite logical. Like I can easily understand it. But why would you need like a accepting like a like a child, like where, like if I see an example for this case, then I will understand it. So maybe before reading that, thank you. I haven't read the last part you gave. Like I will read it, but the thing I wonder is, um, like from like when we use super keyword and except taking parent types like as a parameter, like can you give an example where this is used? Like I totally understand the extend keyword here for our join method, for example. All right, in our string class we have a join method, and that join method takes a second argument, and that argument type, like that argument's type, is something looking quite ugly, but it extends basically, and I can understand the logic. All right, because you type a method with the parent type, and if you have a children, like if that class has children, you can pass them too. But whereas like in super, I don't see any like a real world like I don't see any basic examples. Can you clarify this a little bit? um because you might have something like super coordinate. This allows for any coordinate systems to work with function. Oh, though I might be wrong. Let's see what class says. All right. So like, and then we're gonna like read this, because like I've been avoiding this for a long time, guys, for a long time. Like this isn't that hard, so I think we can like I can learn this today. All right, I want to learn it, bro. I want to learn it. Come on, we can do it. Great instinct. Great instinct. It says to you works, okay? Super clicks the moment you see shared comparator or shared handler reused across subtypes. Here's the cleanest real world one, and it's like it's exactly the sort case made concrete. The example, one comparator for whole family. So animal class has a weight, and dog extends animal and cat extends animal. One comparator written at a parent level compares any animal by height. Like we create a comparator, I think. Like what is this, man? Like is it a function or something? Let's assume I understand it. All right. So what it does is compare by weight. Like let's assume. All right. Because like is this a value? Like what is that? I think the type is comparator. Like anyway. Um, yeah. Let's assume we understand all the remaining part, and the core part is compare based on weight. I will read. All right. Based on weight. So we create list of children and list of dogs and cats, which is their array list. When we try to sort them by weight, so the sort function takes a function. You need to pass a function reference here, and you pass it, and you can sort. This compiles only because list sort is declared. Default void e here dog, all right, a child. Child. Like we share the child, like children. I thought this is a parent. It is a child. All right. So any class that dog supers or this allows you, yes, yes. As I said, is for something like that. That's an anonymous function basically find his lambda function. So a bottom up, a child to parent, bottom up. So we are doing bottom up. Yes, child to parent, child to parent. So this is a child. So comparator is a comparator. So like the animal, like this one is this one, because dog extends animal. All right. So this convention, like a question mark super dog, basically says dog is the child, and we are putting any like any parent class, any parent class that, like, of course one class, because every class extends only one class. So this question mark means a class that dog extends. So if it fits, so without the question mark super would demand exactly comparator dog. So your reusable by weight type animal would be rejected, forcing you to write a separate comparator dog and comparator cat, etc., duplicating the identical logic. The mirror logic, this is what makes it intuitive. You already nailed extends. Super is its reflection. Philip read out to put in. Put in. Extends like a question marks extends t. Whatever I pull out is at least a t, except t or any subtype. Any subtype, because like when you are writing a class, like a class A, you write class A extends class B, all right? So you just like you type question mark extends T, all right? Right? Yes. So like you write here subtype. So any subtype that extends T, all right? And question mark super T, question mark super T, so if this is about subtype, this should be a parent type. Parent type, let me write. Parent type. How on earth understanding this part is easy, but this part is not? Like we are looking for a parent type that our children, like our child, extends from. So basically, from perspective of this child, like a T child, we are looking for a parent, and this is how we do. We are looking for a parent. We are looking a parent of T. The handler must be able to swallow T, except T or any supertype. All right, supertype. So instead of a parent type, let's use the correct supertype, or even let me say parent. Like always supertype. All right, supertype. Supertype is good. Extend is a top down, a parent to child. Yes, it could be something like, I don't know, a JSON file. Basically, we might be looking for a JSON file object that at minimum implements like a serializable. I don't know much though. Super is so confusing. Yeah, so like we can go easy, all right? So like we know the extend keyword, all right? This is easy. But like with this convention, what we are looking for is classes that extends T. So like we are looking for children of T. We are looking for children of T. So this is easy to understand, children of T. And now here, what we are looking for parent parents of parent or parents, one parent, it like, can it have only one parent? Can it have only one parent? We are looking for T or its children. They are not exclusive, by the way. Something can have multiple. Something can multiple parents. Multiple parents. Are you sure about that? Because a class A only extends once, all right? But there can be some other classes, like a class C extends B again, so extends B again. So there are lots of classes. Well, so here we can put class A, class C, class D. No. No. We cannot put. This is for this part. For example, string has parents, object, and card. Yes. But no, it implements car sequence but extends object. I wouldn't call it as a parent, like because string class extends object, yes, but implements this car sequence. Welcome back, Americano. But pretty sure car sequence is its super type. Let's see. It implements. So like, I wouldn't call it as a parent, like, because we use, like in Java we use parent when we inherit. Actually, this is a wonderful question. Let me open another. Oh my gosh. Let me open another terminal. All right. Like, because, like, let me assume. Now we are studying with my amazing friends. All right. Americano beans and just so okay. Like, work so okay. So now what we wonder is, like in Java, like string class extends object class, right? So every class extends object basically. And every class can extend only one class. But this string class is implementing car sequence, and like some other more. What we wonder is, like, can we call those other, like, interfaces as if they are parents of string class, or we can only use this for object class. Like object class is parent of string class, and string is a child of object class, right? Like, this is my first question. My second question is, like, for example, in string class we have join method that takes an argument of something like a car sequence, or like extends something like a strange type, all right? And this is, I guess, producer uh, design pattern or something. And also, uh, in sort, I mean, um, in arrays class we have a sort method. Like I get, like, we have lots of sort method. Like we have overloading. Like we have overload versions of sort method. All right. And in one of them, we have, like, we sort a list of objects, and we have another sort method, and its second, like its first argument is arrays of like array of t's, and the second parameter is comparator and question mark super t. Like what I'm trying to understand, like the second question is that like I totally understand um, the producer part where we just like use like we use extend keyword. Like our goal is like accepting all the parameters that has type, like that is child of a certain type. Whereas in super, we I guess we accept types that has certain parent. I don't know. Or like we accept a type, we accept types which is a parent of certain type, right? Like we accept parents. So like I'm trying to understand this. So can you help us a little bit? Um, does this include inter? What is that? A very needed question to answer. Without it, this extensive logic is gonna kill us. Maybe super asks for a constituent and such. Basically, it asks for a minimum. Actually, like this should be easy. Like this should be easy, but like this is gonna be easy once we understand it. All right, we are getting closer and closer. Um, just see, all right, just see. Like we are getting so closer, man. Yes, it should be, but Java apparently hates readability. Yeah, it can be. I don't know. Great question. These two actually connect to the same idea, the type hierarchy. Like type hierarchy, guys. Like this is the term. This is the term. We understand, all right? And how Java decides X can stand in for Y. Let me take them one at a time. Are interfaces parents to or only object? Yes. Oh my gosh, you are definitely right. You are so okay. Interfaces parents to interface. Yes, interfaces are absolutely parents, super types. Java just uses two different keywords for two different kinds of parenthood. Oh my gosh, two kinds of parenthood. Two kinds of parenthood, guys. The like a extend object implements serializable, uh, comparable string, car sequence, constable, constant. So many interface parents, implicit one superclass. Um, like a superclass and supertypes. All right. Extends a class exactly one implementation and state like a fields. Implement interface as many as you want. The type and the contract. Uh, yes, but for polymorphism, can this object can be used where that type is expected. Both count equally. Every one of those is a real parent. Is a real parent. So we have string hello, we have an object that we share, like we share the reference. We have car sequence. We have comparable string. All right. String is an object. String is a car sequence. String is a comparable, like S S S. Like this is a child, and this is parent. This is another parent. This is another parent. So S is instance of, yes. So it is basically a child of car sequence, child of. So this means, like in real world, like the mistake I've done, guys, is that in real world a person can have only one parent, all right, like a biological. The mistake I have done is like a thinking biologically. We are not thinking biologically here. We are thinking in like a computer wise. In computer world, a class can have multiple parents. All right, so like we're gonna understand it. We're gonna understand it. Like we are getting it. We are getting closer, guys. So a Citroen or a string has one chain of class, like class ancestors, that always ends at object. Yes, but it can have many interface ancestors sitting besides that chain. Wonderful. All of them are supertypes. You can upcast to. Amazing. Why this matters in real code? String implement, yeah, so is exactly why this works. So a new string builder, append high, and like append car sequence, except, So like this method is written using car sequence, but you give a string which is a child of that class, so that like this is extent, like this is the part we like, at least I understood fully. You define the function with the parent's name, and you give a parameter with the child's name. The method author type the parameter as the interface parent. Yes, yes, yes. The parameter is the type of the interface parent. Interface parent. Like this is parent. So any child, like a string or string builder or car buffer, fits. Like any children, like any class that implements this class could be used for a parameter for this method. This polymorphism through an interface parent, like polymorphism through, like I thought that polymorphism could be done only using an extend keyword, because all the examples in textbooks, in documentations, like in forums, I've seen like a animal class extends, cat class, dog class, but like all the examples like were this. So that's why I tend to think that the only parent-child relationship could be done via extend, like inheritance. But interface is also supports this. Like, all right, like I knew this, but I didn't connect it as a parentship, parent thing. So any child, they all right. So this polymorphism through an interface parent, identical in spirit to ArrayList PC. So accepting laptop and desktop. So like you create your ArrayList using a parent type, and you can call it with children's type. One line. Yes, we know this. All right. Now the part where I didn't understand. The consumer side of that thing. Your intuition is correct. Let me confirm it precisely and then show why the rule exists. Like PECS, producer, extends, consumer, super. The initials. um yeah, so lower bound, like works okay, you said like a minimum level, as you said, like this is minimum level. We give the child like a grandchild, all right, and we can we can accept all the things going upward in the hierarchy. So let's assume you are a farmer. Like this method can accept the not president, like president is here. All right, president, mayor, all right, president. So you are a farmer, so we create a method that takes a type of farmer, and we put like we are putting this as a like a like a super farmer, I guess. We create a method like this, and this method becomes such that you can pass mayor as a while you are calling, and also you can pass president. I think this is it. Farmer, mayor, penguin. Yeah. So so literal issues was that Java doesn't tell you interfaces are also, yes, we learned that interfaces are parents, different kind of parent, but parent. Exactly why, as I said, I don't like. All right, so like we understood it, bro. As TV just says, farmer like a child of mayor, mayor child of penguin. All right. Um, like this is what these this convention provides us. We set the minimum as works okay said. We set the minimum, all right, and our method takes every parent, every parents of parents of the parents. Wonderful. Uh, yeah. So we bought auto like a outbox. I mean outbox or autobox. Box this integer array to like an integer class, a comparator type on number, a super type of an integer. Number is super type, so like integer extends number, so number is a parent. So we create this and array dot start sort if the signature had been exactly integer, this would not compile, even though a comparator number is obviously capable of comparing. I guess my brain started computing. So guys, really, really, like a integer number object. Yes. So when we use it like this, we accept the number, like a list of numbers and list of objects, so everything. So this is the part that makes it click. Take this, the actual list could secretly be, writing is safe, like an integer fits into all of those, like an integer is a number because it implements a number, and is the object because it extends object class. Reading gives you only object. You don't know if you'll pull out an integer, a number, or an object. So The only type Java can guarantee is the common ceiling. Object. Object is all you get. Extend is the mirror image. You read like I understand, like I know extend, all right. So like I learned today. Potentially, it's just that Rust has made me so type aware. Super is just very dangerous to me that I am kind of refusing to accept Java allows it. Accept that Java allows it. I like the sorting example. Yeah. Yeah. So we have a list that extends number. So we are looking for children of this, like a, all right. Let's say integer, because integer is a child of number. Like the return type of this is this actually, but since this is parent, this is okay. Every element is a number, safe to read. What if the list is really integer? Like this is not an integer. The one signature that shows both at once, real JDK. So we have a copy method. Oh my gosh. We use both like a consumer and producer at the same time in parameters of a single, like of the same method. Oh my gosh. Like, or oh no no no, you know, yes, like these are parameters of the copy, right? Like a destination and source. So for source, I didn't understand, guys. I didn't understand it at all. So like I wouldn't imagine like I wouldn't imagine I will use like these tools in the same function. Collections copy pours from source into destination. Source produces extends destination consumes super, yes, in a single method. That's the canonical example to memorize. So your summary was right. Extends, yeah. This type or any parent. Like we understood this, but like I don't see any type here. Like which type are we talking about? Like any type? Let's say integer. Like can I put integer here? Like can I put string? Can I put my own class? Like let's say we have a class called kinesin, all right? Can I put kinesin here? I guess yes. But how? Let's assume we put integer here. The source is the child, like a children, like a we are integer. We are integer, and we get children of ours, all right, as a source, and as a destination, we um we like the destination, like the the place where we copy our elements is like should be like, can it be the same, like like can it be the same or should we like use number or something here? Like the logic is this. Like the logic is this. We give so that this make is safe. This makes this copy operation safe. I guess. Um, so your summary was right. Yes. Want to make either of these stick by writing some code? I can spin up a tiny array store collection copy drill in Java, so you can watch which lines compile and which on your. Yes, please, but I got tired, guys. I could make use of a uh, quick break. It's been some time. How much time? Again, almost 3 hours. Like we take breaks in each 3 hours, guys, which is nice. Which is nice. And what time is it again? 12 o'clock. That's nice. So how many hours to go? More. So shall it be? I mean, my. So like let it create some examples, and then maybe we can take a like again 40 minutes break, right? Like actually not now, but maybe after 10 minutes. It is creating examples, and this is where we left off in the main one. Like we studied the join method and the sort method. I think like this is the summary of what we have, like a like summary of summary core parts and examples. I can give some colors, guys, lots of colors. Like if we manage to understand join method and sort method fully, then there will be nothing. Yeah, of course there will be some other stuff, but like this is the topic I've been avoiding for a long time. So I'll be quite happy if we manage to, like understand these. Uh, yeah, yeah. Like you are great, man. Like you have a lot, man. Uh, you have helped a lot, man, a lot. Um, so I think I should open these files. The mental model to carry away, tying back to your two original questions. Question 1. Every supertype, class, or interface is a place you can upcast to. Upcast to. Comparator super is just that idea pushed into type parameter. Accept the comparator type on T or any of type T or any. So the question I asked earlier is like a uh, like a same level, like a when extending we can put a sort, we can put parameter as a source, like a, let's say integer, all right. And we can Like our destination can be integer or above, like a parent of those. Um, I'm so super. I'm going to put things in. So give me a container consumer that's T or wider. T or wider. I'm going to take things out. So give me a sort of T or narrower. All right, all right. Wanna go to one level deeper? One level deeper? We are going into like a hardware. The natural follows on is the self referential bound you'll hit constantly in GDK collections max where T extends what? T extends comparable super T. What? Both wildcards firing in one signature, and it explains why enum string integer all declare implements say the word. I think this being this is just so it can hold minimum the biggest thing an object just in case. Don't you love it when Jenny? Yeah, yeah, I just love it, bro. What is this? Like, it should be easy. Guys, I've like we're gonna handle this using like a blender, guys. Like, solution to understanding any topic is creating animations. All right. Uh, let me let me open this here. So blender is an answer for our every problem, anytime, anywhere. So uh, I think I can open the original chat we had. We have studied bunch of stuff. Um, but the first animation I wanna see is let me copy. Uh, let me let me copy this part and open the original chat we have. So now I need you to connect to my Blender and create us an animation. What I want to see is that the example of join, like a join method from string class and a sort method from, I guess, arrays class. My goal is to understand the producer consumer concept and the convention of like a question mark super T and question mark extent T. Um, I need you to use like some camera angle, like a arc, ARC. All right. We have like a written notes about how to do it. You can search those files, and like I want to see them visually. So you should create some rectangles or something showing the child parent relationship, and from the example of like a real GDK or functions, I want to see which type I can give to my function for these two cases. uh, Suggest me some ideas and show me what you are going to build first, and then we can start animating. But first I want to make sure, like I want to be like on the same page because I want to understand this topic by seeing it, like seeing the child and the parent and this extends and like a super and producer consumer. All right, I want to see these transitions. Or even better, we can show like a child and its parent and its parent and its parent, so that the same method can be called using all of these. But we need to make sure that we use real Java classes and methods. That's why I mentioned about join method and sort method. All right. Let's see like how well it's gonna create our animation. Oh, like I deleted it, so let me find again in history. Click on that, copy it, paste it, but I have lost the part I copied from the other part. And let me copy this part. After this, we are gonna create animation for this. And also, like for camera angle changing, like in the same blend file, we can show different examples. All right, we don't need to create different Blender files. So for different examples, you can just turn your camera, like move your camera, like maybe cinematically. Like we have this info in our notes. So move our camera to like showing another example as we complete an example. As I said, like show me, like suggest me what we are gonna build first. Let us be on the same page, and then start creating that animation. All right. And for the like you should create this animation under related folder under Java, our Java nodes. All right. You can follow the convention of ours, like we create like a blender file, like a random file, and some nodes folder for the topic we are creating animation for. For our merge sort folder, you can see the structure there. Follow that convention. And pressing enter, and we're gonna wait it completes. All right. Now let me drink my water. One sip. The animations help a lot, guys. Now it's gonna connect to my Blender and like first will represent us the logic, the design logic it will use, and then like before taking a break, let me handle this so that we press enter and we just wait, because it takes some time, like maybe 15 minutes, 20 minutes, or even more, so that during the break time it will continue. So we would be as if we were working while we are taking break. That's the beauty of using AI tools. Actually, they are working for you while even you are on break. Like I dream about having an AI model locally, all right, which is smart as cloud code, like a Opus model. But for that, you need to have like a really, 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 really powerful computer with a lots of RAMs. But one day it will become true, I think. Where should this animation Does the design above. All right, so now we need to read all the conventions. Read all the conventions. I got your camera arc pattern, the save discipline rule, and the merge sort folder layout. Here's my proposed build. I'm not opening a Blender yet. Read this, tell me what to adjust, and once we are aligned, like this word is used in in big companies. I'll build keyframes and let you scrub before any render. The core idea: two real GTK methods, two opposite wildcards, one camera arc between them. Your child parent, parent parent, I mean child parent parent parent, same method callable with all of them. Instinct maps perfectly onto case, so I'll lean into exactly that. A platform A, yes, producer, yes, this is join. Real method, exactly. Real hierarchy, parent on top, children below. Um, yes, like these are the children of car sequence, all right? Car sequence class. So they implement this class like a car sequence. Candidate calls fly in from the site and gets stamped green. Yeah. Oh, but like look at these guys. Like we can call this very same method with different parameters. Like of course, the goal of having functions is being able to call them with different values, but these like the generics are about the type of those parameters instead of the values of those parameters. Like we are caring like we are caring about the types of those parameters, like of those parameters, like the type of this like a list of string, and the type of this parameter is like a list of string build. Like this is the type. Like this function is gonna get a parameter whose type is like list of string builder. Oh my god. So list of objects, list of integers. It says red, so not a car. So the integer is not a car sequence. So we cannot use that. We cannot use list of integers to join. That's interesting. I guess it is because integers are for a summation, subtraction, multiplying, and division purposes, not for putting them like a string, like a concatenated. Concept beat: an arrow shows characters flowing out of the iterable or into join. Yeah. Real ancestor chain. This is literally your child parent parent. Yeah. So what is a child parent parent? This should be parent child child. All right. Comparator object, or like a comparator number, like an integer. Like integer implements number implement like extends, I think. Object. I don't know, but this looks good. This looks good. So the thing I should decide is Java Generics wildcards is the correct path. Maybe we can take a 50 minutes. What do you say, guys? Like a 50 minutes break. That would be awesome. Oh, time is like is the stream good? Like on my phone, it is frozen. Let me open it. Uh, Generator for break, RNG. But what does RNG mean? Generator for break. Like I'm handling like a I'm setting the blender up so that during the break it will generate. Oh, actually it started generating, so I guess we can take a break, but random random number generator. So you are saying that we can decide the duration of our break randomly, but I should definitely take a long break right now. And also like that leave break duration. Yeah, to fit. Yes, you're right, but I cannot. How about your exam? Like, I guess you took the exam. So how was it? How did it go? I think I can like a trigger the build or something. Like I want to show the local time on my stream. Oh my gosh. Exam was good, not bad, not perfect. Around 80% is just awesome, all right? It is good. It is more than enough. um, I am live right now, so don't break anything. But I had a clock on my Study With Me 3. I guess after the break, uh, after the break, like my clock disappeared. So without breaking my stream, like can you bring it again? And what causes this? Like on my control panel, I click on break, and break auto switches the scene back to where I was, I think. But it may have some issues or some bugs. Can you find it? Because I'm gonna take a break soon, and I want to show the local time, like a local clock, on my stream right now. Um, so you are saying that 80% incorrect? No, no, no. Like it's gonna be 80% correct, actually. But try making your GPA above 3, all right? Mine is below 3, so don't ask me how much below it, but like above the 3 GPA is good. Like you should have like at least 3, all right? Art is my worst subject. Art. So was the exam about art? That's interesting. Like we had like some history, some chemistry, and some biology lessons during the first year. I see. I see. Hmm. Oh, I see. Uh, there are too many names to memorize. All right. So like before like 2 or 3 days ago, start memorizing everything, and then dump all the things you memorize. All right, and that's all. But for some other topics, you need to like not. I'm not talking about art or those kind of topics, but for real topics, I mean, by real hard topics, you should internalize, and it takes quite of time, you know. But like for as based on my experience, if you work 2 hours every day when you come back home, it is enough. But during uni, like you don't work like a regularly, all right? You just wait until everything got stuck, and uh, and you got stressed, and then you start working. Especially during first, yeah, it took me half a year to get the basics of chemistry down. Oh, yeah. Like there are lots of calculations in chemistry, lots of, oh my god. Luckily, I loved chemistry during high school, so but the calculation part for physics and chemistry, like like there are lots of numbers everywhere. I totally get why we need like a calculators, all right? Um, just switch me. I learned the concepts fast, but the hands on like calculations just doesn't work well with me. I see. I see. Like actually I love like a learning concept, like understanding these concepts are good. But still there are some parts you need to memorize, and I am avoiding memorizing, but I shouldn't, because as Neat Code once said, there are some parts you need to go fast and there are parts you need to go slow. You should find the balance. Same with programming. I'm very, very bad when it comes down to actually making. Guys, in these streams, we're gonna build tons of stuff, all right? Tons of stuff. We're not gonna go like into tutorial hell, because now AI is on our side, so that we don't need to follow a certain video, but instead we can go atomic. We can ask lots of questions, and I guess the animation is done. Oh my god, like it created quite fast. I mean, isn't it? Let us see what it created. Let's start with zero. From zero, we have car sequence, and not, yeah. Oh, all right. We should zoom in a little bit. Like a list of string builder, list of object, list of integer. Oh my gosh, what is going on? I think I should open the camera mode. Like this is not what I had in my mind. I would like think, like I thought about, you know like here it is, our clock. um like I tried, like I what I had in my mind was seeing a stack frame or something like a rectangle. This is helpful, but I don't understand anything from it. So maybe we should render this, and and then create another one. So the clock seems good, but position it on top left of my uh, study with me coding and lead code scene, and also in my break scene. You can make it a little bit bigger. All right. So after Cloud handles this, We are gonna take a break, guys. Can you save this file? And like I think like it this doesn't help me at all. We should create another one. All right. What I had mine was like a something like a seeing a rectangle. All right, and on top of it, the name like a maybe like a class and like a animal or something and a curly brackets. All right. Uh, what I see in this Blender file is like nothing but some rectangles again, but I don't see the hierarchy. Like what is like which one is child, which one is parent. I don't see like a like we need to design something that will indicate uh, the hierarchy. All right. First, save this file and then present me some ideas about animating these functions and different use cases based on the real world uh, method names. All right, with real examples. So I guess this looks just fine. Now we can take a break, guys. Like a 50 minutes or something. What do you say? I need to have lunch. I'm hungry. And maybe rest a bit, rest my eyes, and open some windows so that some clear air comes to my room. uh, 50 minutes goes, we'll also take it. All right, 50 minutes, it is then. So I will let my AI like AI continue from here, and 50 minutes break, guys. 50 minutes break. Like it's been 3 hours and 15 minutes, and this will be our like a lunch break. Which way of drawing the class hierarchy reads best to you? This is the real core, like this is the core visual the whole animation is built on. uh UML cards seems just fine. Elevation ladder, let's try elevation ladder, and let's also save the pipes. Which real-world GDK method should the animation feature? Like a collection copy. Mm, only the string join and sort. No extra faster to build. And let's start with uh, the just the core two, and then maybe we can continue. Let's press enter. Let's stop the counter. All right, guys. Now taking a break. See you 15 minutes break. Lunch break time. See ya. Break. Let's make it 15. Mm. Welcome, guys. We are back. We are so back. Let me slide down the sound a little bit. Is everyone ready for our next next session? All right. Welcome back, bro. Thank you. We are so back. Did you take a nap and now feeling any better? I feel better. I had my lunch. I had a soup and a what? A black tea, like a hot black tea, and then of course bread. And then I had dessert too. So I am up and running. We can tackle a lot of questions right now. All right. Every possible concept in Java, in Rust, JavaScript, every. Now I feel energetic. We can do anything right now. All right. I hope. Yeah. So now, where were we? We were we were creating an animation, and did it created it or just suggested the new? I think it just it just started. So now we should tell it to direct it to the correct approach. The hierarchy now. We don't have the animation. Let's see. Hierarchy now reads. Let me start the my special timer as well. All right, wonderful. So the hierarchy now reads as Java code cards on an elevation ladder. Yes, like we picked this approach. Your class animal sketch with the parent-child relationship shown three ways at once. Position parent up, the extent implements text inside each card, and then the rungs between them. I verified all three keyframes. Platform A, Apex, Platform B, the payoff beat. To preview, where is our oh, we have it, guys. I thought it didn't created it, but it has actually. So what do we have here? Like a producer, and you read out like a join method, it belongs to a string class and it is static. and as a parameter it takes this type of parameter, like, yeah, so literally we share, like, do we share the type only? Like, I didn't get this part. Like, are we sharing like a parameter that its type is this, or I guess that way, but I think we can render it now. It seems late. Oh, look at the camera angle, boys. Like like we are like we are watching a TV or something. Like, look at it, guys. Look at this camera angle. Oh my gosh. Are we in a movie or something? Are we in a movie or something? Look at it, guys. Oh my gosh. Let's continue. The consumer, like a consumer, it consumes. What it consumes, we don't know. So yeah, so I think we should just like a render or something, all right, and then see what we have actually. So let me do that. I think this seems just fine, but we need to render it. Could you please render it and create a MP4 file, all right, for us in the same folder, because I just wanna watch it in rendered format. And could you also say how many minutes will it take, or can you can you, like, is there a way for us to watch this animation with, like, without rendering, all right? Because currently I need to zoom in, like I see the environment, all right, but in rendered version it is something else, all right. Now, like, is there a way, or if not, if there is not, let's render it. And let me, like, give me a sec, guys, while it's running. And let me send a quick message. Give me a sec, guys. Let me hold on a sec, guys. I need to make it. Hello, welcome back. So, did you stretch by any chance? Yes, of course. Uh, because otherwise my back starts hurting me very bad. So, like, I even do walking just because, like, to be able to work or study more actually. So, thank you for asking that. I had a call with my friend from college, so one of my best friends. So now let's continue, all right? All right, good. Keep yourself exactly, bro. Because without health, you like even you cannot stand like on chair, all right? Your back hurts, your neck hurts, so they make you, uh, not available for working, basically. Not invalid, I think. Yes, invalid. So now, actually, good that we started the rendering before I took the call. So let's see how the Blender will gonna is gonna create our animation, because I wanna after having the animation, uh, I wanna go continue with the next topic. All right, we spent enough time on strings. Anyway, what are exact technique now, by the way? Yeah, that's also true. We studied string class and integer class, and now like it's time for to study the arrays class. Actually, I don't like it's a class, and actually we studied like a generic type, and like for in arrays class maybe a few function of that class, and then we maybe I don't know, like we're gonna continue with the thing that AI suggests. All right, since I guess it has created our mp4 file, and let me open that file. So in Java generics, let's see, Java generics, was it this one? And then renders, yes, so this one. So let's see how well it has created our animation, guys. Actually, I was gonna use the QuickTime player. Let me take it back here and start the animation. Let's see. All right, so what we have here, like this is the producer, so this is the one we know well. All right, the basically we add the parent class in the definition of our function, so that we can use like we can call this function using the child, like a children of this class. In our case, it is car sequence, I think, right? This is the parent class, and okay, we have join method over here. It takes a delimiter, and then this type. We have like a string class implements. So string class is the child of car sequence. All right, and every class in Java extends object class. So like extends zone. All right. Let me move it here. So calling this function using like a list, like a string builder list, is okay. Like string builder and string buffer also implement car sequence. So everything related to string class that they implement car sequence. So like this is logical because string is a car sequence basically, right? Like we can use, like we can call the function that accepts car sequence, and we can use it with string. And if you try to call this join method using a list of integers, this is gonna give you like a compile time error. So that it prohibits runtime errors. So look at this move, guys. Isn't it like, doesn't it look good? So for producer like extends, we like bound and below without. So for consumer, we basically make our function available, called by parents as well, parents in the hierarchy. So it is now for consumer. We have our sort method, which takes this as a parameter, like this integer. So this method is gonna take like a parameters starting from integer class and classes that this class extends or implements, right? So this class is parents, by the way, basically. So integer class extends number. So number is parent of this integer. So we can call this sort method using number. All right. So like this label is not positioned well, but so super type extends below. Yeah, super type up extends below. Exactly. So we like, I understood this after like a 2 or 3 hours. All right, Americano. After 3 hours. So the one-liner is super type is up, so making the function available for the using parent classes, and the extend is making the method. Yes. It's been 3 hours that we've been working on. So this is the one-liner, and extend makes the function callable using the children. All right, this is one-liner. But at least we understood, all right? So we can call like this sort method using integer itself. So like super does not mean like only available for the parents, but we include ourselves obviously as well. So like an integer, we can call this like maybe I can make it even bigger. So number is parent of integer class, like integer class extends this number class. So we can call it with this. Fun fact, guys, we can like there are two ways of making a class like a parent of another class. The first one is like extending, all right, and the second one is implementing. So here we see both cases. But if you try like a sort method, like a calling sort method with this type of parameter, you'll end up with I guess compile time error, right? So the Java doesn't allow you even compile. Like a comparator string, because integer class is not child of string class, basically. So by looking like by knowing that which class is child or parent, you can easily understand if this is gonna get compiled or not. So now that we understood everything with this one, I guess now we can continue with the next stuff. So thank you for the amazing animation. Now I think you can run checkpoint skill and save the progress. And now like save the progress, all right? Guys, maybe we should continue with collections copy, right? I mean, this method is sort method, and the first one was join method. Join method was static method of string class, and sort method was an instance method, I guess, of an arrays class. Maybe we should just create another animation. Oh, collections. I mean, do you know genetics enough? Do you think you do? What do you mean by that? So like I think kind of like I know at least now I know the basics. Like of course it is not enough because we've seen an example where there was something like nested extending, and also there was a function where we call like a consumer and producer at the same time. Basically, there's still the T stuff and the recursiveness. Yes, yes, like yeah, you're right. So what you are saying is basically we should continue studying this. Yeah. Um, Let me see. So maybe, well, I mean, you wanted to, yeah, yeah, yeah. So yeah, so because I like a, yeah, yeah, it's just gonna be how it is. Yes. So I have a project file where like they gave me like a 11 day for a project, like a take home project, and that time I couldn't complete it. But now with the help of AI, I can complete. But there was a there was a point where it says that use collections. In that time, I didn't understand quite like what do they mean by collections. But I think they mean this, all right? Because I thought they ask, I think like arrays or array like array list abuse like a collection, but I think this is yes. So like we if we complete this fully, and of course, guys, maybe one day we can do like a stream for that was a real interview question. All right, there was a 4 pages long PDF where they explain they give you like points. All right, do that, use these technologies. Basically creating an e-commerce website, but there were lots of specs basically. So maybe we can of course I will change a little bit so that this will be okay, but maybe one day we can make a stream about it. I used some of that before, like 5 years ago. Right? Yeah, I haven't used Java in quite a while. It's a miracle I still got the iteration. So I guess it is because you internalized or you captured the core idea. So let's say even after 10 years, you'll remember anyway, all right? Because the core idea stays with you for a long time. But if you memorize things, even one week or 2 weeks are enough, all right, to forget all about all the things you just memorized. So as you said, there was this T stuff and then recursiveness. I guess in our chat we talk about the like a T stuff, like a arrow T, and then closing arrow. I guess for sort method, we were doing some overloading for this method, and was this method inside arrays class? Like this is my another question. And also I remember that we were overloading all right, this method. And also there was a version of it where the return type was still void, but before the void keyword we had something like this, like a T enclosed by arrows. And then the the parameter, the type of the parameter that it takes was again some generics, and we skipped it for later, and now can be a better time to study on it. And then we had also some recursiveness, like a and recursiveness, and also there was a function where we use producer and consumer at the same time, and that amazed me, to be honest. But I didn't understand at all. I didn't I don't understand, I don't see a applicable place where like this solves a problem, or like it is used like in real world cases. Like I need to study these three things. Could you please help us? Yeah, true. Facts. Yes, yes. I mean, the uh, the most things you wanna memorize is maybe the primitive, but nothing else really. What about anonymous? Oh my gosh. Yeah, yeah. Uh, you're right, man. Like, yeah, yeah, yeah. Oh my gosh. Why do you remind me that, man? Like, I thought we are going fast and amazing, but you make me like a slow or something, bro. Slow or something. Yes. Unknown something like that. Functions, and then the recursiveness in generics, producer plus consumer in a method. What else we like? I had like I struggled uh, like a T thing, like a T thing. All right, T thing. Yeah, these are the stuff that I really like. I really know. I really don't have any idea at all. Uh you probably want to ask about those. Yes. Well, sorry about that. I can get them exactly. What are these anonymous functions? Basically, Python's Lambda functions. Java has something like that. Yes. Anonymous functions that, uh, like the core part is there, but you cannot reach it via reference. They don't have any reference. You just define there, and where you define it, you use it immediately. Kind of this way. Yeah. And also generics T is like now we're gonna study, all right? We're gonna see these three stuff like this one, Americano, like this one. Like we have a method calls nothing, but there is this thing that I don't understand at all. Now we're gonna study this. Yes, got it partially. Also, T on generic is just a type parameter placeholder. Like I guess it seems so, but like kind of strange. I don't know. I don't know. We're gonna figure it out. So thank you, thank you for reminding the whole three things that I didn't understand. But I really appreciate, all right, because I really need to learn this. They are used widely. They are asked frequently during interviews. So if I wanna call myself like a Java developer or any developer at all, like these concepts also you can apply to Rust, maybe C sharp, most probably to any languages. So these generic types is the foundational part of programming languages. We are not living in a, let's say, 90s or 80s, all right? These are the stuff we need to know. Got it partial. Kinda. The more actual description is that it's a compiled time known generic. So while the R code gets compiled, they know, I think. It just means I don't know what will pass through me, so just put it as T when it comes. But do we need that here? Like, I mean, we have, like, I would understand easily. Like if you said like a T here, or let's say I can understand this, and also I can understand this. But how about this one, man? Like what is this? Like how do we even set it? Like I can easily understand the type of the parameter should be an array of something, all right, and that something should be also like we also gonna get the same type or the parents type inside this comparator. Like I get it, but I don't get it this part. when it comes, basically you need to give the type, at compile time, and not yes, runtime. These were our lessons, just didn't get most of it. Yeah. So yeah, like I guess we had this during uni too, but I didn't get them back then either. This T is compile time known. As I iterate once more, it just means a type. Yeah. So I understand. But there are three T's, all right? This T, and then this T, and then this T, like as after the static. So which one are you talking about? So I can understand the two of them out of three, like these one, but I don't understand this one. I guess you are trying to explain this one as well, but I don't understand it. But we are gonna handle it. Like we're gonna figure it out. So these T's mean like these T's mean everything. All right, they are important. Java Virtual Machine just inject what you given at the first T to all other T. All right. That sounds quite logical. I get it. But how about very exactly, like this is sort method, all right? Like is this static? Yes. So sort method, like a sort method is in arrays class, and we call it like this one. So we let's say integer, right? We pass like an integer, and we pass some comparable, all right, with type int. I get it, but where is T? Where am I adding this T? While calling, I mean. I think while calling we don't do that. We don't add like a T is integer here, but integer is here, so there is no integer anywhere, like a here or something, right? This is what I mean. Or maybe we don't set this, but instead, while calling this function, we use infers T for you. Most probably, yeah. Let me read it now. And it's Steven Leaves collections, Java util collections for lists. Java util collections, we have sort method over here. Yeah, so now we totally understand this convention. Both are overloaded alongside the natural order versions. Both are overloaded alongside the nurture. So this is like this sort method is this one. Like, what do you mean by this example? So you remembered right? Same name, multiple signatures in the arrays collections utility classes. All right, T before void. This is the generic method. Declares a type variable T scoped to this method. All right. That leading T is a declaration. It says this method introduces its own type variable T. Figure out what it is at each call from the arguments. So by looking at the arguments, it understands the type. It must come before the return type, void, I mean here, yeah. The compiler then infers, yes, as works okay set, infers T per call. So public static, this method returns type T and takes an argument, list of T, and return this method's first element. And first of the like T inferred string in this example. And here t inferred as integer. Same method, different t. All right, all right. So we can call this function, since we add t over here, we can add list of strings, list of integers, list of any object, list of kinesins, I mean list of object, list of number, list of string builder, list of char sequence. All right. Why declare it all? Why declare it all? So every mention of t in the signature, like a parameters, refers to the same type, like a same type. And the compiler can enforce the comparator, like a comparator, must match the array's element type. Array's element type. Without the t, the compiler wouldn't know t is a variable. All right, guys, I get it now. Like, if we didn't use this t at all, then there would be no way for our compiler to understand this convention, because it could think t as a class. All right. This convention tells our compiler that now we are doing some fancy stuff, like generic stuff. It's legit Java virtual machine being smart. Exactly. Oh, so works okay. You said it correctly, but I didn't understand. But now I understood. It's legit Java virtual machine being smart. It's why you can do array lists instead of yeah. Is the t there is just an identifier that tells the compiler this use a generic? Yes, Americano, yes. T just an identifier telling our compiler that we are gonna use generic. Yes, like works okay, said yes, got it. Java virtual machine just makes multiple copies of the same function. Caterate to your given injected t afterwards. Yes, that's it. So it is like, instead of declaring it with t equals int and using t, we just put t to have t declare itself to whatever type it passes. I think yes. I didn't understand, but this seems correct. No need to do it yourself. That's the point of generics. All right. Yeah. All right. Why declare it all? Yeah. So the compiler wouldn't know. Yes, the compiler wouldn't know. T is a variable. Like look at it, guys. The AI said the exact thing that us, all right? It would look for the class literally named T, all right? So, like, this thing is just for our compiler to understand our intent, all right? Because we are doing some fancy magical thing over here. No. If I am a bit late, no. I'm literally somewhere. You are walking? No. Like, you explain it correctly, but I didn't understand it. But now it makes sense. Class level versus method level T. Oh, all right. So guys, we can use this T not only with our methods, but also with classes too. So, like, imagine we are like defining our method as like I mean this one, right? No, T, yes, I think this one, and also like a compare thing, and like a extends or something, and then T again, right? Yes. So this is the definition. Like, we can use these T's while like for our methods as well as our classes. Let's call our class, as always, Kinesin. I guess we can do something like this? What does it mean, brother? What do we get from by what by doing that? Like, this is a class name, literally. What is that? Class level versus method level. So I will take a screenshot of it, guys, and paste it over here. So T class declares T for the whole class. Yeah. So what? So what? Yeah. Oh, like declares T for just that method. All right. I think after after putting this thing here, we can use the same thing here, but still, like, it doesn't make sense. How do we, can we do stuff like a class, kinesin, and integer? Like, what does it mean, bro? What is this? What is this, bro? Sort is static, so it can't use the class level T. It must declare its own. All right. That's why static generic utilities all carry the T prefix. All right. Like, I think I didn't get this part. We can ask it later. Recursiveness. T extends. Oh my gosh, look at it, guys. Like, guys, hold on a sec. For extend, let's say comparable, we open this and we put like a question mark. I think yes, question mark, and then T, and then extends, and then let's say the integer, right? But for super, we again put question mark, and then like a super, and then T here. Like, for extent, we use T before. For super, we use it afterwards. Yes, T, like a super T, and no, T is always comes after the keyword, like a question mark, keyword, T. So question mark, keyword, T. So why do we have T over here, man? That's why I just got confused, you know? Like, this isn't a question mark. It is T right away. And then extends, all right. Like, at least here we have question mark, keyword, T. So this is the collection's max signature. You remembered, we skipped. So works okay, remembered. Not me. So the collections, like public static, T extends, yeah. T appears inside its own. Oh my gosh, guys. Read the bound as T must be comparable to itself. Or, guys, I'm losing it, guys. Where are we? Are we in Mars or something? Why does it have to be? To find the max, max compares elements to each other, so each T must know how to guys, is this Chinese or something? I don't know. I don't speak Chinese, guys. The interesting part is why this and not just that. And this, like, it is a real inheritance scenario. I guess works okay. Like, this is what you meant by inheritance, I guess, right? Like, yesterday or 2 days ago, you mentioned about inheritance in, I guess, Rust, yeah, right? And I told you that inheritance is easy, brother. But I guess you meant this, right? Uh, Wait, sorry, what was the question? Um, like we are like now we are studying like a recursiveness, we are studying generic, and we are studying recursiveness. You in generics, I guess. Guys, oh my gosh, no, no. Dog inherits. Oh my gosh, like why does dog inheritance such a bad, guys? Like as far as I know, classes inherits some other classes. Like, is this a class? Is this a class, guys? Like is this even a class? Likely, yeah. Like, like how do we write this class? Like a class and a comparable enable compare compara. Oh my gosh, comparable and animal. Guys, like, is this a class? Is this a class? What, Rust? What do you mean? Oh my gosh, like, is there a problem? Is there a problem with the audio? Let me check the stream. Pretty sure comparable is a comparable interface. Yes. No. He's traveling. So All right. All right. All right. Not your audio. All right. All right. All right. So wonderful. Like, comparable is an interface, but it says that like a dog inherits comparable animal, like a comparable. So like dog is a class, and classes extends other class. Like, I mean, yes, extends other class. So this should be a class. How is it a class? Uh, if the bound were, oh my gosh, things started seeing Chinese, guys. Would be rejected. Dog is not comparable dog. Guys. So, guys, what we are gonna do is take this, all right, and come back to our original thing and open another terminal. Be easy. Open another class session and then paste it over here. So now we are studying these generics in Java. Everything was going smooth, all right, until we've seen this recursion in generics. And then everything started shuttering. All right. I don't understand a thing at all. I am lost. Things started seem like a Chinese. And I don't know, I don't speak Chinese, all right? Could you please clarify? Like activate tutor mode 2 and with automatic steps, teach me this concept. Yep, traveling here, don't mind me. To be honest, I don't know at this point Java does get. All right. So let me fill my water. I can hear the frustration. Frustration. Recursive generics that, yeah, yes, is exactly where Java Generics stops feeling like containers of stuff and starts feeling like a logic puzzle. Let me bring up, yes, please. So, guys, what we are building a generic max method that takes an parameter, of course. The type of parameter is a list of t. So we basically can put like a list of like a integers, strings, like a Kinesin object, boolean, doubles, and everything. That's just amazing. The classic reason, the like a yeah concept why comparable t is a contract about you about who you can be compared against and why inheritance makes that contract sneaky. First question, anchor before we touch the scary part. Forget generics for a second. All right, plain Java. When a class says uh, in your own words, what power does the implementing give you a dog object? Like this is the question that I don't understand. One sentence. I want your mental model. So you asked amazing question, mate. Amazing, like you question an amazing question, all right? Wonderful. The thing I don't understand is like I know that comparable class is an interface. What I hear, like what I see here, is not only an interface, but it is not a comparable, like a only comparable. Like there is a generic type alongside with it. First of all, can you teach me this part? Like first of all, can you show me the interface, like a real interface, like a comparable interface? Like are there different versions of it? All right, are there different versions of comparable interface? Like where there is maybe only one comparable, like without any generics or something? And also since we are using like a comparable dog here, like a interface, we should have a place where we define this, right? Like can you show me that interface as well? Guys, first of all, we need to I need to at least see this interface. Like I can understand the comparable interface fully without a doubt. But an interface with a generic type, uh, like this is the farthest point I can get. Direct answer. Direct answer. You asked to see it. So let me show you. Here's the real comparable, straight from the Java development kit. Like a comparable. Oh, guys. The comparable interface it itself, itself has this generic type alongside with it. So we basically uh actually this is not a class but an interface, I think. So basically uh basically I think we can create this class too, but uh we create this interface like a kinesin with a org, let's say org, I don't know. So it is an interface, yes, as I suspected, yes. Wait, what are interfaces in like layman's terms? They are on add-on blueprint. So what they are is basically there are some cases where you wanna make sure, like Americano, there are some cases where you just need to be sure about a class's feature. All right, let's call like a class, like a class. All right, class A, and you need to make sure that this class has a certain method. Let's say a method. Let's say method that sums. All right, you need to make sure that you have to have this method inside this class. All right, for these cases you just write like a implements and the interface name that this comes from. Let's say math, I say. This is why, and these interfaces makes this class A is A, all right, so that each time you see a math, like a math parameter, you can use class A. This structure allows you to use class A whenever you see a math. Let's say a method, all right, that takes math as a parameter, all right. You can now, since you implemented it, you can now use like a class A instance here. You can give class A instance while you are calling it. This is what it is. That is why you can inherit multiple. They are independent. Yes. So these can come helpful. All right. Like this is used widely. This implements keyword basically makes that class is a relationship, so that you can use it while calling some certain functions. This is quite important, all right? And now I see that there are some interfaces with generic type. So where do we exactly use that generic? Actually inside the method. So, and also Americano, in interfaces, you just declare the function, but you don't declare its implementations. As you can see here, we don't have the body part of the method of compare to method. It doesn't like, it isn't important, all right? What is important, like what important is, I mean, the important thing is basically when a class implements this class, you just write this code and add its body there. All right? Interfaces don't have the implementation, but the classes that implements those interfaces have it. All right? Like, does it make sense? I hope it does. As I also suspected that Java virtual machine or a Java compiler does something. What do you mean by something? That's the whole interview. I kind of partially get it. I know how it works, like a works okay says, but I will likely need to code a bit. And yes. Yeah. So one type parameter t, one method CMD click comparable in VS Code, and this is what you'll land on. Yes. Now, the three things you asked directly. Is there a non-generic version? Is there a non-generic version? No. There is exactly one comparable, and it's generic. All right. There is no separate plain comparable interface sitting somewhere. You can write the raw type with no generics, but that's just the generic one with its type info stripped off. A legacy escape hatch, not a different interface. Where is comparable doc defined? Yeah, so that's another question. Where is this defined? Nobody. This is the key misconception. Oh my gosh, guys. Misconception. To kill right now. Comparable doc is not a separate interface that lives in some file. It is the guys. It is the same comparable T above with T replaced by doc. The compiler does the substitution. Like, this is the key, guys. Like, this is the word I was looking for. I need it in its head. In its head. Uh, if laziness doesn't kill it first. Uh, Love generics and Elasto probably just a major bit. But yeah, I will try coding marathons like yeah. Next week maybe just a yes. All right. Wish you premature luck and support on that. If laziness doesn't kill for them, true, like me. Yeah. So yeah, like I am really pushing myself, guys. So I really appreciate you being here. All right, we are doing just great. And if you have any topics like a lead code, we will do like a lead code session, like a lead code streams, object oriented streams, C# streams, Java, Python. Like today we didn't start studying Python, but I guess maybe in any few hours we can start Python too. Thanks to for being here. Thank you. You are just great, guys. You are just great. Not great, great. Android Studio Streams. Yeah, I guess we can do that. Like, do we need to run Android Studio? Because can't we do it just using VS Code? We can do it too. But I just don't want to run Android Studio because it uses so much RAM. I guess we can use our VS Code because as far as I remember, we can do it. Like, I am like I what that mean? It just sucks at everything. Yeah. It just sucks everything. Yeah. It uses maybe like a 6 or 8 gigabyte of RAMs. What that mean? Like Android Studio, where you create mobile apps. You know. So guys, the comparable doc, like we basically don't define it anywhere in our code. Or do we? It's the same above with the T replaced by doc. The compiler does the substitution in its head, it does this substitution in its head, basically, as the AI says. All right, in its head. Yeah. All right. You have already seen this exact mechanic. Your own ArrayList PC. Oh, from the interfaces topic. Was ArrayList an interface, guys? I thought it was the implementation. ArrayList PC, ArrayList string, comparable doc. Oh, all right. Like ArrayList PC does make sense, but comparable dog doesn't that much, but now I see, all right. One array list E class, E filled with PC, same class, E filled in with string. The array list PC isn't a class someone wrote. All right. All right, all right, all right. We just while instantiating this, we basically put it. We don't write. So, guys, isn't it just beautiful that without even writing the class, we can we can create a list of it. I know, like, of course we have that class, like a PC class. I don't know, guys. Um, so isn't a class like this? Obviously, isn't a class. Like array list is a class, PC is a class, but together the place where it is defined for dog is your own implements clause. Clause. Hmm. All right. You pick t equals dog right here. T become dog, so the param is dog. All right. When you write implements comparable dog, you are the one choosing t equals dog. That choice is what forces compare to take a dog. Back to you. One check before we move on. If a class instead writes implements comparable animal, what type must its comparative method take as a parameter? Of course, animal. Of course, it's animal. Exactly. Compared to animal, now hold that thought. It's the whole trap. Here's the setup. Animal implements e this interface. All right, and dog extends. Guys, I should I should draw it, guys. Without the visuals, I don't understand anything, guys. So like a dog extends animal. So there's a dog class over here. There is a animal class over here. All right, extends and animal implements. All right, so this animal class also implements comparable this thing. All right, so there is a relationship over here. This is just fine. Um, yeah. So yes, we have this. So animal implements yes, yes. So I guess we need to focus on this part. So dog extends. No, not implements. Extends. Dog extends the animal. Yes. Dog writes nothing new. Just inherits from animal. Yes. Question, guys. Question. And this is the exact line from the screenshot. Dog, dog inherits dog inherits this method from his parent. Yes, it did not write its own compare to method. Yes, because it inherits from its parent. So fill in both blanks. Dog is dog is comparable. Like a dog is like I don't want to look at the don't look at the below side. All right. Let me even copy that part and think don't look at it, guys. So we dog inherits this method like a compare to. Yes. From animal. Its parent. It did not write its own. Yes, because like it doesn't. It can, but it doesn't have to. Dog is like a dog is animal, man. Why? Like a dog is no. Yes. Like dog is animal, guys. Right? Because it extends. Dog is also is comparable, like a comparable. What was that? I forgot. Comparable animal. All right. Comparable animal. All right. So dog is animal. I think, guys. I think. I am not sure. Dog is animal. Dog is also comparable animal. Uh, which interface did it actually inherit? Like this interface, it inherited. Dog is not blah blah. Which interface does it not implement? Uh, like, is it comparable dog? I think yes. Like this is the answer. Like, uh, it is not comparable dog, but it is comparable animal. What do you say, guys? Like dog is comparable animal since its parent is comparable animal, but dog is not comparable dog. What do you say, guys? I was midway to typing that when I went AFK. All right, all right, no worries. I guess this, guys, like dog is not comparable dog because like it didn't implement it such an interface, but it extends animal class, and animal class implements comparable animal. So basically this makes dog class is a comparable animal as well, I guess. This is my final answer. So dog is comparable animal is not comparable dog. Yes. That's it, bro. Thank you. You just stated the whole screenshot in one line. Dog. All right. So, all right. I understand. Dog is comparable animal, not comparable dog because it inherited compared to animal, and it never wrote compared dog. So now, why should you care? This is where the scary bound comes from. Let's build the max method. What does comparable do? Um, like I don't know, but it's a method in the interface that we implement. Comparable allows you to use accuse. That's literally it. All right, all right. So we basically implement comparable, and then when we like have instance of our class, we can call this accuse method. Thank you. This is where the security bound comes from. Let's build the max method. All right, so now we are creating max method. The security part, got it. So guys, we have a method that takes this as a parameter, and I see that Oh, now I see. Now I see, guys. Like the thing we extend is a class that implements this interface. Like now I see, guys. Do you see it too? Like I still don't understand this part, but at least I can see that we like I guess T is a class that extends a class that implements this interface. All right. So we are basically looping through the items we have, like we are getting from the parameter, and what we do is like a oh that makes sense actually. Like now I started understanding. All right. We have a max method that takes this as a parameter, and then what it will return is like a I don't know what what it will return, but at least I can understand this part. Like a T extends a class that implements this interface. Nice. So we basically loop through the items that are coming from this list, and we basically call this compare to method. Why? Because we know that T, guys, because we know we can call this method. Why? Because we are extending this interface. Like, of course, we are not extending this interface, but we are extending a class that implements this interface. So basically, this move makes us able to call this function, which is compared to, all right? Because each item in this list is this, all right? I explained it before. So we compare we compare the item with the best one, and if it is bigger than 0, then it means that we find the the next best, so we update the best. So this is we know this from other LeetCode problems. So now it makes sense, guys. Now it makes sense. Read the bound out loud means T must be comparable to its own exact type T. Like I didn't interpret this like this, but I just thought that like a class that extends a class which is itself basically. So we are telling here that we are a class that implements like that we are implementing this comparable, and that's all. Right? Am I wrong here? Now the question. All right, all right. Enjoy your meal. Thank you. We've gone so far together. Thank you. Enjoy your meal. Works okay. You want to call. Now the question. You want to call like a dogs over here, and we wanna call the max like a compiler tries t equals enjoy t equals dog. With t equals dog, the bound demands dog must be also comparable dog. All right, all right. So the bound demands, guys, demands. So it says that we should implement this interface. Based on what you just told me about dog, does dog satisfies comparable dog? Will it this like if it implemented this interface, then it yes. But it says it will fail, dog is not comparable. Oh, like yeah, so here dog didn't implement this comparable, so it won't be able like the compile. Yes, yes, it will fail. Yes, yes, you guessed it right, Americano. Like I for for a second I forgot what we were doing, all right? Like like we had dog and animal, animal extends animal, like a dog extends animal, but like animal implements this, but this means dog implements comparable animal, not comparable dog. So if you try to call this method, the compile like it won't, like our code won't get compiled. Yeah, I guess we got it right. Like we got it. I guess we can continue now. Also loving the stream. So I am loving the stream too, guys. Like we are doing like a we are going like a we are flying together. We are flying together, all right? Like these topics are hard, all right? Not easy. But studying with together, now we handle it, guys. We handle it. We are going fast. Like of course it's been some time, but believe me, we are going fast. All right. These stuff is like a are like a senior or mid level. Like I don't have a Java experience at all. All right. Learning hard topic is the better with different perspectives. Exactly, man. Exactly. We are gathering our knowledge, and then we are building like our building together. Apes together strong, guys. Don't forget that quote from a movie. Um. So right, it fails, and that's the real problem because comparing dogs is obviously legal. Happily accepts a dog. Dog is an animal. The bond is just too paranoid. It demands comparable dog when would do perfectly. So let's loosen it. Look at what dog actually has versus what we demanded. Dog has comparable animal. We demanded comparable dog. Yes, has like do you see the keyword here? Has. Since we extended. Yeah. Like dog extends animal. So dog has, I think, animal. I don't know, guys. Like we say that like a dog is an animal, and also we say dog has an animal. But I guess what it means is dog has this interface since its parent implementing it. Animal is super type of dog, super type, alright. So the fix is stop demanding comparable dog exactly and instead accept comparable to dog or comparable to any ancestor of dog. Like this term made me think, guys, the super keyword that we have studied. If you want a comparison to dog, just say you want set T to also super on dog. This naturally resolves the animal and dog requirement. Yes, I will understand what you just said in a minute, all right? You've seen the wild card. That means this type or any super type of it, you literally just wrote, uh, yeah, T or any super type of T, yeah, T, T or any super type of T. T or any super type of T. Yes, the parent chain. Fill the blank. Oh my gosh, like how can I turn the suggestion part off in Cloud Code? In terminal, you show suggested thing, and I wanna turn it off. fill in the blank in the bound. So static t extends. So uh, I don't know. I don't know, guys. It says, like, what should we write here? Like, T is a class that extends, like, should we say dog or something? Like a T or something? I guess T. We should write T. But didn't we have T over there? Like, actually, let me look at the yeah, we have T. What was our problem again? So we have animal that implements comparable. We have dog, and dog inherits this function, but can't call it with itself. Extend keyword of T, since we need the super type of T. Extends keyword of T. So you are saying that, like, what should we write here? What should we write here? Like a extend, like a extends T, like a or only T. Like, we have, like a, let's say we have list of T's. uh t extends comparable T super dog. Oh my gosh. T super dog. uh comparable T super dog means we accept the parent of dogs, right? We accept the parent of dogs. So if we put this, we basically accept uh, the parent of uh, I don't know, this maybe, I don't know if this is the animal case of gosh, I mistrusted. like I can understand if we type T here, like there is a class T, and it extends a class that implement T. So T is basically implements comparable T. I don't know, man. I don't know. Oh my gosh, guys. Oh my gosh. Remove. Come on, man. Anyway, even I couldn't delete it. So T extends comparable extends. So I don't know, man. I don't know. Like, what we have, like, for example, like, we have, let's say, list of T. We iterate each of them, and we can use compare to on item T, like I mean like a type T, like to be like for us to be able to call this method, we should have the definition of it. Definition of it. Like we should implement it. And here like means T must be comparable to its own object type. Yes. Like this means class T should implement this interface. Like if T is a dog, dog should implement comparable dog. That's it. Like guys, like let's go step by step. All right? Step by step. Come on. Like this is easy, man. So like this tell us that we have a class T that implements comparable T, all right? Like this is it. This is it. So that we can call this compare to method, because without it, we don't have the definition of it. So things get complicated when we have a class that extends T, I guess. Like let's assume you have a class animal, and this class implements comparable animal, like these implements, all right? And there is a class like a dog that extends animal. So now we have a gap. That gap is that dog class has the function of compare to coming from its parent. But if you do something like this one, all right? Let's say you iterate through the list of dogs, and let's say you try to call this method, all right? You are gonna fail, man. Why? Like because this method requires the caller to have the same type. Like dog class should have its own compare to method. I mean, it has, but it should like a dog class should implement comparable dog, all right? Should implement these guys, should implement this, not comparable animal, should implement this, Since it doesn't, we fail. Could you ask Cloud to rename the T? No, like we shouldn't. I mean we can maybe, I don't know. It doesn't has to be a single letter. Yes, but like we should be familiar with it. But won't using compare on your extend yes, that's an error. Actual, yes. Yeah, so comparable T also doesn't work. At minimum, it should just equal itself since extends ask for minimum including itself. Isn't that because compared to only true if for animal comparison? It can't compare dogs with info, just animal info. Actually, yes. So like dog class basically implements a compare, like a comparable animal interface. because it extends animal class, all right? It doesn't implement comparable dog interface, so it fails calling this because this is a special method. This is a special method, not a normal method. This requires the caller to have to implement comparable with its type, All right. Now let's continue. So the question it asked was this one. Which wildcard expresses T or any supertype of T? Like if it's a supertype, then we use super key, like a super. I mean super T. I think this is the answer. Like like we should add here like a super T and question mark at the beginning, right? Like this is the answer, right? Because the card says T or any supertype of T. So T or the parent. Oh yeah, it's T extends comparable. I don't know, guys. I think this is answer. Like, all right, all right. I guess it works. Okay, you also said this, right? Now I understood. Now I understood. Because like it literally says here. Like I don't know the reason, but it asks us like the question already asked this T or any supertype T. So like the answer for this, I mean, is this. We basically we are basically T class, and we accept our parents. We go upward. Why not inside comparable if it can use a question mark and any supertype? It is question mark super T. Yeah, yeah. Why not question inside comparable? Which comparable? Like, like, like we are using the what I wrote here is here, like this part. Here we write, I mean, I suppose super T here, like this part, Americano. Oh, okay, my bad. All right, all right, all right. Yeah, yeah, yeah. This part. All right. Um. Uh, Spinner. Yes, this is spinner tips. The hints that appear next to yes, yes, yes. No worries, no worries, man. Like we are handling senior level topics. That's the answer. Full bound. Static T extends. Yes, yes. Now read it back as a sentence. T must be comparable. Like guys, like this basically says that a class that implements like a comparable T interface. All right. Like this looks like a fancy, but all it says is like imagine a class T that implements işte comparable comparable T. All right, so like this is what it is. Like T must be comparable to T. So like, all right, or to any super type of. Uh, all right. You no, sorry guys, so sorry, so this part, like this full part, t extends comparable. All right. Yep. If, for example, t was integer, this sentence would just say that this would work. Given integer is comparable to any integers and numbers. Yes, integers and numbers. Yes. Let me let me copy what you just said. Yes, definitely, brother. Uh, if, for example, t was integer, this sentence would just say that this would work given integer is comparable to any integers and numbers. Like the parent, like a numbers, objects. The other parents. Yes, definitely, bro. Uh, uh, let's prove it. Fixes the dog case. Compiler tries t equals dog. The bound now ask. Like maybe I should take a screenshot of this too. Oh my gosh. Yeah. I love this teamwork. I honestly have not had such. Yeah. Me too. Mutually, man. Mutually. Me too. It is fun. Handling, understanding these stuff together. Um, dog has like a comparable animal. Bound accepts comparable dog, comparable animal. Comparable. Yes. Like this is what you just said. Works, okay? Like we write like a comparable dog, and what we get is like a making these types also available to call this method, like a comparable animal, which is parent of like a one ancestor, like a first level ancestor, and comparable object. So we can call this method using these dog or any ancestor. Yes, dog or any ancestor, dog or any ancestor, dog or any ancestor. That's the entire reason collection max in the real JDK is declared exactly like this. So public static, there's a class T that extends object class, and also a class that implements comparable interface, and like a implements like a same type or the parents. Like T is a class that implements comparable T, or let's say comparable T parent, or comparable T parent 2, comparable T parent 3. So yeah, this is what uh, this is return type. This is the method, and the method gets a parameter, and parameter type is again we use T and children, like a same T or children. We can give the same T or the children of T as a parameter, and what we return is like a class T that extends object and object. Of course, every class extends object class. what we return is a generic type T that implements comparable interface comparable T or parent of T, I think. Like it should implement the comparable T or like and or I mean parent comparable parent, let me say. Like maybe I should take the screenshot of this one too and assign also some colors. And this one. So all right, the comparable, like a comparable super T, is there specifically so subclasses that inherit from parents still learn. Feynman check. 2 sentences. Your own. Oh my god. Still, I can see the suggestion part. Why does T extends comparable T reject list of? All right. So T extends comparable T rejects list of dogs because dog extends animal but doesn't implement the compare to method but it gets this definition of this method from its parent, but it doesn't define this method by itself. And this phrase rejects because it basically says that T should be a class that implements comparable with its own type. With its own type. Your second question is, what does adding like a question mark super T change, and why does that let dog through? That is a good question. Like question mark super T basically makes like a, it means that except T and its parents. So like I know that this means that this, but I didn't quite catch the part. Why does that let dog through? What do you mean by letting dog through? Like I understood the first, like a first question, but I didn't understand the second question. So I'm not reading what is written here. Because dog either is a parent or is T itself. Because dog either is a parent. Let me see. Let me see. Works okay. Your number one is correct. Yes. Yes. As you said, works okay. It is okay. Oh my gosh. My, like my shoulder hurts a little bit. Um, yes, you meant from its parent. I knew. The bond comparability demands a class that implements comparable with its own exact type. The dog only has comparable animal. Yes. Now, letting the dog through. There was a song like "Let the dogs out," right, guys? Let the dog out or something like that, right? Quite popular song, like a maybe 15 years old. I don't know, 10 years old, 20 years old. Let the dogs out. Who let the dogs? Yeah, yeah. Who let the dogs out? Who let them out in it? Yeah. Who let the dogs out? Yeah, yeah. This reminded me that song. So now letting dog through. Fair question. Let me make it concrete. Um, yeah, please. Bitte. Think of the bound as a bouncer at the door of the max method. When you write max dogs, the compiler walks dog up to the door and the bouncer checks its ID against the rule. So guys, there is a there is a there is a door over here. There is a bouncer. I think it is a man, right? And also there is a there is a there is a dog, all right? There is a dog over here, and yeah. Think of the bound as a bouncer at the door of the max method. When you write max dog, the compiler walks dog up to the door, and the bouncer checks its ID against the rule. Like, I have some drawing skills, guys. I have some drawing skills, all right? And thank you. Um, Old-bound comparable T. Uh, things started seeing Chinese again. Bouncer rule, show me comparable dog. All right. Dog shows comparable animal. Bouncer, that's not comparable dog. Rejected. Rejected. Compile error. Dog cannot enter. New bound. All right. So this was the our like the ones that the one that I know we understood, guys. New bound. Comparable. Like a question mark super T. Yes, yes. This means that T and the parents, like except T, and then implementations of parents, I guess. Bouncer rule: show me comparable dog or comparable any ancestor of dog. All right. So yes, yes. So like this is the interface. Like like this asks that either you should implement this interface compatibility, like either you should implement dog please, or if you have parent, I can accept the parent's implementation as well. This is what it says. Nice drawing, yes. Like I expect if you have the implementation dog, Mr. Dog, all right? Or if you don't have it, I don't mind at all because I will accept the implementation of your ancestors. Bouncer, animal is an ancestor of dog. Animal, like where does this animal came from? Like where did this animal come from? Animal, yeah, that's the flaw. Accepted the compiles dog enters. So letting dog through. The compiler accepting max dogs and compiling it instead of rejecting it with an error. Through the door of max, through the door of max, that's all it means. Does the call compile or not? The basically this magical phrase, guys, like this magical phrase says that I accept you. Like a girl, or like a girl saying her boyfriend, I accept you with who you are. Like, I accept you, dog. I accept you and your parents' implementation. Like this phrase means this, does mean this, all right? Does mean this, all right? Why don't what I did yeah, so dogs inherited compare now wallet ID. Before it wasn't. Make sense now? If yes, give me number two, again one clean sentence. What does guys, all right, let me see 2 hours. All right, that's nice. We can take a little bit of a break, but at least we understood, guys. Like things seem a little bit, like things started making sense more than before. All right, like it's all about, like the example we are now studying is about like a class that implements something and a for loop that tries to call a method that is not implemented by the subclass, but instead the parent class. And of course the subclass extends the parent class. All right, this is the first one, and the second one is like using this question mark super t, which makes make the compiler accept the implementation, like not rejecting the fact that subclass doesn't have the implementation, like it doesn't reject the subclass right away, but instead it accepts if if its parents has it. Like this is the core logic. Like uh like it is good, man. It is good. It's very nice. Now, how many minutes? Let's say 50-50. So we can maybe take a 25 minutes long break. How are both of your heads not hurting right now? My eyes are a little bit tired. Like, guys, because I actively use it and like generics. So perfect break timing. Yes, yes. But yeah, take a break now. Like break YouTube. Yeah, yes, yes. So so 25 or so you already have. Yeah, yeah. So works okay. No Rust very well, and he knows the inheritance, like this type of generics there, and he's basically amazing. Yeah, he also knows like a little Java. Yeah, yeah. And it was great. It was great. So we will take a break, and when we come back, we're gonna this was the subsection. All right. The main flow we had, I think this one, right? I think this one. We barely touched this, so I had to hunt. Right. Yeah, yeah. See you in a minute. All right. So taking a break for 25 minutes. Taking a break for 20 minutes. All right. So now, let me stop this one, and yeah. See ya, man. Where is the start break? Make it 25. Start break. All right. Hello, guys. We are back. We are so back. Are you ready to tackle with Python? Welcome, guys. Welcome. So let me, yes, do this. So, guys, now we need to, I think, like wrap up what we have done today on Java. All right. We can run our skill so that it will generate necessary files, and we can continue with Python. So we have collections copy method. It says like maybe we can create the animation later. All right. So let me like paste the image here, and then oh my gosh, yeah, open this. What was the where was our original file? I guess this was some. Now I need you to run the checkpoint skill and save our progress, because now me and my friends want to tackle Python. No more Java. The Python is our goal. We're gonna like learn some Python, all right? So what I need you to do now is run that skill and save our progress. We have studied generic type. We have studied like interfaces with generic type, like a comparable interface, and we studied also like a dog class that extends animal class, and that animal class implements comparable. So we have studied that part, and also you know what we have studied. So wrap up and create like save our progress. All right. Now it will summarize what we have done today, hopefully, and then we're gonna continue with Python. And like I know little about Python, like only knowledge of creating a for loop and maybe a while loop, and we can like create a folder, and we can ask AI to teach us like teach us some stuff. All right. And we can code some stuff, and also there is a framework called Fast API. All right. It is a well-known framework, so they ask whether you know that framework or not. Like it is same as Spring framework, like in Java. And all right, so we can start with the Fast API, I think, because we all know programming languages. But I will tell AI to design something for us, all right? Maybe we can go like on parallel, while in one session we iterate like we go through the concepts, like same basic programming concepts in Python, and on parallel we can go with Fast API framework oriented, basically. All right, and let the AI do its job, and maybe I just can like terminate this session. And also, where is my main? This is our main session. So I guess we have here like a maybe Python file or something like that. Yes, so we have Fast API and stuff. We have our topics. So I created these topics previously. We can pick one and continue. All right, this might be it for me since it is like 10 p.m. there, and we are having Java practical. We are having a Java practical. Yes, might get confused and start typing. All right. Fast API stuff. Oh, real sorry. We'll catch up Python through next week after this. All right, Americano. So good luck with your exams. We'll continue. All right, next week's too. I hope you'll get amazing exam. All right, exams. Yeah. All right, and even like I guess they are your finals, right? Like all right, summer will be like a crazy. All right, we like at the end of this summer, we are gonna be senior programmers. Also, thanks you so much for the stream. Yes, anytime, bro. This gave me a confidence boost. I didn't know I did. Yeah, yeah. Amazing. Thank you. I appreciate it. Summer will be a coding fest for me. Yeah, yeah. We're gonna be like a senior developers at the end of this summer, all right? Not even in the end of like in 1 month or something. To be honest, it's just what happens with teamwork. Exactly, exactly. Yeah, yeah. It is about teamwork. Exactly, exactly. Take care. Have a good dream. Have a good sleep. Good luck. Yeah, yeah. All right. And also, I guess I can start streaming like 4 a.m. in my time, or even 3 a.m. All right, just for you guys, so that we can spend more time. Because, yeah, thanks for joining by. Thanks for stopping by. Um, like because I love getting up early, and I love sleeping early too. I'll just be playing games and reviewing. All right. Do it, do it. Thanks for your time. Yeah, yeah. Anytime, bro. Anytime. Let's see. So, like we have lots of topics, guys. Lots of topics. So, I guess we can go in parallel. And we have Python and Python curriculum, and we have like I created these topics. All right. So variable types, collections. All right. So now, like somehow, I broken my VS Code. See you for for real for all right. No, all right. See you. Take care. Yeah, yeah. Take care. So, like, I click on this plus button, and it opens like this. I don't want this. So, like, what did I change? Like, oh my god. Maybe this one? No. Like, why this opens terminal on the right side? How did I like break this? Like, I configure terminal settings. Uh, it opens like on the side, but it should open on the bottom. I think it was like that before. Maybe I just can ask a cloud to fix it. Configure task, select default profile. That this is not it. So I click new terminal and it fails. Maybe I should just ask AI to handle it because it has right uh, property. All right. Now another thing, like I click on this plus icon and it opens the terminal on the side by side, but I don't want that. What I need is that is just like previous it opens like on top of each other, right? On the right side I could see my um, terminals. What changed and now like I I don't like it at all right? Like why this happens? Why it opens on the right side like this like this doesn't look good, all right? Or oh guys, oh my gosh. I'm sorry guys, like it opens correctly. Like the problem with that is just I just enlarge it too much. So we are all good. I think it created no like we can close that one and we can start studying Python now. So we have a skill now. Let me share the topic. Here we're gonna practice these topics that are listed in topics detail folder. Activate our study skill and create a progress file so that we can keep track of what we studied. All right. Uh, yes. Let me slide down a little bit. So this is This is one parallel thing. So the another parallel thing we're gonna study is studying Fast API framework. What topic we're gonna do? I don't know. AI will tell us. All right. Now create like activate our study skill and create a progress document. I want to cover all of these topics listed here one by one and use pedagogical approach to teach me and create connections between them. All right, so be pedagogical. To be honest, I ain't that knowledgeable on REST API, so excuse me if I no worries, man. We are learning together. We are learning together. Like we are working as a team, and we have AI on our side. We have internet on our side. So almost there is nothing could stop us. No. There are lots of things that could stop us. For example, electricity. But that's all right. That's all right. Yeah, teamwork. Yeah. So now AI thinks, and AI is gonna find the correct thing to focus on, and we're gonna focus on that topic. And while it does its thing, where are we? Like we are in Java folder. Let me open my Python folder and create another folder. So create our first mark, and let's see. So it answered this one, so I can close that one too. Now seems very nice. Ledger created. Yes, resuming. I think I can also start my own tracking. Wonderful. So now uh, variables and types. All right. Variables and type. What we are practicing: declaring variables and converting between them. All right. Also have like studied this conversion, and we also learned that parsing is something bigger than just converting. Converting would seem like a loosen description. Converting between integer, float, string, boolean. The one idea: Python is dynamically typed. Dynamically typed. All right. Like we don't do it like we do in Java. The type lives on the value, not the variable. All right, we know that. First question to warm up, coming from Java, where you write like this one. All right, how do you write those same 3 lines in Python? Type them out. So let me open my application over here and open the Python stuff. All right, we know this, but like in Python we don't need that. I guess we don't need a string either. Oh my gosh. All right. And this one, I think. Will you use type annotation also? Will you use type annotation? What do you mean by type annotation? Print active true is not defined. What is true? What is true in Python? Like a this one? All right. Whenever I code up in Python, I use annotation. I don't know about annotation. What is annotation in Python? Python. Yeah, it is like a true, like a big bit with capital true. All right. Quick answer: in Python, an annotation, a type hint, is an optional label saying what type a variable, parameter, or return value is expected to be. Unlike Java, Python does not enforce it. It's a hint for humans. IDEs, tools like this one, never checked at runtime. Like you mean this one, all right. Like instead of name equals this one, Mahmoud, we type the variable name and then columns and then type. So in Java, type is in the beginning, but here it is after the variable. It is after the variable. So it is after the variable. So it is after the variable. It is after the variable. All right. In Rust, it is also like this. That's nice. That's nice. Print active. All right. All right. All right. After the variable. So it says like write those stuff up. So our down we've written. All right. So and also we have functions. In functions, what we do is like a definition, function name, variable, and then type. Variable and then type. And then these arrow keys represent like a meaning, what like means, what this method returns. And again, we use these columns. So each time after the variable, actually these columns for like representing like a curly brackets. Note, as set by Claude, this is a mere suggestion. Like warning. Python does not give a heck about the type. For humans. Annotations used properly. One Java habit leaked in the trailing. Oh, sorry for that. Sorry about that, guys. One Java habit leaked in trailing. All right. Python accepts them, but no Python dev writes them. All right. Also note to keep in mind everything is public in Python. That's interesting. There is no private. All right, that's even better. But I wonder how it handles encapsulation. We're gonna see. Now the second half of conversation. Integer parse int. Yes, we studied this early in the morning today. We have our integer class, and there this is what it returns, right? It returns an integer, and it takes a string. There is only one convention of prefixing. In Python, for example, indicates this var variable is private, but you said there is no private. What do you mean by that? You will usually see this convention a lot. All right. And also we have like a value of static method in string class that returns a string basically. It's a convention. All right. Let me see. How would you write the string 5 an integer? It only convey is private. You can still use. All right. That seems interesting. The string, So, how would you write string 5 to an int, an integer to a string? It's like stop sign. You can ignore it if you want, but anything occurs, it's your fault. That's quite interesting. So, what it asks is turn string 5 into integer, like a turn string 5 into int. I should think simple here, like maybe like I don't know, man. Maybe like this, or like a convert. I don't think so. Convert 5. In Python, you can just the class itself. In Python, you can just the class itself. It just integer. Yes, I got close. Integer string 10, like a integer string, let's say 5 over here, and let me even print that integer function. It looks like a constructor or something, and 5. Let's see what it prints. The 10 is the radix. Oh, all right. All right. So I thought you. All right. So like integer, like a string. All right. So string is 5 basically. So this is it. Oh, it is simple. Like basically. All right. All right. Like remove this part and run it. All right. Like it is so simple. So basically making integer to string, string 5. All right, this is simple. This is simple. Like we cannot distinguish, but that's all right. Yeah. So let me copy this and paste it and go. Both right. Integer 5 is 5. Same pattern works for making like a converting into float. The one gacha word knowing. Billion 0 is, I think, false, and this is false, and 42 is true. We got an error now. Oh, it is because the intent. Yeah, indent. So run it. False, true. Yes, as I expect. Why? Because like Python is simple, all right? We should think simple. Not Python has a concept of falseness, all right? Like this is quite logical, all right? Because if you need to make 0 like in Boolean, you need this is the first thing comes to my mind. You're gonna need it. You're gonna need to understand these others. Yeah. So these a lot. Yeah. Like it is a simple language. Everyone says that, but let's see. Copy that part and paste it. Oh my gosh, I started feeling tired. And at 6 p.m. like maybe another 50 minutes break. I feel quite tired right now, and my shoulders are starting hurting me. All 3 correct. Yeah. Basically done. Feynman gate. Explain in 2 sentences. How does Python typing differ from Java's? And what does an annotation like? All right. So let me take a screenshot and add it into our node. And this is our first node. Paste it over here and open it. basically non-zero numbers are truthy, and zeros are falsy in C. This is also true, like in C this is also true, but it's a bit more restricted. Yeah. So basically Feynman gate explain to us how does Python typing differ from. So in Java we like a strictly like it is strictly type. So we type like we code the type before every variable, whereas in Python we don't need it. We don't need that. But as my friend said, we have annotations, and we first like type the variable name and then column and then the variable type. But we don't need to do that. But it is for humans. All right. Like a Python is used in a like a ML AI. So and let me also open this one. And also hold on, guys. All right. Collections. That passes, you nailed it. Thank you. Tiny note. The word is static, not like I didn't say that. Static typing. Java checks types at compile time. Python is dynamic. Types write on the value. Your core point is exactly right. The annotation is optional. Yes, syntax is name, like a variable name and then the type. And it's for humans, tools, not enforced. Collections. Python's 4 built-in containers. You know these 3 for Java, so let's map them. Oh, wonderful. So take a screenshot and paste it over here. So we have array list. So we have like in Java, we have list. So do note functions are also types in Python. Functions are also types in Python. Interesting. Let me note what you just so oh my gosh, I should like update this code part. It opens every time and it irritates me. So we have like a hash map. In Java we have dictionary, so keys and values. So we should like maybe after this we can study like a dictionary methods, like how we add elements into hash map, how do we iterate through keys, how do we iterate through values, how do we find the smallest key, how do we find the value of the certain key, stuff like that. We have set, which which includes a number only once. Each number is unique basically. No directly equivalent. Tuple, and this is immutable. All right. First question: make a list with this one, and then add 4 to the and then remove the last element. Like the last or the first element. In Java, that's add and remove. Yeah. What are the Python names? So it says that I think create a list. Let's say 1, 2, 3, like 1, 2, 3, and it says that add an element, like let's say 4, and it says like do we have something like that, or maybe like a list remove like a remove 4. Yeah, I know what I said, of course, do not, because hash maps and sets use the same braces to represent them. The default curly braces represents an empty hash map, by the way. To get an empty set, call the constructor in set. We have pop. If you, yeah, pop would be great. Pop would be great. Like I was using pop in queues in Java. Yeah, like a add for, and then print the list again. Print the list again, and then pop, and then print the list again. Let's see how does it do. List add gives an error. Instead of add, do we put? No, add put. We add. We put like insert. No. Oh my gosh, like insert, put, add. Not list is a keyword. Oh my gosh. No. We should call it my list. Sorry. Like this may cause problems. Use list for list. Yeah. You are definitely right. Like I tried adding, like putting, insert. These are my intuitions. How can I add an element? Put, like put, add, insert. What else? What else we can use? Push. Oh my gosh. We can push to a list, we can add, we can put, we can insert, we can not extract, add. Like which operations we can use. Let me guys open my Safari. All right. Methods of lists in Python. Let's see which methods. Append. Oh my gosh. Yes, append. But we have insert here too as an element at the specified position. Oh. If we use like a insert and again maybe 2, or maybe even make it 0, can I? No. That you can use on list. So I think the correct method is append. Yes. So we append 0. So let's make it 4. We append 4, we pop. Like this pop method is used for queue, and append method is used in string builder. But do not Python do have default values. All right. For functions and such, default values. All right. What kind of default values? Let's say my list, like no, if I output the my list 2, I would if I print my list 2, I will see an empty array. No, should I instantiate it? Really? I thought Python handles everything. Let's see. Why? Oh my god. I thought Python could handle this because like it doesn't care about types. Yeah, basically it doesn't care about types, but it does care about if you initialize something or not. All right. So Python has some rules. No, I mean like a definition item. All right. So you are saying that definition, like definition, we use definition for function, and you are saying that that function takes a parameter called item, and we make it like the default value we have for function. Like let's print item, and let's call the function. Oh, it holds the reference, I think. Wow, interesting. This means if you don't give this item a value, I think it defaults to an empty array. All right. So you can assign some default values, like in classes in Java, we can do this too. We can assign some default values in Java, like in class variables. So we can do this for functions in Python. But I thought that, oh, I don't call the function. I print the function itself, so I should call the function. Sorry guys. And where is my, yes, my like R1, let's make it 100 and print. So yeah, so we can see that it prints 100. So basically our default value is 100. So if I assign 101 inside the function, yes. So if I give a parameter 102 is a parameter, what would happen? It will take like 102 as a parameter, and then inside it assigns. So basically I will see again 101. Yes. If I remove this part, I will see 102 because we have now a value apart from the default value. That's nice. Now we know how to initialize a function, and we know that function parameters can have default values. That's us. First question: make a list with. Yeah, we have done this. Append and for. Wonderful. Both right. No now dictionary. All right. Now dictionary. 2 ways to read a key. Like we have person name. Note that these items are statically linked. Very giant disclaimer. Note that this item is statically linked. Yeah, so like, what do you mean by that? Let me take a screenshot of it and paste it over here. Open it. Open our code. Take the screenshots. Open our app and paste as the related image. Yes, the default values. Yes. All right. I think I understand it. Let me open it. So now dictionary type. What's the difference between person city? So I guess we can just like copy this one and paste this one over here. It says that, like, what is person, by the way? Like, I don't know anything about it. Is it an array? Is it a variable? Is it an array that has like a name as a string? Now we also use get function. For example, if you append to a default hello, is it a record? Welcome, Mark. Mark for what do you mean? For example, if you append to a default, yeah, welcome to stream. It is not a record, it is live. We are currently live. For example, if you append to a default of hello somehow, then on a text next call, I think I see. Mark, sorry, in Python it's called struct. If you append, it's called class. Why are you larp? What do you mean? We have a person. We have person.get. Like, what will happen if I use person.get and maybe name, and maybe even print that? Like, what would we see? An error, of course. Why? If we like create a name with like a test1, or let's say value1, and again error. How do we create hash map in Python, basically? Like a hash map, hash map is the term in Java. We have dictionary. Do we need to use this term like a dictionary or something? I guess yes. Like the error changed, kinda changed. Dictionary in Python, yes, hash map. No, it is a map. Like hash map is dictionary. Like hash map in Java equals dictionary in Python. So what I'm trying to do, like here, is a dictionary. Yes. What I'm trying to do is like creating a dictionary with key name and value1. What do you mean by hash map? Maybe I should remove this part and try printing that. All right, again an error. Like this is something else. So dictionary person. I guess we are like I'm making a mistake. All right. Maybe I should just look up how to create a dictionary in Python. My dictionary, how you instantiate a dictionary, he mean. Oh, so we should should we like instantiate a dictionary? Yeah, I guess. Like a my map equals bracket like a key comma value 1. Am I doing correctly? And if we change this key to this key and I remove that part, like you are saying that I should instantiate like a Like I know there is no new keyword in Python. Oh no, like this one. Print person dot key gives, and there is no person here. My map we have, and my map JavaScript, yeah. like like I have a dictionary obviously here, and you guys said that I should instantiate it, so I created, like I used the name of dictionary over here. Like this is the key and this is value, obviously. What else do you want me to do? Like let me look at it. Oh, I should use curly brace. Oh my gosh, I thought. I guess this like this kind of bracket is for list, but for dictionary we should use curly brackets. So you are saying that I should use this and key, yeah. So where is the value part? Where is the value part? Like with comma? No. Like if I use comma, then we go to the next element. Oh, we use column. That makes sense. Like these columns, and then like it's like JSON, right? Key and value 1, and let's call it key 1, and then comma, and then create key 2, and then value 2. That's nice. And if I call this my map dot get dot I think key 1, and if I put this into print, and if I try to print that, you got it. If I print that, all right, so we can remove that. Like I thought, hold on a sec, what happens? Like why am I seeing that? But now we're gonna see value 1. So basically, so like I thought that like the AI says like that we have a dictionary. So I thought that I should use this keyword while creating one, basically. But I guess we don't use these keywords anywhere at all, right? We don't call them. We just use the right side, like this one for list, this one for hash map, this one for hash set, this one for, all right. So now what it was asking is now dictionary. All right, so now I think yes. All right, so now I should just copy this one, remove that one, and paste this one. This is my hash map. That's nice. It says that it tries to reach this key, so it will print this one. Oh, I see. So like there are two ways for reaching keys. One is like direct, one is using get method. And let me see. So we have like, let me print it out, and also let me print out person dot get dot age, for example. Let's see. We got an error. Should I use like this single quotes or something like that? No. Person dot get, maybe 1, maybe numbers. Is it what it is? Maybe numbers? No. Like a 0 or something? Like if like no. No, it gives error for this one. All right, so but it gave none to us. So I guess, yes, all right. So I should use the key. All right, awesome, we got it. So basically creating dictionary is this. So now it is time for learning a for loop. Get method gets something or inserts a default value, the second parameter. So you are basically saying that if I remove that part and as a second parameter, if I gave like a maybe 30 or something, you are saying that it is gonna print 30, right? Yes. All right. All right. What is the difference between like a direct reach and the get reach? Oh, so the second parameter you mean this one? All right. So get method has a second has a second parameter. So we have this thing in Java too, like a get or default. In Java we have get or default, like a map dot get or default, and we use key, let's say key, and then 0 if there is no value at the position of key. It's literally get or default. Now you mentioned it. Yes, get or default without the default, like without we explicitly type the default part. So under the hood it handles. That's nice. That's nice. The difference between like a direct reach and this reach, when city isn't in the dictionary coming from Java, think about what hmap.get does for a missing key. So when we find when we have a key that has that doesn't exist in our hash map, it returns, I think, -1 or null, I don't know, but it fails. So this isn't something we want. So we use get or default. And as my friend works okay said, um, like the get method in Python, it takes two parameters, and then the second parameter um, is basically putting a value, like a default value, if that key doesn't exist in that map. Let's see how will it answer. It returns none. In Java, right idea. Oh my gosh. But let me sharpen the contrast, because Java and Python differ here. Java.getCity returns null. Quietly, no crash. All right, no crash, but null. No, it says null. Python rises key error and crashes. Oh my gosh. Like, how on earth? Like Python should be like a friend, like a close friend, like a, I don't know, like a easy. But instead Java doesn't get crashed, but Python does. So why? I thought Python handles everything, no crash, no errors, because it has some default values like a 0, none, null, error, that kind of stuff. But it says that rises key error and crashes. Well, they said it was easy to learn, not that it was easy language to master. All right, all right, all right. That makes sense. That's fair. That's fair. That's why .get matters more in Python. Bracket access. This is what it's called. Bracket access. So let me open my broken my broken app, and open this node and paste it over here and save it and click it. Click on this. Yeah. So get method is kind of dangerous. That's why that get matters more in Python. Bracket access on a missing key is an exception, not a null. So this what? I don't get it, man. Like, it literally says that Python persistently rises key error and crashes, not quite null. And below it, it says that's why that matters in important bracket access. Oh, bracket access. This is bracket access, right? That's why, oh my god, you had the second parameter exactly right. It's the fallback when the key is missing. Is a parenthesis, not which is a bracket. Oh, we are using get method. Oh, sorry. All right. So get method is kind of same, kind of smart. You can also set an even default value, which is awesome. But the direct access is what is dangerous. So I would use get method anywhere I need to get a value from a hash map dictionary. So I wouldn't have any problem at all. All right, problem is solved, guys. Use get whenever possible instead of using a direct access. In Rust, bracket access is also dangerous. Oh, that's nice. That's nice. All right. I know that in C is like a reaching for certain memory addresses is also dangerous. So you should know what you are doing. All right. Use get, guys. Get is safe. Get is smart. Use get. That's awesome. You had the second parameter exactly right. It's the fallback, yeah. And now set and tuple quickly. What does this print? I mean, if you know a key and value exist, use sure. So now we are, I think, doing like a set. And why can't you do on a tuple? Because it is immutable. Tuples are immutable. Oh, all right. I can accept that. Exactly. So now, guys, we are going Fast API. And so, guys, are you ready? Also note, sets are like mathematical sets. You can do standard set logic. All right. Resuming Fast API projects. Just started. 0 out of 20. Before any code. Anyway, Fast API, yeah. So Fast API. Let's start. Before any code, one quick thing about why we start here. Project 1 is the project. It says project, which these are projects. All right. Project 1 is the data spine, the exact pattern you built now. Asynchronous session plus Alembic plus a clean split between ORM models. And like I've heard this term before, but I don't know what it is. Get reused, untouched. In projects 3, 4, and so on. So we are not building a notes app. We are building the Foundation 7 later projects silently assume. Like a Pydantic. Like this one. Now the confidence audit. This is your map. So be honest with me. Be honest with me. For an asynchronous CRUD API, Pandatic schemas just mean conventional Python code. All right. All right. SQL Alchemy asynchronous session. Wait, wait, no. And NVM. Never mind. Asynchronous session, asynchronous with await session. It's a blueprint actually. All right. Like generating, running a migration instead of why you keep not create, not update, not response separate from. It just tells you what form of an object to express. Like it is like blueprint in Java, I guess. Like in Java we had like a class variables. We call them as blueprints, right? Track activated is live in the project folder. Yes, resuming Fast API projects at interface. He said interface. It's an interface. All right. Like with all 20 projects laid out as a pedagogical ladder, not 20 random apps. The key thing I baked in, every project's row says what's new, what it reuses, so the connections are explicit. You can scrap it anytime. Resuming, yeah. So like I guess we're gonna learn CRUD operations, guys. Like create, read, update, and delete. So this is basic, so we should learn it, all right? Before any code, one quick thing about why we start here. Project data spine. I love CRUD. Like asynchronous session, it says Alembic. I have made a couple of terminals. That's nice. A clean split between ORM models and interface schemas. Get reused untouched in projects. Yeah, I don't know, guys, what it says. What does it say? So asynchron with await. All right, we have this in Java. ORM means object resource management, by the object resource management object. So like in Python, do we have objects like classes, and we create like objects? I heard that Python is object-oriented programming too. I just learned about ORM and I already forget for SQL. Wait, hang on, no. It's a relational relational management. It's object relational mapping. all right. It's object relational mapping. We're gonna see what it is eventually. So we have asynchronous session, asynchronous with like some sort of methods. Alembic immigrations, generating and running migration. Like this isn't pedagogical, any pedagogical. Sorry, I'm getting confused now. Spent way too much. yeah. Two questions. Which of those five feel solid? Any of them, man. I don't know any of them. Which are fuzzy? Every one of them. I heard so Mr. AI, Mr. Cloud. I don't know anything about Fast API. The only thing I know is in Java we have like a Spring Boot framework, and its equivalent in Python is Fast API. And the companies want me to know, like companies want us to know this framework, all right? And we need to learn it fast in an efficient way, and so that we don't forget in the long run. So that we need to internalize them. You dump some terms, some convention like a asynchronous session, asynchronous with, await session execute like a methods that I've seen for the first time. Like I know programming, or I know Java and C Sharp and JavaScript, uh, but I don't know Python and this framework. And I know how to create for loops, while loops, and how to create like a function, like a function, and how to create a map and a set, how to reach a value like of a map. Other than that, I know nothing, zero. So how do you plan to teach us? So let's see how it's gonna teach us, guys. Let's press enter. Like this shouldn't be hard, right? I trust my skills, like a cloud skills, all right? Because it really behaves such that it is a real teacher. Changes everything, and it's the most useful thing you could told me. Yeah, I overassumed. Yes, you did. Let me throw out that audit. We start from zero, and I mean zero, literally zero. Here's my honest read. That spec for Project One throws Asynchron and SQL Alchemy, Alembic at you all once. For someone who's never touched Face API, that's a deep end of the pool. We're not starting there. How I'll teach you. Four rules, and I will hold myself to them. Yeah. Every new thing is anchored to Java Spring Boot first. You already know this stuff. You just know it with different names. Face API is Spring Boot with the boilerplate removed. My job is to show you this Python thing, that Spring thing you already do. Then you'll go, oh, that's it. One tiny program per concept, and you run it yourself. No walls of text. You type 10 lines and run it, see output. That's how it sticks. Yes. You explain it back in 2 sentences before we move on. If you can't, we stay. All right. This still not forget in the long run part. We added project 0 before 01, the warm ups. Each is 10-line program that runs alone. This is the part that makes it internalized, small, named, complete. One endpoint returning JSON. Alright. A path, query parameters. Alright. A request body with validation. Alright. What asynchron await even means. Java threads, but cheaper. Alright. So guys, one day we should do like a stream dedicated for threads and processes in Java. This is also asked for mid-level and senior level question, like jobs. I don't know that much. I love and hate asynchron code. I hate. I love and hate asynchron code. Love and hate relationship. Talk to database, the simple way. Only after those, yeah. So all right. Alembic is flyway liquid based migrations. It gets the job done, but damn, is it like it is frustrating in lower level like C or Zik. All right. Even Rust has ugly syntax for asynchron. Oh my gosh, I wouldn't guess you would set that. If you say so, I guess it is really, it has really bad ugly syntax. Environments ready. Face API, yeah, like this one. You guys said that, told me that, like it is like an interface. That's interesting. I love using asynchron in the language. One language that has good syntax is Golang though. We can, I don't know guys, like we can, like, if I don't know if we can like do that, but maybe like I would be happy if we do like some Go streams too. Like I know like literally zero, but Go is popular nowadays too. Like maybe we could try creating some projects using Go. So your first endpoint. Here's a Spring Boot you already write in your not that way, but a REST controller, yes. Get mapping, yes. A map, like a key string, a value string, yes.